Hey everyone, my name is Zach, and I wanted to welcome you to the JavaScript Bootcamp, or whatever I call it on the title of the video. Ultimately, this course is going to take you from complete beginner, haven't written a line of code in your life, to having at least a firm grasp on what is a programming language, what is JavaScript, and how do I actually use JavaScript to do something useful. Be sure to check out the description. I've got timestamps so you can jump around this video, and I've also left a link to a page that will give you a bunch of resources and maybe even some next steps on certain topics if you want to take them a little bit further. Before you dive into this video, since a lot of people might just be starting their software development journey and are just learning how to code, just wanted to leave some words of encouragement. This stuff is hard. It's really, really hard. And when you're first starting out, a lot of it is not going to make any sense. So I just wanted to encourage you to stick with it, even if it doesn't make sense. Go through all the code examples and just spend the time with it until it starts to click in your head. I promise you it will, and I promise you you'll be left with more valuable skills after you make it through this. One of my primary reasons for learning and teaching myself how to code is so that I could build whatever I wanted to. I didn't want to be limited by anything. And I hope that this course gives you that power as well and puts you on that path to being able to build the things that you want to. Best of luck, and I'll see you in the course. I want to start here with a quick win. I want you to see the power of code and see what we can do with it very early on so that you can kind of have that confidence to know that you don't have to go through, download a bunch of crazy things onto your computer and write a bunch of crazy lines of code in a terminal to actually do something cool. Since we're going to be jumping into code here in the first lesson, before you know anything about it, you're going to be confused, and that is very okay. Don't worry about that. I promise we'll go back through everything that we talked about in this video, and a couple videos from now, you will probably be able to actually do what we're going to do in this video. So if you're a fan of the Netflix series Stranger Things, you might remember in the first season, the kids were talking to their professor about this thing called the upside down. And basically what the professor was talking about was a lot of physics concepts and stuff like that. But basically he was talking about this tightrope where there's a human on the tightrope and then a flea on the tightrope. And the flea can actually go around this tightrope and see all different sides of it, but the human cannot. And that's ultimately what we're going to be doing throughout this series. We're going to be looking at something that you've spent a lot of time with already and actually go to the other side of it and understand what's going on behind the scenes. And the first thing that we're going to touch on is something called browser developer tools. Now, you might have seen something like this before. This is called a web browser, and you probably use it every day of your life. But have you ever right-clicked and clicked Inspect Element and gone into this tool on the right where there's all these different applications that you can go through to see what's going on this web page? As a full stack web developer, or more particularly a front-end developer, which is kind of a subset of full stack development, you're going to be using these developer tools a ton. And you're going to get very used to them. And in this video, I actually want to walk you through the most common parts of these developer tools and actually write some code within them to give you an idea of what this is all about. The first thing I want you to do, though, is download the Firefox web browser. So just type in Firefox download, go to the download, and get that onto your computer. I want to be working with the same tool across the board. Although you have developer tools within any other browser, whether that be Edge or Chrome or Firefox, you have these developer tools there, but I want to make sure that you're looking at the same thing that I'm looking at. And Firefox is actually a great web browser for developers because it has some really advanced developer tools, and in my opinion has probably some of the best developer tools of any browser. So get that downloaded, and then once you have it downloaded, go to google.com and take a look at this pane on the right. And if you don't remember, I just right-clicked anywhere on the page and I clicked Inspect Element. Now the first thing we're going to talk about here is the inspector. Now the inspector is probably the portion of developer tools that you will become most familiar with. And the reason is it allows you to basically, as you might expect, to inspect the page that you're looking at, or the web page. So as I'm scrolling over these different lines of HTML code, you'll see that different parts of the web page are actually highlighted. And I can click down and drop this down and get more specific at what I'm selecting. So I can basically see what's going on in this web page. And then if I go to the bottom here, these are all these stylings or the CSS styles that go along with the HTML. Again, don't worry about this. We're going to get into these, languages later into the course, but for now I just want to show you the landscape. And to really show you what's going on, let me open up another tab here. Go to google.com/images and let's just type in dog. Let's grab any dog here. I like this one here. And we want to open this in a new tab. So let's say copy link location. Now we come back here to the page and let's click this button up here. This is kind of our selector for different elements of the page. And let's click on this image here. You can see at the top there, well, I can't show you, but there's an IMG or image HTML tag. Let's click that and then let's go into this source attribute and paste in that link that we just grabbed of the dog photo. Once we press enter, you'll see that our web page has actually updated, and we can close the developer tools, and google.com just got a makeover. Now, this is not permanent changes. Obviously, this would not be permanent changes, but we can right-click, inspect element again. Let's click on the image, and let's make this a little bit smaller. So let's put a width of 100. And now you can see that the dog is a little bit more styled on Google's homepage. But as I said, this is not permanent. These developer tools are great because they allow you to make very temporary changes to your web page. So you might have the code that you're writing, on the back end and in your terminal or your code editor, and those are the live changes, but you can come here to just make little changes. Like you saw how the picture was too big, so I went in and changed it to a different dimension, and I can kind of test out these different changes. And the power of this is just, it allows you to do things in real time. But the second that we click refresh on the page, you're going to see that it goes back to the original web page. So you are the only one seeing these changes within the inspect utility. Nobody else sees them, and the changes are not permanent. Like I said, we're going to be spending a ton of time here, so don't worry if none of this really made sense. But as you can see, we're clicking through. We can click on different elements, so let's maybe click this little icon down here. And you'll see how powerful this is once we get into this stuff in the bottom right, where we can see the box model, and we can actually look at the document object model, or the DOM. We're going to get into all of these things. But the next thing I want to show you is this thing called the console. Now the console is probably the second most popular tool within developer tools, or at least in this series we're going to be using the console quite a lot. And what the console is, it's actually called a REPL, and that stands for read, evaluate, print, and loop. Now you don't really need to know that. What I want you to remember about this console is two things. Number one, it allows you to write JavaScript. And number two, it allows you to actually modify the document object model, or the DOM. And we're going to talk about that a little bit later in the series, but these are the two main things that the console allows us to do. And to show you, I'm going to just give you a short example of how we can use the console to make some of the changes that we are also making here in the inspector. So if you remember, we kind of changed the image within the inspector. We can also do that within the console. So let's grab a different dog picture here just for fun. Grab this one here, I like this, and copy the image location. And all that's doing is just copying the actual file that we're looking at. From here, we can go back to our page. And what we want to do is actually select the image tag on this page. So all we have to do is say document.querySelector and then type in IMG. And you can see that when I do this, this little element here that we were editing earlier is highlighted, and down here it's actually printing out what we're going to get when we press enter.
So when we press enter, we get this image, but we actually have to save that in a variable real quick. So let's say our image, and again, don't worry about what's going on here. We'll talk about all of this later. But we'll say document.querySelector img. We'll save that. So now our image is actually representing this element on the page. And then we can say our image.setAttribute. And what I want to set is the source. And I want to set that equal to the link that we just copied from that dog photo. And when I press enter, it's actually going to change this on the page. And I can also resize this just like we did earlier. So our image.setAttribute, or actually no, it's not setAttribute, it's style.width equals, let's say 100. I'm sorry, it's actually not, it is an attribute. So let's set the attribute, sorry, I'm doing this in real time here. So let's go with width, and we'll go for 100 here. And you can see that it goes down, resizes accordingly. So this is just a short example of how we can use the console to actually edit the document object model, or we can just think of it as the web page for now. Not only that, but we can also write pure vanilla JavaScript within this REPL or this console. And to show you that, I've actually already showed you that because I saved our element in a variable, a JavaScript variable, but we could also write a function. So we could write a function that says change image or something like that. And it takes a URL and then it's going to actually change the image. So let's go ahead and make that function. And what that's going to do is going to say document.querySelector img set attribute, and we're going to say source, and then we're going to pass in the URL. Once again, don't worry about what I'm doing here. This is just examples. And then I'm going to say enter down, and that's our function. So now I can execute this function, and I can paste in that URL and click enter, and I guess it's already there, so it's not going to change. But if we went over to a different dog picture and run this function, you'll see that it changes the image in the browser. So we can write JavaScript, we can modify the web page, all that stuff within the console, and we're actually going to be learning a lot of the initial concepts of JavaScript here in the console because it is so easy to set up and get going. All you have to do is, as we showed, you just right-click, inspect element, click on the console, and boom, you're ready to write JavaScript. So it's a great place to start so that we don't have to set up all this elaborate stuff just to write basic JavaScript. There are a couple of other features within developer tools that I want to show you here, but they're less important than the first two that we looked at, so the inspector and the console. Now, just to remind you, right-click, inspect element, and from here, I want to go up to the network tab. So this network tab is something that you will be using a lot later on, and if we refresh the page, you're going to see that there's some activity here. And what's happening here in this network tab is you're actually seeing all of the resources that are being transferred to and from over the network to this web page. So Google's backend servers are actually sending resources to the front end, and you're actually seeing all these resources displayed in the browser. So an example of that would be this Google image right here. And if we click on the images part, you can see that the December holidays in the response is actually the image that we're looking at here. And if you wanted to see other things about this, such as the timings, how long it took to load, you can look at the HTTP headers, all that kind of stuff. This will be very useful for us as we get into more of the back-end development, where we're talking about API requests and HTTP and all that kind of stuff. So we'll come back to this. We'll spend some time here a lot later in the series, but I wanted to expose you to it initially so you can see that this is something that we will be using. Now, another thing we will be using, if you click this little arrow over here, is storage. And storage is useful for a couple of things. Storage is going to be useful for tracking user behavior on a site. So not to play the blame game here, but when we talk about Facebook and all of the cookies that Facebook puts on your web browser, on your mobile phone, all that kind of stuff, this is where this is being stored. So you can see Google is storing these cookies about us as the user. And although these probably won't mean a whole lot to us as people using the site, these have specific IDs and all sorts of identifiers that allow Google to know things about the user. This is also great for authentication. This is how we're going to actually log in and register people to our app. And when we build our backend dashboard for editing our blog for our personal website, we're going to need authentication because we don't want just anyone coming and editing our blog. So this storage tab is what we're going to use to actually do that. And while it's a very advanced topic that comes later down the road, I also wanted to show it to you. Everything else that you see here, whether it be the inspector console, debugger, network, style editor, all this kind of stuff, everything else is not quite important enough for us to cover here, so I'm just going to leave it there for now. You probably won't even use anything outside of what I talked about for at least several months or even years, or maybe even ever as a web developer. All right, so I think I've covered mostly what these developer tools are about. Just to review, right-click anywhere on a web page, inspect element, and you'll get to these developer tools. Now, the last thing I want to do in this video is actually show you what coding's all about and have you write your first JavaScript program. Well, you probably will not understand the concepts behind the code we're about to write. I want to get you in the habit of actually writing code and get you feeling comfortable in this console that we talked about earlier. So open up a web browser, hopefully the Firefox browser you just downloaded. Put this video on the side, open up the console. So right click, inspect, go to the console. You can even type clear with 2 little parentheses to clear the console. And we are ready to get started. Now the goal of this program is going to be every time we click on Google's web page, so when I click it, I'm actually clicking right now, I want the background of the page to actually change color, and I want that color to be a random color. We can do this with JavaScript code, and I'm going to walk you through line by line how we're doing it and kind of explain what each line does just to give you a feeler. Again, don't worry about how everything's working. We're going to go into the details of the JavaScript language in future videos. The first thing we have to do is save the body HTML tag in a variable. So when I say body HTML tag, every web page that you're going to go to has this thing called the body. And this represents kind of the container for the entire web page, aside from, of course, the topmost container, which is called HTML. So we want to select this body, and this is what we want to actually change the background for. So we can actually do this manually, and we can come down here, and right now you see on the body the background is hashtag FFF, which is just the hex code for the color white. Now we can type in green, and you can see that the background actually changes in our web browser. Now what I want to do is do this in vanilla JavaScript and do it every time we click the screen. So in order to do that, the first thing that we have to accomplish is saving that body tag. So let's type clear to get a clean space, and then let's type in a variable. So here's our JavaScript variable. We want to set that equal to document.querySelector, and then we want to get the body tag. So when we press enter, that's going to be the HTML body. You can actually print that out and see that we have successfully retrieved that and stored it in that variable. From here, we actually need to create a function. Now this function, we're going to save in a variable, and I know this is getting a little bit confusing at this point, but bear with me and type along as I'm doing this. So we're going to go through this function, and we're going to assign something called an array. So this array is going to contain various colors of our choice. So you can put as many as you want in here separated by commas. I'm just going to put in a couple random colors here that I've saved. So 2942, these are just hex codes. So you can actually go hex codes, something like that. You can go to Google and you can see all the different hex codes here. There's various tools that you can use for this. But anyways, we're going to save these as a comma-separated array. And let's go add a few more. And then you can also, a valid CSS value would be something like red, blue, or green. So we can also type in red, blue, green, yellow, orange, and maybe even purple. All right, so we have saved this colors array. Now the next thing that we have to do is get a random index from this array. And when I say index, each of these values are at a certain index within this array, and we'll talk more about this later again. But this one would be the 0th index, this would be the first index, the second, third, so on and so forth. To get this random index, we have to actually use a built-in JavaScript library called the math library. And we need a random index between 0 and, let's see, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 items within this array, so we want a index between 0 and 7 because arrays are 0 indexed. They don't start at 1. So we'll get a random index here. That'll be equal to math.floor. And we're going to pass in math.random. Please don't worry about what's going on here. This is just an example. And this will give us our random index. And I actually pressed enter a little bit too early, so we actually have to rewrite this function. Okay, I've kind of returned to where I was before I pressed enter and screwed this all up. But basically, we're getting a random number between 0 and 7. And the way that we do that is actually get the length of the array by typing colors.length. So let's not make that mistake again. Let's enter down a couple times. And now we have to actually grab the random color and save that in a variable. So we'll grab the random color. That'll be equal to colors, and then we'll insert our random index that we have generated. Then we are going to actually style the body. So all we have to do is grab this variable that we saved up here called HTML body. And then we want to go to the style and then background color, not clip, background color. And then we want to set that equal to our random color here. So that's going to actually do what we showed earlier and change the background color. And then the last thing I want to do is just print to the console a confirmation that this worked. So we'll do something like this. We'll say the user clicked and set the color to, and then we'll concatenate this string in here and say random color. Okay, our function is done. Hopefully it works here. And the way that we see if it works is by running it or executing it. So we'll do random click function. And it looks like the user has clicked and changed the color. Now to finish this program off, the last thing we have to do is set an event listener on the HTML body element. Now this is a little bit advanced, but it's kind of a cool feature of JavaScript and all that kind of stuff. So all we have to do is go to HTML body and say onClick. So it's saying when the user clicks, I want to execute this random click function. All right, so once I press enter, now we have wired it up so that every time we click, it's going to change the color. So I'm going to click a couple times. Since it's random, we might get a couple duplicates here, but then we can even close this and keep clicking and get all sorts of different results here. So it's actually a pretty cool program that we just wrote. And you can see, even you who have never written a line of code before were able to kind of follow along and type what I was typing and write your first little program. In other words, you just did something that almost everyone in the world does not know how to do and will never know how to do. Your brain is probably in utter confusion right now, but don't worry. In the next couple videos, we're going to actually be deep diving into this JavaScript programming language, and we're going to be learning how I wrote this program, what are all these different symbols that we're typing into the console, and all that kind of good stuff. So don't worry if you're completely confused. This video was mainly to give you an introduction to the developer tools that you can have within any browser. We're using Firefox, but it just gives you that introduction and also just some exposure and some comfort levels actually writing real JavaScript code. And that's it for this first video. Be sure to hit the subscribe button and also that little bell so you're notified when new videos are posted to this series. And thanks for watching. Today we're going to be talking about what is JavaScript and why do we use it. Let's see what Wikipedia has to say, because we know that's going to be simple. JavaScript, often abbreviated as JS, is a programming language that conforms, and I think I'm going to stop right there because this is not a useful definition, especially for most people watching this. What you can remember JavaScript as is just a programming language. And more specifically, it's a programming language that is made for the web. You have other languages like C++, Python, PHP, Ruby, C#, all of these different languages, and they all kind of have their unique characteristics. And JavaScript's unique characteristic is that unlike these other languages that cannot run in a web browser, JavaScript can. This has been the case for quite some time, but recently, as you can see, the 1.0 version of WebAssembly has been released in 4 different browsers, which does let you write all of these other programming languages to run within the browser. But for now, just think of JavaScript as the programming language of the web, because it's the easiest to write in the browser, and even with WebAssembly, there's a lot of complicated steps to get all of that set up. So you say JavaScript is the programming language of the web, but is that all it can do? Well, the answer is no, but if you asked that question 20 years ago, you might have been laughed at. Since that time though, JavaScript has gained a lot of traction in development communities and was the most used language in the Stack Overflow Developer Survey of 2020. And to name a few things that you can do with JavaScript, let's pull this up here. You can create web applications. So there's lots of front-end frameworks like Angular here. You've also got React. I think this is the most popular one at the moment. You can do back-end pieces of your web application or back-end servers with things like Nest.js. You can also create desktop applications. If I pull up my Visual Studio Code, which is a code editor, this is actually a desktop application that was built using this tool called, or framework called, Electron. So you can build desktop applications for various operating systems. You can also create mobile apps with React Native and NativeScript. And then finally, you can do AI and machine learning data science projects with TensorFlow.js and a couple other libraries. So to say that JavaScript is not a powerful language is a bit of a miss here, because JavaScript has many different applications. The next question that you might ask is, can JavaScript get you a job? And the answer to that is a resounding yes. But JavaScript alone is not going to do it. You have to actually learn frameworks such as the ones that I've gone through here: Angular, React, Nest.js, Electron, React Native. All of these frameworks that are built around JavaScript are what you get hired for. And speaking of frameworks, what is a JavaScript framework, or any framework for that matter? Well, the way that I think about it is the framework is something on top of a programming language, so it's an abstraction on top of JavaScript that enables a developer to do something more efficiently in less time. Facebook is created largely with a framework, a front-end framework called React, and this is a very popular framework. We just went over it. And Facebook could definitely have been built without a framework. It could be built in just JavaScript, HTML, and CSS. But the reason that it wasn't is because the developers there decided, hey, this is getting really repetitive, and we have certain things that we do over and over and over again that we want to kind of automate. And therefore, React was born. React is something that the developers at Facebook kind of created in order to make their jobs easier and more efficient. We can use a little bit of a construction analogy to think about frameworks. If you're trying to build some commercial real estate building, are you going to use a shovel and a ladder to create this whole entire building and, drive all the materials back and forth in pickup trucks? The answer is no. You're going to get huge trucks, you're going to get bulldozers, you're going to get cranes, you're going to get all sorts of big materials in order to build this huge building. And it's the same thing with building web apps, or honestly anything that you would build with code. if you're trying to do it with just a language like JavaScript and you're not using some of the popular frameworks that have been built on top of that, you're basically showing up to a construction site with a shovel and a pickup truck. So you don't want to do that. In order to be employable, you need to understand how to use these different frameworks like Angular or React, or even a framework like Electron, which enables you to write desktop applications like Visual Studio Code. All right, I think that's enough on frameworks for now. Could do a whole video on it. Let's go to the next question, which is JavaScript the same as Java, or at least similar? And the answer to that is no. If you search enough on the internet, you'll probably stumble upon the analogy of a car versus a carpet. They both have car within the word, but they're nothing alike. And that's kind of the story with JavaScript and Java. Now, Java was actually the inspiration for JavaScript way back in the day, and JavaScript was meant to be a companion to Java. So they do have some similarity, but when you're writing each of the languages, they could not be more different. The next question is JavaScript better than Python, or honestly, insert any language there? The answer to that is always going to be, it depends. And the reason that I say that is because all these different languages that you're choosing between have different unique use cases. And while they can all kind of do the same thing, they all are programming languages, some of them are better for certain types of industries than others. So if you're asking me to build an app like Facebook, I'm probably going to go with JavaScript and use some JavaScript frameworks because that's what those are made for. They're made for creating apps like Facebook. But if you wanted me to do some machine learning and build out the computer that sits in a Tesla, I'm probably not going to use JavaScript. I'm probably going to use Python because Python has a much more mature ecosystem around this topic of machine learning, AI, data science, all that kind of stuff. So when you're asking whether you should go with JavaScript or another language, it really depends on what kind of industry you're getting in, what you're trying to build, all that kind of stuff. If you're trying to build a web app like Facebook, JavaScript is great. If you're trying to do some machine learning, Python is great. If you're trying to create an extremely efficient, we'll say, banking application or something like that, a language like C++, which is much faster in execution than a JavaScript, would be a good choice. There's no right answer here, but there are different ecosystems around each of these languages, and you'll kind of notice as you study them that certain types of developers kind of gravitate towards different languages. Another question that you might have is HTML and CSS required to work with JavaScript? And the answer to that is yes and no. It kind of depends on where you're actually running that JavaScript. Now let's start with the front end because this is a little bit easier to explain, and then we'll move on to the back end. If you don't know the difference between those, I actually made a video on the difference between front end and back end development. Anyways, let's go over to my browser here. On the left side of my screen, I have an HTML file that is actually open in Notepad here on the right. Not doing any fancy editors here, just want to get a few points across. So let's create a basic HTML document here. I know I haven't actually gone through how this all works yet, but we will get there, I promise, at some point here. In the body of the HTML, I'm just going to create a button that says click me. So when we refresh the page, we should see all of this reflected on our web page. And you see that we have a very unstyled button, which is just click me. So this is a example of a web page. This is no different than the home page of Facebook, except for the fact that it is not including both CSS and JavaScript. So this is HTML alone. Now, if we add CSS to the picture, we're actually going to be able to style this. Now we can add some styles to this button. So let's do that right now. We'll add a background color of transparent. And then I want to say the border is going to be 1 pixel, solid navy. Then I want to add some padding to it. So we'll say 20px. We want the font size to be 1.4 rem, just somewhere in that range. And let's go ahead and close that bracket off, save it, and refresh the page. You can see that we have a much better styled button here. We can also add some hover styles to it. So let's go down here and say button hover. And now I want the background color to be navy. And I want the, let's see, the border to be none. I want the color of the text to be white so that it stands out on that navy background. Save this, refresh, and you can see that we have a styled button that changes styles when we hover over it. So this is the power of CSS. But if I click this button, it's not going to do anything. It does nothing. It's just a static element on the page, and while it looks like it's changing, looks like it's doing something, that's only being done with CSS and HTML. Now, in many web applications, you have various buttons and forms that users can click on in order to do things within the app. So I'm sure you've been to a login page before where you enter your email and your password and you press login. Well, that is actually being triggered by JavaScript. And while you do need the HTML and preferably CSS if you want a web app that people are going to visually like, you need JavaScript to actually react to different interactions on the page by the user. If you just have HTML and CSS, your login form is going to not do anything and you're going to have a useless app. To kind of give you an idea what I mean, obviously this is not realistic, but I added some JavaScript to this HTML document that also has CSS, and you can now see that every time I click on this button, it's going to add an element to the page. So I'll click it, and you can see that I'm adding a p tag with the text "click to the button" every time I click it. And this is just to demonstrate how once you add JavaScript to your HTML and CSS, you can actually interact with the page rather than just looking at a static website. Well, in this case, all I did was add some stupid text to the page. You can see that how every time we click the button, we can fire an event and maybe send in the login credentials to our backend server, authenticate, get the response back, and then redirect that user to a different page of our site. When we're working with JavaScript on the front end or in the browser, HTML and CSS are pretty much required for JavaScript to run. Now, yes, it could run without them, but it would be completely useless. You'd just be running it in the console like we did in the previous lesson. So it has to have something to actually interact with. Now, on the back end, since JavaScript is both a front-end and back-end language, we can actually run JavaScript without any HTML and CSS, and it can be extremely useful. When we're working with JavaScript in the browser, HTML and CSS are required to make this JavaScript do anything useful, because ultimately the JavaScript in the browser is all about taking those HTML elements and modifying them and interacting with backend data, all that kind of stuff. So HTML and CSS are required in the front end. On the back end, if we're using the Node.js runtime, which is the way that we can run backend JavaScript, we don't need HTML and CSS. Let's write a simple Node.js program to demonstrate that we don't need HTML and CSS. In order to do that, once again, we have not covered this in this series yet, so bear with me. But we need to create a sample.js file. And then we'll open this up with Vim, which is going to allow us to edit this. So once we have this, again, haven't covered this either, but we can make a do math function, something like that, where we can enter in two values and get some result. So let's do a multiplication problem. So we'll just we'll say return x times y and close the braces. And then in order to actually run this program, we are going to actually store it in a result variable. So do math, and we'll say 5 and 80, something like that, big enough where we can't necessarily do it in our head. We'll do like 87 or something. And so it's going to store that in the result, and then we want to print the result to the console. So from there, we can save and quit, and then we can clear the console and run this sample.js program, and you'll see that it did that multiplication for us. So obviously this is very useless and you wouldn't ever do such a simple function, But think about back when we were working on the front end and when we clicked that button. So let's say that it was a register form. You add your email and your password, you click the button. The JavaScript in the front end is going to say, okay, the button was clicked, I need to do something. And so what it's going to do is grab all that data, the email and password. It's going to send it over to your backend server. And your backend server is going to run the Node.js, version of JavaScript. And it's going to say, okay, I got an email and a password. Let me look up this email in the database, hash the password, and compare the hashed password to the one within the database. And then I'm going to send some data back to the front end in order to tell it whether the user has successfully authenticated. So you can see how these different sides of JavaScript work in different ways. But the point is, no, you don't need HTML and CSS on the back end, but yes, you need it on the front end. And the last question that I'm going to cover is, what is the difference between something like ES5 or ES6 and JavaScript? Well, there's actually an organization called ECMA International, not even sure if I said that right, but this is just a standards organization. And in order to really visualize this, I want to go into a quick example of something that's not related to JavaScript. Well, not entirely. And that is the ISO 8601 date standard. So we're going to go through this example, and then I think everything else is going to make a little bit more sense. So if I open up the console like we did in the first lesson of this series, and I run, let me save a date into a date variable, and then I want to print this date as an ISO string. And you can see that I have this uniquely formatted date, and it looks very standardized, and that's because it is. And it's actually standardized by this, organization called ISO, which is, I think, the International Standards Organization. And there's actually organizations like this across the world for various, different standardized things. And the same thing applies for JavaScript, and that is where ECMA International and the ECMAScript specification, or in other words, you might hear this as ES5 or ES6, all different versions of this spec. This is where these have originated. And so JavaScript is actually an implementation of this specification. And the reason this is so important is because of browser compatibility, among other things. So if you go to this MDN Web Docs article, you can see a grid of all the JavaScript APIs that are supported within different browsers. And the reason that this ECMA standards is so important is because the specification just needs to be updated and maintained in one place, and then all of the different browser developers, you've got different teams for each of these different browsers, they can look at that specification and implement their browser knowing that all of these specifications are not going to just randomly change when, say someone working on the JavaScript language decides that they want, a new API feature. So just remember, JavaScript is an implementation of the ES6 or ES5 or whatever version you're working with. It's an implementation of that specification. All right, I think that does it for this first rapid fire Q&A session that was not very rapid fire whatsoever. But this last part of the video is totally optional. It's for the people who really want to learn the ins and outs of web development and want to continue on with this series here. And what we're going to be talking about in the last part of the video is just the question of, what is a programming language? So we talked about how JavaScript is a programming language, and it's kind of unique because it can run on the back end and the front end in a browser. But we didn't really cover what is a programming language. And I think that this is a very important question to ask, because if you're going to be writing a lot of code, you probably should understand what's happening behind the scenes, at least at a high level. So for this last part, what we're going to call a programming language is a group of tokens or symbols that, when combined together in a very, very specific way, can be translated by something called a compiler into machine code, or ones and zeros that all computers know how to run. You can think about it like this. Let's take a spoken language something that I don't know, which is pretty much every language except for English, but we'll call it, I don't know, something like Portuguese. If you started speaking Portuguese to me, my brain would not be able to comprehend what those words and symbols and expressions actually mean semantically. Although I can't understand Portuguese, what I can understand is the body language of someone speaking it. So if you've got someone speaking Portuguese and they have a very, sad demeanor to them, I can understand generally that what they're saying is not a happy thing. And it's the same thing with computers. Well, a computer cannot understand JavaScript, it cannot understand Python, it cannot understand C++. It can't understand any of these languages. But if we use something called a compiler, which is just another program, more code that actually reads other code and compiles it down into ones and zeros that a computer can actually understand. So it's taking a language and it's compiling it down into ones and zeros, or we can think of them as body language because all computers understand ones and zeros. Now, this is where it gets really complex, and I'm not going to actually dive into it during this video. Once we start talking about compilers, then we have to get into the topic of operating system theory and what is our target runtime that we're dealing with, like where are we actually executing these ones and zeros, because each computer is going to have a slightly different CPU, slightly different ALU or arithmetic logical unit. All of these things matter when we're compiling code down. And for each different language and kind of each different operating system, you have to have slightly different compilers and other tools that I'm not mentioning here in order to do that. Now, if you're someone who really wants to understand this in a great level of detail, something that was very important to me, then I recommend reading this book right here, which is The Elements of Computing Systems. And you'll see within this book, I'll see if I can show like a little page here, but we actually get into things like the arithmetic logical unit and how these ones and zeros are actually translated into commands for the computer. Now, I will say, if you're going to read that book, I will warn you right now, it's going to take you months, and it's very difficult to get through. That said, I came out of it learning in a ton, and I was really happy with what I learned from that book. But if you're trying to get a job quickly, you're trying to become employable as fast as possible, do not read that book. It's going to take you too long. It's going to distract you from actually writing web applications. Now, if you're someone who wants to understand this stuff but doesn't have time to build a computer from scratch, which is what you'll do in that book, I recommend a book called Code by Charles Petzold. And this is going to give you all that information. It's going to teach you the ones and zeros, compiling, all that kind of stuff. But it's going to do it a little bit quicker, and you're not going to be quite as hands-on with it. And the final question of this video is, where does JavaScript actually run? And the answer to that is very similar to the question that I asked earlier, which is HTML and CSS required to run JavaScript? And I said, well, it depends whether you're running it in the front end or the back end. And what we're asking here is, where does JavaScript run? And this is where we get into the topic of something called a runtime. And a runtime is basically an environment where code is run, and it gets into those topics that we just talked about with compilers and how do we target different platforms and compile down to ones and zeros. And there's actually two runtimes for JavaScript, and that would be the Node.js runtime and then the browser runtime. And believe it or not, the browser runtime within Google Chrome uses something called the V8 engine. And this is going to actually do all of that compilation that I was talking about. And it's going to get into a bunch of other stuff, some optimization using the just-in-time compilation method, all that kind of stuff. It's going to basically take your JavaScript code and convert it to something the computer can read. And Node.js, which is kind of the back-end version of JavaScript, or the runtime that we're going to use for our back-end JavaScript servers and stuff like that, that also uses the V8 engine, which is similar to Chrome. So you can kind of guess that the creators of Node.js and the creators of the V8 engine that runs in Chrome and Node.js have kind of become good friends here over the last couple years. But this is not the only way that we can run JavaScript. You have Node.js, which is the most popular way to run JavaScript on the back end, and Google Chrome, which is one of the most popular browsers. But in this course, we're using Firefox as our web browser because I think the developer tools are a little bit better there. And with Firefox, we're not actually using the V8 engine in order to compile the JavaScript down. We're using something called SpiderMonkey, which is the original engine for JavaScript that was built within the Netscape browser way back in the day. And as a side note, if you really want an interesting podcast to listen to, look up Browser Wars. I think it's by the podcast called Business Wars. And it's a really cool story about Netscape and how all these browsers gained market share. Really worth checking out, in my opinion. So in summary, JavaScript can be run on the back end or the front end. And if it's run on the back end in Node.js, it's being compiled down using the V8 engine. If it's running on the front within Google Chrome, it's also using the V8. If it's running in Firefox, it's using SpiderMonkey. If it's running in Safari, it's using some other compilation method that I can't think of off the top of my head. But ultimately, these are all different runtimes, and you do have to be aware of where you're running your JavaScript code because it's going to run differently. There are things that you cannot run within the Node.js runtime. If I tried to, let's say, open up the Node.js runtime here, all I have to do is type node and it'll bring me into the console. If I tried to say document.query selector and then grab the body tag of the HTML and I press enter, it's going to say uncaught reference error, document is not defined. And that is because in the Node.js runtime, the document object model does not exist like it does in the browser. So you have to be aware of these different runtimes and understand that certain types of code can run in the different runtimes. It's all JavaScript, but you kind of get what I'm saying here. And at this point, per usual, I've droned on way too long, longer than I ever thought that I would. But you have reached the end of the second lesson of my Full Stack Web Developer Roadmap series. And while we haven't written any JavaScript yet, well, I guess we did in the first lesson, but we haven't actually learned JavaScript yet, we do have a lot of context around it now, which was the purpose of this video. I really wanted to put this video together in order to give you that context so that when we start getting into the details, variables and data structures and functions and loops, all that kind of stuff, you have a little bit of a background to understand it from. If you liked this video, please give it a thumbs up and subscribe to the channel if you want to follow along with this series and series in the future. And with that, hope you enjoyed the video and I'll see you in the next lesson. In this video, we're going to be talking about JavaScript variables and data types. And be sure to stick around till the end of the video because I have some challenges and some practice questions that you can use to apply the skills that you learned in this video. Before we start talking about variables and data types, I just want to mention that as we go through this series, I'm not going to be covering everything that there is to know about the JavaScript programming language. There are a lot of different features within JavaScript, a lot of built-in functions and syntax shortcuts and all sorts of things like that you can do, but they're not absolutely necessary for you to write JavaScript code. For example, let me create a basic array here. So we'll say my array, and then we'll put some numbers in it. And this is actually what this video is all about. So don't worry if you don't understand this quite yet. But JavaScript has some built-in methods that we can use on this array. So we could say myArray.push, and then we can add a number to the end of this array. So just return the length of our new array. And if we print it out, you can see that there's the number 50 at the end of it. Now, that is an example of a very useful and commonly used built-in JavaScript prototype method that we're going to be covering in this series. But there are other methods, and there are a lot of them, that we will not. So, for example, we can say myArray.reverse. Now this one's pretty simple. All it does is it reverses the order of the items within that array, as you can see. But this is not critical for you to learn to write good JavaScript code and be a web developer. So I'm going to selectively exclude things like that and try to focus in on the most important things of JavaScript. Likewise, there are also some very complex topics that we can discuss around the internals of JavaScript and how it works behind the scenes and how prototypes work and why it's technically not a class-based language. And all of these things are important for you to understand later down the road, but when trying to get you from, zero to deploying your first full stack web application, they're not completely essential per se. And believe it or not, a lot of web developers that work full-time jobs and are employed getting paid lots of money don't fully understand the internals of JavaScript. And that's why this series called You Don't Know JavaScript, written by Kyle Simpson, or his GitHub username is Getify. And he's written this wonderful series or book series on JavaScript and how it works. And you can go to each of the series on GitHub and actually read all about, how JavaScript works under the hood. And he has a tremendous understanding of this language and explains it in great detail. But I would say that you would use this as a reference, and personally I think it's geared towards someone who has written JavaScript for some amount of time, and it's something that I reference back to even now after writing JavaScript for about 4+ years. It's still a great resource to look back on. So just know, as we go through this series, I'm not going to be covering absolutely everything. And if you have questions, be sure to just Google it or go to this You Don't Know JavaScript series and pick the section you want to learn about and kind of read a little bit more about it. And finally, if I can get through this long intro, we'll finally get to variables and data types. But I want to show you one thing real quick, and that is the console.log statement. So when we're working within the JavaScript console in our Firefox DevTools, you can print a variable by using the console.log statement. And this is built into JavaScript. You can use it on the front end in the JavaScript console or the back end in the Node.js console. And we can print something like hello world. We've done this already once in a previous video, but this is how we print different variables. So if I just say my first variable and set it equal to 20 and then console.log that first variable, you'll see that it prints it to the console. That's going to be used heavily within this series, so I want you to be familiar with it. The next thing is the concept of comments. So if you put 2 forward slashes before your code and then you write something, this is obviously invalid JavaScript, and you press enter, it's not going to throw an error on you. While if you type it like this, it's going to say that there's a reference error because we haven't commented it out. There's another way to write comments. Let me clear the screen here. And you can put a forward slash and then a star, and then you can enter down, write whatever comments you want, and then you just have to close it out by a star and then a forward slash. And when we press enter, it's not going to yell at us with any sort of error because we have written a comment. So I just wanted to basically introduce those concepts, the console.log, the single line comment, and the multi-line comment. You're going to see them a lot, and they're very useful for marking up your code and remembering things about the code that you've written. A big congrats if you're still watching this video. It means that you are dedicated to learning how to code. And for that reason, let's jump into variables and data types in JavaScript. So when I think of a variable in JavaScript, I just think of a data container. And a good analogy for this is the Amazon warehouse. So they've got these big vertical yellow stacks of containers with different products in them. And then on the bottom, they have little robots that kind of drive these containers around according to when the items in the containers are meant to be shipped. And I like to think of this as an analogy because JavaScript variables are very similar. In that Amazon warehouse, each container is registered and all the robots know exactly where to find the container and the products that are within that container. Same thing goes for JavaScript variables. Your computer knows exactly where to find all of these JavaScript variables that you declare and assign values to, and it's able to retrieve them instantly. So you can think of JavaScript variables as, you write them, and then they are basically like little Amazon products that get put into these containers and put in the back of the warehouse, but the computer at all times knows exactly where to go in that warehouse to find the values of these variables. In computer language, we wouldn't really call it a warehouse, we would just call it memory, but it's a good analogy to go by, and I think it'll help you remember what variables are all about. Just like Amazon's containers can have various types of products stored within them, so can JavaScript variables. And we can look at this here. We're going to just go through a couple examples of variables. The first one will be, we'll say your first variable, and we'll say learning to code gives you superpowers or something like that. So that would be one example of a variable, and that is actually a string variable. We'll go into that a little bit later. Now you can have your second variable, which will be equal to a number this time, so equal to 10. And finally, we'll say your third variable, and that'll be equal to an object. And we'll say that this object has a property that says something like hello world. And this is also a valid variable. And to print these variables, once again, we can use this console.log statement, and we can print your first variable, something like that, and you can see that it prints it out to the console. So these are just examples of writing variables, and now I want to go into each component of these statements. So as you can see, we have this keyword called const. We have a little space here. Then we have what seems to be our variable's name. Then we have this equal sign. Then we have some sort of data and a semicolon at the end. These are all really critical parts to writing JavaScript variables, because when the compiler goes to basically interpret the code that you have written, it reads it in a specific order, and it looks at every single what we call token within the code. So for example, if I tried to define a new variable, and this time I'll just say another hello world, something like that, this would be valid. But if we took out just even this single little quotation and pressed enter, it's going to give us a syntax error. And you're going to get a lot of these syntax errors when you first start out, because they basically say, hey, you haven't written this JavaScript program correctly. You've missed a specific token within your code. Now, a lot of times you don't have to actually worry about these syntax errors. What I have pulled up here is Visual Studio Code, which is a code editor we're going to work with a little bit later in the series. We're not there yet, but what I want to show you is that if we tried to say new variable, and then we define hello world with a semicolon at the end, it's going to look fine. But if we go over here and delete this little quotation, you're going to see that Visual Studio Code picks up on the fact that there's an error in this syntax. So a lot of the times when you're writing code, we're not going to see it, here in the console, which is what we're using right now. But once we get into code editors, it's going to point these things out, and you don't really have to worry too much about getting everything right as you're writing your code. The next thing we have to talk about with JavaScript variables is the concept of declaration and assignment. To properly use a variable, you have to do that sequence of steps in order. So you first have to declare the variable, then you have to assign a value to it. Now, if we typed in, something like new variable, and I'm going to actually refresh the page so we clear out all of the variables that we had already written. So if I say new variable, something like that, and we say hello world, that is going to not only declare but also assign this variable at the same time. So in many cases we're doing it simultaneously, but we can also break it out into individual steps, and we can do that by using the let keyword, and we'll say let another variable equal, we'll say 20 this time, or actually no, we need to just put a semicolon at the other end of it. And by doing that, we have actually declared the variable, and now we have to assign a value to it, and we don't have to put the let keyword at the beginning, we just assign a value. And we can print this to the console by saying another variable, and you can see that it equals 20. So in the second example, I declared it, then I assigned it. And it's important to understand this concept. You don't necessarily have to, think about this while you're coding, but I wanted to point this out. And it brings up another good point about this const versus let versus var keywords at the beginning of your variable expressions. Let me go ahead and write the same variable per se in 3 different ways. So first we can say variable 1 equals 10, and that's using the const keyword. Then we can say let variable, we'll say 2 this time, equals 10. That's valid. And then we can say var variable 3, can't type here, equals 10. And you can see that all 3 of these ways of writing a JavaScript variable are valid. So you might ask the question, well, how do we decide between const, let, and var? You need one of them at least to create a variable. If we just tried to say, random keyword and then variable 4 equals 10, it's going to give us an error because random is not an assigned keyword such as const, let, or var. Let's go ahead and start with var, and that is the only keyword that I would recommend against using. It's kind of a legacy keyword within JavaScript. It's something that existed in the old versions and standards of JavaScript, and nowadays we have the const and let keywords, which will pretty much cover every situation that we need to. Now the reason var is not used anymore is because it can be redeclared. So if we say var my variable equals 10, and then we say var my variable equals, I'm sorry, I can't type today, equals 20, it's going to actually update the value of that variable without yelling at you at all. But if you use a keyword like const, so we'll say another variable equals 10, and then we say const another variable equals 20, it's going to say that there's a syntax error and it's going to yell at us for redeclaring a constant variable. With the var keyword, being able to redeclare a variable seems convenient, and it actually is when we're working within the console. But when you're actually writing code, it can be kind of dangerous and you can have some unwanted side effects by being able to redeclare a variable. The next keyword I want to talk about is let. And let is something that you will use whenever you expect to reassign a variable at some point in your code. So we just kind of talked about redeclaring a variable, and that's very different from reassigning a variable. So if you remember, you first declare the variable, which is basically saying, go back to our Amazon analogy where we're talking about, the containers and the robots have to remember where those containers are in the warehouse. Well, your computer has to first register or declare these variables, and then once it's declared, it kind of allocates some memory space on the hard drive or something like that, or in RAM, to basically remember where to retrieve that variable from. So that's the declaration step. And then the assignment step is where we take an actual value and we say, okay, put this value in this variable, and so the computer will go find that variable that was declared into memory and assign your new value to that little memory slot. So we will always use let when we expect to reassign a variable. So let me show you what this basically looks like. So let's say that we have a counter and we start that counter at 0. And then we want to actually increase the value of that counter. So we can say counter equals counter plus 1. And we can also say counter plus plus. That will do the same thing as the previous line that I just wrote. So now we should have it equal to 2. And you can see that it is now equal to 2. And you can see that we are reassigning the value of this variable multiple times. Now, if we tried to, let me refresh the page real quick so that we can use this variable again. And if we tried to say counter equals 0 with the const keyword, and then we tried to say plus plus, it's going to say that we have a type error because we can't assign or reassign a value to a constant variable. So that's when you want to use constants, is basically when you expect the value to never change. So a good example of that is, say we have a program that calculates some sort of, I don't know, income statement, and you want to put in a tax rate for this individual. So you might program in something like a tax rate, and that will be equal to 0.08 for 8%, and you press enter, and now this constant variable is never going to change. Your tax rate's never going to change. And that is the best use case for a constant variable. So just remember, you use let when you expect the value to be reassigned to a variable, and you use const when you expect the variable to never change values. Now, the concept of a constant is pretty universal in programming, and it spans across many languages. Oftentimes, you'll see constants written something like this. So we'll say tax rate equals 0.8%, and you can see that the variable has been written in all caps and separated by an underscore. Now, you'll see this very often, but this is just a semantic difference, and it's functionally the same as what we had written before. And that actually leads us into our next discussion, which is about variable naming conventions. I'm going to paste a couple different versions of variables in here, and we'll press enter, and you can see that all of these are actually valid in JavaScript. They're all written slightly differently, but they're functionally kind of the same. So these are all saying your first variable, but JavaScript recognizes them as different variables. That's why we're allowed to declare all of these at once. And they all functionally operate the same, but there are a couple of these that are more preferable in the JavaScript programming language than others. So for example, the first variable that we have here is written in something called camel case. And that is basically where the first letter of your variable is lowercase, and then each successive word or logical separated word within your variable is going to be capitalized. So this is called camel case, and then there's another version down here which is called Pascal case, which is basically where it's the same thing as camel case except the first letter is capitalized. The second variable here, where we have underscores in between lowercase letters, is called snake case. Then you have this one right here that we just talked about, which is called constant case. And then finally you just have a totally lowercase variable. And these are all different semantic styles that you can put on a JavaScript variable or any programming language variable. And oftentimes these indicate to other programmers something about your code. I'll talk about what these mean in just a second, but first I want to talk about what makes these valid. So you can really think of a variable in JavaScript kind of like a Twitter hashtag. So if you were to write a Twitter hashtag, and we'll say the full stack roadmap, which is the one that we have for this series, this would be a valid Twitter hashtag because it's all one word. Now, if I put a space here at the end, then Twitter's only going to recognize that first part, or full stack, and then it's going to treat roadmap as just normal text. And that's exactly how JavaScript works with variables. If we tried to define this as a variable, so let's say const full stack roadmap equals 10, it's going to give us a syntax error because we have a space in between these two words. To have a valid JavaScript variable, you have to put everything in one word and use one of these conventions up here at the top. Now, there's also a few things you can't do, so we cannot do something like this where we say full stack equals 10. You can't have these little quotes here. This is not going to work. And then you also cannot start a variable with a number. So you can see that I put 1 at the beginning of this variable. It's going to throw an error. But if I put full stack 1 at the end, so now we have our number at the end of the variable, that works just fine. So these are just some of the things to watch out for. It's fairly intuitive and you'll get the hang of this really quickly, and if you don't get the hang of it, the JavaScript debugger is going to yell at you and it's basically going to give you a bunch of syntax errors. All right, so now that you know how to validly declare and assign a variable, let's talk about something called a style guide. And this goes back to the concept that we see up here where we have all these different semantic ways to write a variable. They all work, but some of them are more preferable than others depending on what language you're writing in and what you're trying to do with the individual variable that you're declaring. If you type in JavaScript style guide into Google, you'll find a couple different style guides by different companies. So this is Google's JavaScript style guide, and here would be Airbnb's JavaScript style guide. So basically what these are specifications for the employees of these different companies that says, here is how we want you to write your JavaScript for our company. And what this might entail is different naming conventions, different use cases of different JavaScript features, all that kind of stuff. There's a plethora of things that you'll find within these style guides, but the one I want to look at is naming conventions. So we can find this within each of the style guides. Kind of have to look for it here real quick. So here is naming for Google. So we have the naming style guide for Google and Airbnb, and you'll see that each of them recommend camel case. So we can see package names need to be lower camel case, class names are upper camel case. Let's go down to normal variables, so non-constant field names should be lower camel case, local variables, lower camel case. You kind of get the point. They're all pointing towards this lower camel case convention. And if we go to Airbnb, you'll see here that it says use camel case when naming objects, functions, and instances. This is a bad example. This would be a good example. So you'll see within these two different companies, they're both recommending camel case. And that's actually a recommendation across all of the JavaScript community. So you'll see a lot of JavaScript code written in this camel case, as we saw here with our first variable. And this is what I would recommend you do as you're starting to learn how to write JavaScript. The last thing I want to talk about with naming conventions for variables is what we're actually naming them. So you'll see here that these are very descriptive. This is clearly indicating to the programmer that you're practicing, you're writing your first variable. But there's also going to be programs where you're going to have multiple variables within a single function or a class, and you need to identify between these different variables. So tell me, would this be an appropriate way to name a variable if we just said q equals 20? Well, the answer is no, because how are you going to ever know what that q is supposed to represent? Maybe it represents a counter in a for loop. Maybe it represents, I don't know, the tax rate on something. You know, whatever it means, you need to name your variable accordingly. So if this 20 represents a 20% tax rate or something like that, we need to call it tax rate for net income or something like that, where you're clearly specifying what this value represents. Now, there's also the case where you can get too complex with this and write out a variable that's way too long, and in that case, it gets hard to write that code because you're constantly having to type this super long variable and it takes you longer. So you want to find that middle ground where you're not being so vague where it's just saying the variable's name is q, and you're not so specific that you can't, write your variable within 10 seconds. The next thing we have to talk about is the left side of the variable expression and the right side of the variable expression. So let's write our first variable. JavaScript gives you superpowers, something like that. We'll press enter, and let's take a look at this. So on the left side, when I say the left side, I'm talking about everything left of this little equal sign in the middle. And when I say the right side, I'm talking everything right of this little equal sign in the middle. So it's very important to make a distinction between the left and the right because depending on what you're putting on each side, you're going to get different behaviors. The left side of the equal sign is always going to include two things. It's going to include either const or let, and you could use var, but I don't recommend it. And then it's going to have a single space right here. and then it's going to have your properly constructed variable name, and then I always use another space. This is just good code formatting after that, and then an equal sign. And everything left of the equal sign is considered the target, or that container that you're trying to put some sort of data or value into. So this is where you're storing your container. Now on the right side of the equal sign, you have the actual value that you're assigning. So the right side could be one of many different things. And this is where we get into the concept of data types. In this case, we have a string on the right side of our equal sign, and then followed by a semicolon. That's to indicate the end of the variable expression. So I want to touch on that real quick. Let's say that we had one variable equals 20, and then const second variable equals 30. This would be a valid expression. We wrote them on the same line, but we ended each statement with this semicolon. Now, if we were to pull this up again, all I did was press the up arrow key to get my last statement in the console. That's a quick shortcut for you. And if we were to take out this semicolon here, and let's go ahead and, I don't know, rename these variables so that we can actually experiment around with them. So 1 and second, and then press enter, it's going to yell at us because we don't have a semicolon at the end of our first variable declaration, and that's why that semicolon is so important. It kind of indicates the end of an expression. Just for an example, here's a bunch of code that I wrote that is demonstrating that we can have multiple different things on the right side of our expression. So you can see in each line we have our basic variable declarations, but on the right side we have anything from a number to another variable, to a string, to an object, to an immediately invoked function, to a combination, sorry, it keeps disappearing, a combination or addition of variables. And if we were to console.log variable 6 here, you're going to see, hello, my name is Zach. And basically what that's doing is it's taking the value derived from variable 5, which is returning us this hello, my name is, and then it's adding to variable 3, which is Zach. So you can see how we have a lot of different options on the right side, and this is always going to equal the value, which could come from a function or a specific data type. It can come from a lot of things, and that is assigned to the target container on the left side of the equal sign. All right, let's go a little bit simpler here again. I'm going to paste in 3 variables. The first one we have is a number, the second is a string, and the third is a Boolean. So let's talk about these different data types a little bit. There are a couple different data types in JavaScript, and the 3 most common are sitting on this screen right now. These are kind of the primitive data types. Now you might notice that as we have declared and assigned these variables, we didn't really mention what data type we are specifying here. And in a lot of languages such as C or C++ or Java, they actually require you to specify what type of data you are assigning to this variable. Another example of that would be TypeScript, which is actually a superset of JavaScript that we might talk about a little bit later in the series. But basically, it's a language that compiles down, or it's actually transpiled down to JavaScript, and it allows for type checking or static typing. So this is how you would declare a variable within TypeScript. So we would say the variable 1 equals a number, and that is equal to 10. So in this declaration and assignment, we are saying, okay, we have this variable 1, this is a number, and here's the value, which is a number assigned to it. And this is what we would call a statically typed language. And when we say statically typed, all we mean by that is the fact that you are, before you run your code, telling the compiler what types of data to expect. Now, JavaScript is what we would call a dynamically typed language, and you can see this above where this variable 1, the compiler is going to have no clue what type of variable this is until it actually evaluates the assignment value that you've given it and figures out what type it is. and you can actually see the type of each variable. So if we typed in variable 1 using this built-in type of function, we can also say variable 2 and variable 3 to see the different types of the variables. So you might say, well, if JavaScript is dynamically typed and we don't really need to specify the data type that we're assigning to the variable, then why should we even care? Well, that is exactly the reason you should care, because if you're writing code like this and you're assigning all sorts of different values to these variables, it's really important that you always recognize what types of values you're assigning to your variables, so that you don't try to do something like this where you say variable 1 plus variable 2, and then it will say 10 some value. So clearly something happened here. You tried to add a number and a string together, but JavaScript has magically coerced the first variable, which is a number, into a string, and it has combined those or concatenated those strings together into a single string. So without understanding the different data types that you're assigning to your variables, things like this are going to get very confusing, and you might try to add things together or combine variables together, and you don't know why they're combining in the way that they are. This right here is actually called implicit coercion of a variable type. We're not going to talk about this quite yet, but basically what's happening is it's taking variable 1, which is of type number, and variable 2, which is of type string, and it's saying, I want to coerce this number into a string and then combine the values together. So you can have a variable such as number 1 will be equal to 10 as a string, and then we can say number 2 equals 20 as a number. And if we said the type of number 1, it's going to give us a string, and the type of number 2 is going to be a number. But what we can actually do is explicitly, rather than implicitly, coerce these two variables together. So if we implicitly do it and say number 1 plus number 2, it's going to give us 1020, because it is basically coerced this number of 20 into a string and concatenated together with this first string, which is 10. But if I wanted to add these two together as numbers, all I have to do is use the built-in math function to, number function to put the number 1, which is a string, into a number, and then I can add that to number 2, which is already a number, and now it's going to give me the correct answer, which is 30, and that is the addition of those two numbers. So you can see that if you're not paying attention to the types of data that you're working with, you might have unexpected results, as we saw right here when we added a string and a number together. All right, so now that we've talked about the importance of data types, let's go through each of them and just get an overview of what they look like. So let's clear this out. So the first one we're going to do is a string value. And there are actually two ways that you can declare a string value. You can first say something like hello world with these single quotations, and that would be valid. You can also say another string value and specify with double quotations hello world, and that's going to work just the same. There's no better way to do this, but I would say just like we use lower camel case for writing JavaScript variables, the convention within the industry is generally going to converge on these single quotes, and a lot of code linters, which actually a code linter is something that will take a big style guide like the ones we looked at before, and it'll actually write these rules into code, and then while you're typing your code within a code editor like Visual Studio Code, it will take all those rules and it will apply it to the code that you're writing as you're writing it. So a lot of these code linters are going to specify that they want your code written with these single quotes rather than the double quotes that you can also write a string as. Moving on to numbers, these are a little bit easier. All you have to say, let's say number values are variable. All you have to do is specify a number, and there's nothing to it here. Now the one thing that you might mess up on at some point, let's just make this a different variable. You might try to add a comma in there to specify a larger number. And when you press enter here, it's going to give you a syntax error because this is not a valid way to write a number. You always have to just write the number as one big number. There's no commas or anything that you can put in it. Booleans are also pretty simple. So if we want to write a Boolean, Boolean value is going to either be equal to true or it's going to be equal to false. So that's pretty simple. There's only two possible values that you can put in there. That's Booleans. Now the next one is arrays, and this is where we start to get into a little bit more complex data types. So let me clear the screen to work on this real quick. And if we wanted to say first array, and then we want to put in some numbers here, we can do that. And you can see that an array is specified by these opening and closing brackets, and then values here that are separated by commas. So you can think of an array, and I know computer science people would yell at me for saying this, but you can think of this array as just basically a list. And this list is separated by commas, and within this list you can actually put any data type that you want. So we have numbers in this first array, but we could also put in a variety of data types. So we can put in a number, a string here, we can put in an object. We're going to get to that in a second. And we can also put in another array. So we just put in another array within this array. So these are all valid things you can put in an array, and you can kind of mix them together. You probably won't do this very often where you're mixing data types, but just wanted to say that you can do that, and that's part of JavaScript's dynamically typed language feature. Now the important thing to understand about arrays is that they are indexed. And when we say index, each of these values separated by commas are identified by a single index, and these indexes start at 0. So they don't start at 1 as you would think. So in this first array, you might say, oh, this value 10 is represented by the index of 1. Well, no, that's not the case. This is represented by the index of 0, and then you just count up in order. So 10 would be represented by 0, 20 would be represented by 1, 30 by 2, and 40 by 3. And we can retrieve these values from the array by saying first array. So you type out your array variable, and then you use brackets just like you did to write them, but this time you pass in the index. So if we wanted to grab this value of 10 from the first array, we just type in the 0th index and press enter, and it's going to give us that value from the array. Now we can also retrieve these other values. So say from the second array, let's say that we wanted to get this last value, which is actually another array. We could say console.log second array, and then we can use brackets, and we'll count this is 0, this is 1, this is 2, and then this would be the third. So we can say 3, and that's going to give us this array. And we can even tack on another set of brackets, and we'll say we want the third, or the second value. I'm sorry, I'm misspeaking totally here. We want the fourth value from this array by using the index of 3, and then let's say we want the 0th value, or this value of 1, from the array that we've grabbed there. And now you can see that we can grab values from nested arrays. So that's the important thing to know about arrays. You have to pay attention to the indexes, and then you use bracket notation to retrieve those values from their respective indexes. The next thing we'll talk about is objects, and in JavaScript these are very important. You might even hear the phrase that everything is an object in JavaScript, and that is true. I don't want to get into the subtleties of it today, but it is very important nonetheless to learn how these objects work in JavaScript, because you're going to be using them in every single program that you ever write. To understand objects, just think of them as a complex container. So going back to that Amazon analogy where you have those carts of different containers, and then within the containers let's say that you have other containers that have the Amazon products. So let's say that you have some sort of jewelry product that is sold on Amazon. You might have a big container, and then you might have 30 different little containers within that big container. And then within each of those 30 little containers, you have different pieces of jewelry. So that is kind of what a JavaScript object is all about. You can make it infinitely complex, infinitely nested. There's just so much you can do with it. So let's jump in and see what a basic object looks like. So we'll say object variable, and then this is indicated by these little curly braces. This is what you enclose an object in. And then within an object, you have to give it properties. So these properties are written just like a JavaScript variable, and you can kind of think of them as variables contained within the object. So we might say prop1, and then you use a little colon to say, okay, that variable I want to assign the following value to. So we'll say we want to assign the number 20. And then to create another property, you have to put a comma after the first property. So it's sort of kind of like an array where you have a bunch of different values separated by commas, but in this case, you kind of have to think of it as a key value pair. So this is the key, which would be the prop1 or the variable, and then this is the value right here on the other side of the colon. If you want to say prop2, and then we want to set that to 50, you can do so like that. And then you put your semicolon at the end, press enter, and now we have the object variable with prop1 and prop2. Now to access these properties within the object, we use something called dot notation. So unlike the array where we would say object variable, and then you put little brackets and say 0 or something like that, we can't do that. That's not going to work. But if we said object variable dot prop1 like that, then we're going to get the value of 20. So we access the properties using dot notation, and this can be infinitely nested. So let's construct an object right here. We'll say it's a nested object, and it'll be equal to, we'll say layer 1, and then layer 2, and we're just making a bunch of objects nested within each other, and then we'll say target value will be 20. And so this target value is simply a property nested within several other properties within this object. So we'll press enter, and then to get that value, you just say nested object dot layer 1 dot layer 2 dot layer 3, and then dot target value, and you get the value of 20. So you can see how this dot notation allows you to basically grab the values of the properties off of the object. And notice how when I'm using this dot notation, I'm specifying the property. So we could also do this, so we're going back to our object variable right up here. So we can also, like I said, you can't use this 0 here, but what you can do is you can use this bracket notation. You just have to define the property that you want to grab in that bracket notation. So that's another way to retrieve a value from an object. I prefer the dot notation usually, but in some cases you might need this because maybe you know the name of the property, so you know the name of the property is property1. So instead of explicitly writing this property as a string, you might store it in another variable and then pass the property value variable into your object. I don't want to get too far into that because that's going down a little bit of a rabbit hole, but you may need both of these in certain situations. The last thing we'll talk about is functions, and we're not really going to talk about them much. But I did want to say that functions are valid things that you can assign to a variable, and this goes back to the concept of everything is an object in JavaScript. So let me just show you a brief example. We'll say function container variable just to be descriptive here. And then we can write a function like this, and this function will maybe return the value of 20. So we are storing that function in this variable, and then we can actually call this function like this and get the value of 20 that was returned from it. But we haven't learned how functions work, return values, all that stuff, so don't worry about this. I just wanted to show you that this is a variable and we can actually assign a function to that variable. So that's a valid thing to put on the right side of that equal side. All right, if you're still here, huge congrats. You're probably one of very few people that have the patience to sit through a video of mine that goes into sometimes excruciating detail about things. But thank you for watching. I just want to go through a quick summary of what we learned here and then offer you some exercises that you can use to actually practice the concepts we learned in this video. So just to summarize, when using variables, we first have to declare it and then we have to assign it a value. And these are often done in the same line of code, the same step. When we are using the different keywords, so let, const, and var, we probably never want to use var, but when we use let, it's because we want to reassign the value of a variable, and when we use const, it's because we expect the value of this variable to not change within the program. Next up, the left side of the equal sign represents the variable that will hold the value that you're assigning. So it's kind of the target for that data. The right side represents the actual value. There are many ways to write a JavaScript variable, but camel case is the preferred way. You'll see this most often in the JavaScript community. And then there are 5 main types of variables. You have strings, numbers, booleans, arrays, and objects. And those functions that we just talked about kind of fall into that object data type. So the final thing is that a semicolon represents the end of a JavaScript expression. You always put that at the end, except if you're using an object, in which case you can enter down onto multiple lines and you actually have to use commas to separate those different object properties. That's it for the summary. Now let's move on to the challenges and practice for this video. So like I said, you're not going to be able to just watch these videos and learn how to code. You have to actually apply them. And at the end of each video, I want to at least give you a few challenges to work through to apply your knowledge. So I'm going to just put these challenges on the screen here for a few seconds, and you can go ahead and work through them in the console within the Firefox DevTools that we talked about in the previous lesson and how to use that. And the answers are going to be on my GitHub account, and I'll link to those in the description so that you can see if you got them right. All right, on to the challenges for today. Good luck, and I will see you in the next video. Today we're going to be talking about JavaScript operators, and be sure to stick around till the end because I have a handful of challenges for you to try out and solve on your own to practice the skills that you learn in this video. Before we talk about JavaScript operators, I want to do a little review of what we talked about in the previous video, which was JavaScript variables and data types, because they're going to actually come into play during this video. So if we right click anywhere in our Firefox web browser and click Inspect Element, let me make this a little bit larger for us so that we can see. And then you go to the console, you're going to get into a REPL, or I think that stands for Read, Evaluate, Print, and Loop, which basically allows you to execute JavaScript without setting anything up. So we're going to be using this to code in this lesson, but also to review what we did last time. So last time we talked about JavaScript variables, and the way that you declare and assign a variable is one of 3 ways. We can say const, and then a space, and then the variable name. We're just going to call it A here, and then you give it some sort of value. This is a valid way to define a variable. We can also do it with let A equals 20, and we could, or not, we can't use a actually because we already declared this up here with the const. So we need to do something like b. And then we can also use var, but I don't recommend using this because it's kind of an outdated legacy feature of JavaScript. But nevertheless, it still works, so we can still declare and assign a variable that way. Now, we also talked about how you cannot reassign something that you assigned as const. So if you wanted to say value will not change as the variable name, and you set that equal to 20, and then you try to say value will not change equals 30, it's going to give you an error because you assigned it with const. But if you say, instead of const, you say let, and then value will change equals 20, then you can come down here and say value will change equals 30, and it lets you do that. So that's the difference between const and let. Again, we don't use var because it's kind of a legacy keyword in JavaScript. Now, we also talked about the different data types that you can use. So I'll just use the const keyword for our variables here. We'll say my string equals hello world. So we can define a string value, which is represented by these little quotations, the single quotations, and declare that as a variable. Now we can also, again, I just pressed the up arrow on my keyboard to get that last command that we typed, and we can kind of circle through all of the commands that I have typed along the way. But anyways, we can declare a string, so we'll say the second string. This is basically just a different variable, and we can use double quotes to do the same thing. So these are functionally equivalent. Some style guides would recommend that you use single quotes, others would recommend double quotes. It doesn't really matter, you just got to pick one. So that's how you define a string. And if we wanted to define a number, so my number, we just give it a number. That's pretty easy. We also have booleans, which are going to either be true or they're going to be false. So that's pretty easy. There's only two answers that you can possibly have there. And then finally, we have arrays and objects. Let me clear some space here. So we'll start with my array, and we can fill that with pretty much anything. So we can do some numbers right here. So that'll be our first array. And then maybe we can say our second array will be something like string 1 and string 2. And if you remember, we can access the properties from these arrays by using bracket notation. So we just look for the index. This would be the 0th index, the first index, the second, and the third. So we use that here to identify different objects or different values within that array. And then finally, we have objects, which are going to be a little bit more complex, and they're kind of the cornerstone of JavaScript. But we can say property 1 equals some value, and then so that's a string value, and we can access that by just saying using dot notation. So we just say my object dot and then property 1, and that's going to give us some value. We can also, with objects, use bracket notation, and if we pass in the string version of that property, it will still give us some value. So that's just a quick review of how JavaScript variables work and all the different data types. Now we're going to take these concepts and extend them a little bit further in talking about JavaScript operators. So the first thing we gotta basically resolve is, what is an operator? Well, an operator is something that exists in all coding languages, not just JavaScript, the one we're working in. You'll see these operators in anything from JavaScript, Python, Java, C, C++. All of these different languages have this concept of operators. And there's not a really great way to explain it without just jumping in, but basically how I'd summarize it is an operator is something that allows you to either compare two values or more than two values. You can modify values, modify variables, combine them together. It just allows you some more flexibility in kind of to test the different equalities of different variables. So I know that's a kind of a tough explanation, but let's just jump in, you'll see what I mean. Now there are four main types of operators. We're looking at arithmetic, assignment, comparison, and logical operators. You'll see how these kind of fit in just a second when we jump into them. We'll start with some of the easiest ones, which would be arithmetic operators. So this would be plus, minus or addition, subtraction, multiplication, and division. So you can see how this works. It's pretty easy. We can have a series of numbers, and remember, we're using a JavaScript console, which basically reads the value of a JavaScript expression and then prints it back to us. Once we start writing code in files later in the series, we're not going to be able to, like, let's just say some random variable here equals 20, and you can see that all we have to do is type in some random variable and press enter, and it's going to evaluate what the variable actually has stored in it. We don't actually have to use this console.log statement that we have been looking at in prior videos. You know, you definitely can, and it's going to print 20, but you don't have to. You can just type it the variable. So this is going to be very useful when looking at these operators here. So in any JavaScript console, you can just take numbers like this. So we'll say 20 plus 50, and that will equal 70, and it shows how it evaluates those. And this plus sign in the middle is considered a JavaScript operator. So you can already start to see what these operators actually represent. You can also do something like 50 minus 20. I'm trying to space it out here for us, but we can say 50 minus 20 equals 30. And we can also do some division. So 20 divided by 2 is 10, as well as multiplication. 2 times 2 is going to be equal to 4. So these are all what we call operators. This plus operator, the subtraction operator, division, and multiplication. And these are the most basic arithmetic operators. At this point, you might be wondering, well, what are we doing here? I've never seen this syntax written before. Well, this is not actually valid JavaScript code. It works here in the console, but if you tried to write it in a file, it's not going to work out so well. Generally, you're going to be doing these operations and assigning the value to an actual variable. So let's say that we want to do a result variable, and we want to say 20 plus 50 divided by 2, or something like that. And we save that, and now we print out the result, and it's going to be 45 because we did 20 plus 50 is going to be 70, divided by 2 is 45, and then it stores it within this result variable. So what we call the right side here, and this is going back to the prior lesson, we talked a little bit about the left side of the equal sign and the right side of the equal sign. So this equal sign right here, so we got left and then right. Everything on the right side is what we're going to be calling a JavaScript expression. And so we're using all of these different values along with the operators to create some sort of expression that is going to be evaluated in full. And then once it's evaluated, it's going to take that single value that it came up with and assign it to the variable on the left side of that equal sign. There are actually a couple more arithmetic operators as well. So we can use something called a modulus operator. So let's do 100 and then a little percent sign, and then we'll say 50, and that's going to equal 0. And basically what this is doing a division problem, so 100 divided by 50, and then it's figuring out what is the remainder of that division problem. In this case, 50 is a factor of 100. It goes into 100 2 times with no remainders, so we're going to get 0. But what if we said 100 modulus, I don't know, 77? Well, we're going to get 23 because 77 goes into 100 one time with a remainder of 23. So this may not seem very useful to you right now, but I promise you there's going to be times when you're coding where this modulus operator will come in handy. Moving on, we also have the exponent operator. So if we wanted to say, I don't know, 8 to the power of 2, so generally you would see it written like this. Well, this is not actually what the exponent operator looks like. We would have to put in 2 stars here, and we'll say 8 to the power of 2 is going to equal 64. 8 times 8 is 64. And that's how we use the exponentiation operator. So that's 2 little stars. You can remember that where the multiplication is going to be 1 star. So 8 times 2 is 16. And then if we do 8 double star 2, that's 8 to the power of 2. So that's the exponent operator. And then finally, there's a couple operators that are not going to kind of fit into this this schema that we've been looking at so far. It's going to be a little bit confusing, but I'll try to explain it best I can. One of those is going to be the increment operator, and then the next will be the decrement operator. So let's say that we have a variable. I'm going to intentionally mess this one up. So let's say that we have a starting number, and that will be equal to 0. Now notice what we used here. We used the const keyword here, so we cannot reassign this value. So the operator that we're trying to use here is called the increment operator. And the way that it works is you take a variable or some value and you put 2 plus signs at the end. And when we press enter, you're going to see that it's invalid because we have a const declaration or a value that cannot change. Now, if we wanted to declare this with the let operator, so we'll say start number, this is a different, or actually let's just clear the whole screen so that we're very clear on what we're doing here. So we'll say let starting number equals 0. Now this value can be reassigned. So all we have to do is say starting number plus plus, and when we press enter, it's going to say 0, but the actual value of the starting number variable is actually equal to 1. And we can see that by printing it out once more. And if we do this increment operator again, and then we print out starting number again, we're going to get 2. So you can see how it's adding 1 to the variable. And this is actually equivalent to saying starting number equals starting number plus 1. So you take the previous value and you add 1. So if we press enter, now you're going to see that the starting number is equal to 3. Now we can also do this with a decrement operator. So we can say starting number, actually let me clear the screen real quick. We'll say starting number, which is currently at 3, and put 2 little minus signs at the end, and it's going to now equal 2. And we can do it again, a couple minuses, and now it's equal to 1. So you might say, well, why is this useful? In many cases, when you're going through loops, which we're going to talk about in a future video, this is going to come in handy. So we just made it through the arithmetic operators, but now we can move on to something called an assignment operator. And believe it or not, we've actually already covered this. So when we write a variable, my variable equals 20, we're actually using an operator already. So this equal sign that we've talked about so much is actually an assignment operator. And believe it or not, this is the only assignment operator that you're ever going to need. Although this is all you'll ever need pretty much forever, I want to show you some of the other assignment operators that we can use, just so that you know that they're out there. But once again, these are not required, and quite honestly, I don't even use these. A lot of programmers that have been coding for 20, 30 years will never use these. So this is just for educational purposes. Honestly, I would recommend just writing your code out long form, and I'm going to show you what I mean in just a second. Let's say that we had a value. We'll assign a variable equal to 10. Notice how we use this let keyword so we can reassign this variable. And what if we wanted to add 5 to it? Well, this would be pretty simple. All we would have to do is say x equals, and then we want to take the previous value of x, which is currently equal to 10, and we add, using the addition operator, 5. So that's the end of our expression. Press enter, and now x is equal to 15. Well, there's actually a shorter way to write this, and all we have to do is use a different assignment operator. So the way that we would do this, let's start over. I'm going to refresh the page, clear out all this nonsense up here. And let's say that we have our variable, again, equal to 10. Well, we can also write it like this. We'll say plus equal 5. And when I press enter, this is actually going to reassign that variable of x from 10 to 15. So add 5 to it. And you can see that if we print out x, it's now equal to 15. So you can see this little operator here, the plus and then the equal sign. This is an assignment operator, which works the same as just our normal equal sign, but instead it's going to take whatever's on the right side of it and it's going to add it to the variable on the left side. We also have this for every different operation. So we have the plus equals So let's just start with x. We'll use this as an example here again. So we'll say plus equals 5. This should turn it into 20. We also have x minus equal to 5, which should bring it back down to 15. We have x divided by equals, and then we'll say 3, so that should equal 5. And then finally we have x multiply equals, we'll say 2, and that's going to equal 10. So you can see how we have several different assignment operators that are just shortcuts for us to do something that we could already do writing it out longhand. And what I want to say about this, like I said, you don't need these operators. All you really need is this one right here, and that's the equal sign. And the reason being is, sure, you could save a few characters of code, but it's just a lot more clear if we wanted to take our value, so let's get x, this is currently equal to 10, it's much more clear in my opinion if we just say x equals x plus 5 rather than saying x plus or equal to 5. And it just eliminates the need to memorize a bunch of stuff. You really just don't need these, and I would recommend just not worrying about them. So just to do a little recap, we have our arithmetic operators. So let me just write this out in a comment. So we have our arithmetic operators, and this is going to be plus, minus, multiply, divide, modulus, increment, decrement, and I believe that covers all of it. I apologize if I missed one here, but these are all arithmetic operators, and they allow us to basically modify different variables. We also have assignment operators. So assignment operators, and this is going to be the equal sign that we're very familiar with, the plus equals, minus equals, multiply equals, and divide equals. These are all valid assignment operators, but once again, I just recommend learning this one and being done with it. Now, the next sort of operators that we can talk about are comparison operators, and in my opinion, these are the hardest to understand because it introduces a concept that we haven't really looked at a lot yet. Let's go ahead and start with a basic example. So let's assign a result variable, and we'll assign it equal to the following JavaScript expression. And when we print out this result variable, it's going to equal true. And if you can just kind of logically think through this, not to be confused with logical operators, but if we can just think through this, 20 is greater than 18. This is actually the greater than operator. We're going to talk about all of these in a second. But you can basically figure this out intuitively. This is bigger than this, so the result should be true, right? Well, let's bring in something a little bit more complicated. So let's say something like, I don't know, constant result 2 is going to be equal to 20 equal sign 3 times and then 20. So in this case, it's a little bit harder to understand what we're doing here. We've got an equal sign here, and then we have 3 more over here. And this has probably got you thinking like, well, what's going on here? The answer to this expression is going to be true. And that is because 20 does equal 20, but we have to understand what's going on here on the right side of the equal sign before we can really think through this. So to really understand this, we have to get super clear when we're talking about the left side of the equal sign and the right side of the equal sign. We talked about this in the last lesson, but we're going to go into this even deeper now. So if we look at this second expression that we did, this is the assignment operator, and we have to be clear what we're looking at here. So the left side is going to be the variable that we're assigning the right side over here to. So this right side, as I talked about a little bit earlier, is going to evaluate to some value, some single value. And this is what we call a JavaScript expression. And in this case, we're using a special operator, which is the triple equal sign. And this triple equal sign behaves in a certain way that basically says, well, is the left side of it and the right side of it, or maybe this is a little bit confusing, is 20 equal to 20 in both value and type. So we talked about data types before, and this is where that all comes into play. So as we go through these, make sure that you're being clear about what you're looking at. So the left side versus the right side. These equal signs over here are not doing the same thing as this equal sign right here. Think of this as kind of like the master equal sign that kind of determines everything about this whole JavaScript statement, and then any other equal sign that you see are actually going to be operators that are doing some sort of comparison. When we're talking about comparison operators in JavaScript, there are four main comparison operators that have to do with equality. So we have the triple equal sign, we have the double equal sign, we have the not equal sign with 2 right there, and then we have the not equals with 1. So you can think of these two, so this one right here and this one right here, these are kind of opposites, while the double equals and the single exclamation and single equals are kind of functionally opposite. Now, what do they actually do? Well, to find out, we need to start playing around with a few values. So once again, just like we could do 20 plus 20 and get 40, we can also evaluate different expressions using these comparison operators. So if we said 20 double equals 20, that's going to evaluate to true. We could also say 20 triple equals 20 is going to evaluate to true. So what's the difference between the two? Well, the difference is it has to do with the data type that we're working with. So if you remember from the last lesson, 20 written like this is going to be very different from the 20 written like this. In the first case, we're looking at a number. In the second case, we're looking at a string. And you can see that the expression evaluates to true, but we're not quite there yet. So let's say we want a number value, and that'll be equal to that 20. And then we also want a string value, which is going to be equal to, I don't know, we'll say 50. But notice how we have these single quotations. We could also have done double quotations here. Doesn't really matter, it's just another way to write it. And so now we have a number value and a string value. And if we use the type of operator, this is actually one that we'll, we've already used a little bit, but this is actually an operator itself. And then we put the number value, it's going to evaluate to number. And we can also put in the string value, and that'll be a string. So we know that this number variable and the string variable are of number and string types, but we can try to compare them with each other using the double equals and triple equals equality. So I kind of messed up here. I meant to say that this string value should be equal to 20. So let me just go ahead and redo this once more. So we'll say string value equals 20. And then we'll say number value equals 20. And we're back to where we started here. And now what we can do is we can say string value double equals number value. And this is going to be equal, and it's going to return a value of true, which is a Boolean. And the reason being is because while these are not the same data type, they are the same value. So if we were to convert this string value into a number, so we can use the built-in JavaScript number function and pass in the string value, we're going to get 20, which is a valid JavaScript number. And what's happening here, when we compare the string value to the number value using the double equal sign, what it's doing is it's first converting them to the same data type. So it might convert the string value to a number and then compare it to the number value. So it's comparing apples to apples. And then it checks whether the actual values are going to be equal to each other. In this case, they're both equal to 20. So we have a resultant expression of true. Now, if we tried to do this with triple equals, so string value triple equals number value, we're going to get false, because this time, if we do triple equals, it's not going to convert the types to match each other. So basically what it's saying is, well, yeah, the numbers, the actual values are the same, but the data types are not, so therefore this expression evaluates to false. So when we're looking at these different, the double equals and the triple equals, the double equals does not care about the data type. while the triple equals does care about the data type. And in almost all cases, I would recommend using triple equals because we're just being a lot more explicit about what we're writing in our code that way. Well, you can see that string value does resolve the true when we compare it with the double equal sign. This is only because it is implicitly coercing the data type of these values. Now, if we did it with the triple equal sign, it's obviously false because they're different values, but like I said, we could do the number string value. So this is explicitly, not implicitly like JavaScript does with the double equals, but we are explicitly coercing this string into a number, and then we can triple equals compare it to this number value, and it's going to equal true. Like I mentioned, these comparison operators are probably the most difficult of all the operators to kind of grasp your head around. Nevertheless, hopefully this makes sense when we're talking about double equals versus triple equals. And then furthermore, if we were to set a result variable equal to the value of string value triple or double equals number value, which we know equals true right here, then what's going to happen, even though we have these equal signs on the right side, remember right side versus left side, we have this expression, this entire expression on the right side of this equal sign. And therefore what JavaScript is doing is it's saying, okay, first let me look at this expression, let me evaluate it and see what it results in. In this case, it results in true. So now I have a true value on the right, and now I want to assign this into the result variable. So we press enter, and we're going to get the value of true in that result variable. Now moving on to the not equals, or this little exclamation point with the double equals, or the exclamation with a single equal sign. These are basically the opposite of what we were doing with the double and triple equal signs. So let's try this once more. We'll say we want a number value of 20, and then we want a string value of also 20, but this is in string form. So these are not going to be equal if we use the triple equal sign, because that cares about the value and the type, but it will be equal if we use the double equal sign. Now, if we just plop in this exclamation point, it's going to reverse everything. So if we do the exclamation point with a single equal sign, and then we say string value, that's basically saying, is the number value not equal to the string value? And in this case, it is equal to the string value because we're using only one equal sign. So the answer is false. I know that's a little bit tough to wrap your head around, but if you think about it long enough, it'll make sense. Now, if we plop in this double equal sign and put in the string value, this is going to evaluate to true, because remember, if we have the in the case of, let's say, hold on one second, triple equals, this is going to care about the value and the type. So it's the same deal with this exclamation point in the double equals. So basically it's saying the number value is not equal to the string value because the types are not equal, and it evaluates to true because no, they're actually not equal to each other. So just try to reverse it in your head. Don't think about this too much. When the time comes, you'll figure out how to use these, but I just wanted to briefly go over them and show you that they're just the exact opposite of double and triple equals. Now with these equality operators, it gets a little bit tricky when dealing with different data types. So thus far, we've only compared numbers and strings. So if we said 20 triple equals 20, that equals true because it's a number in comparison to a number and they're of the same type. We can also say 20 double equals 20 because, you know, that's kind of saying the same thing. It doesn't care about the types are the same, doesn't care, but the values are the same, so it equals true. We can also compare strings. So we can say hello world, and that is going to be triple equals to hello world, and that's going to equal true. And we're also able to remove one of those equal signs, and it's going to give us the same answer because the values are the same, the types are the same, it doesn't really matter there. So we can use it with numbers and strings. We can also do booleans. So if we said true triple equals true, that's going to give us true. Now I know that's a little bit of a tongue twister there, but we're saying that the value of true, which is a Boolean, is equal to another value of true. So that expression evaluates to a truthy value and it prints true. So I've said true about 50 times in the last 30 seconds, so let me stop doing that. But basically we can do strings, numbers, and Booleans with our equality operators. Now if we try to do arrays and objects, the game changes a little bit. So let's say that we have an object which is equal to, we'll say property 1, some value, and then we'll go down. Actually, I needed to hold shift down while I did that, so let me redo this real quick. So starting over, we have my object, and this will be equal to property 1, which is equal to some string value, and then we have, we'll say property 2 is going to be equal to a number, and there's our object. We also will define my array, and this will be equal to 1, 2, 3, 4, 5, just a bunch of numbers in there. And all we have to say to prove this out is my array equal to my array? And the value here is going to be equal to true because you're comparing the same variable with itself. But let's say that we created another array, and this time it's going to equal the same exact thing. So I'm going to put in the same exact numbers, it's going to look exactly the same. We'll press enter, and now if we compare my array triple equals another array, it's going to equal false. So in the first case, when we were comparing the same variable with itself, it equals true, which makes sense. But why does this not equal each other? Why does my array not equal another array? They look exactly the same. And this is one of the quirky parts of JavaScript. You'll hear that a lot, but I'm not going to get into why these are not equal and actually how to compare two different arrays using JavaScript. It's just too complex for what we're talking about, but just know you cannot compare everything. And the same goes for objects. So if we said my object triple equals my object, it's going to equal true because we're comparing the same exact object. But if we say another object and we make that equal to the same exact one, so property 1 is going to be equal to some value, and then property 2 is going to be equal to 20. So this is the same exact object that we had up top, but this time if we say my object triple equals another object, we're going to get false. And you might be wondering, well, maybe this is just because we're using triple equals. Well, that's not the case. Even if we used my array double equals another array, it's still going to be false. And if we use my object double equals another object, it will also be false. So you cannot compare with these comparison operators arrays and objects. You actually have to use a different library in a lot of cases, and a lot of developers turn to a library called Lodash. So if we just type in Lodash into the browser, you'll see that this is a utility library that basically provides you with a bunch of different methods that you can use to do a bunch of common JavaScript operations that would otherwise take you writing a good amount of code to do. But again, this is way too complex for what we're doing right now, so we're going to go back and keep going with our discussion on operators. So we've gotten through the bulk of these comparison operators. The hardest ones are done. Now we just have to talk about numeric comparison operators. And these will not come as a surprise. We have the greater than, less than, greater or equal to, and less than or equal to operators. And you can see how these work. 40 is greater than 20, that's true. 20 is less than 40, that's also true. 20 is less than or equal to 20, that is true. And 20 is greater than or equal to 20. So you can see how these all work. They're pretty common, and if you took any sort of math class, you'll know exactly how these work. Now, the final operator that falls into this comparison operator category is something called the ternary operator. And that is spelled, let's see if I can spell this, ternary is what I'm saying here. And this ternary operator is going to look like this. So we'll say we want to assign a result variable, and we want to assign this equal to the following expression. So we'll say 20 triple equals 20. We'll add a little question mark, and then we'll say values match, and then we'll add a colon, and we'll say values do not match. And we'll press enter, and you're going to see that the result is values match. So this is a very confusing expression to look at first glance, but you will get used to this. This is something that a lot of programmers really like. Some of them do not like it because they think it makes it more complicated. We haven't talked about conditionals yet, but I think you'll be able to understand this a little bit, so I'm going to try to explain it real quick. This expression right up here is going to be functionally equivalent to the following expression. So we'll say if 20 triple equals 20, then we'll say return, or actually no, we need to redo this real quick. We need to first say or declare a variable. So we'll say result variable, and we don't need to assign a value to it yet. We'll say if 20 triple equals 20, then we want to assign the result variable equal to values match. And if it does not equal, so else, then our result variable is going to be equal to values do not match. If I can spell right. Okay, so when we press enter, it's going to say that it evaluated to values match, just like it showed up here when we printed the result. And if we type out result variable, you can see that it has been assigned that value. So I wanted to show you this, even though we haven't gone through the if-else statements yet, the conditionals, but I think it's fairly intuitive to understand. We're saying if this expression evaluates to true, then I want to assign the variable to what is after this question mark, or the values match. Otherwise, this else statement, which is going to be substituted by the colon, we want to assign it to values do not match. So in other words, this question mark is kind of like the if part, and this colon is kind of like the else part. And this everything left of the question mark is going to be the expression that we're actually evaluating. And remember, this is where it gets, this is where it's kind of confusing when you're first starting out. Remember, we have to keep the right side and the left side separate in our head. So we're looking at this equal sign. What is to the left side of the equal sign? Well, that is the result variable. Now, what is to the right side of the equal sign? Well, that's everything here. So this entire expression is to the right side. And when JavaScript looks at this, the first thing it does is it says, what's on the right side? And furthermore, how do I evaluate that? And then it uses the rules of this ternary operator to say, okay, first I want to look at 20 triple equals 20. What does that resolve to? Well, that resolves to true for reasons we discussed before. And therefore, I'm going to grab this value right here. Now, if it would have resolved to false, then it would say, okay, I don't want this. I actually want this one over here. And then once it's found that answer, it's done all of this work on the right side, it's come to a single answer, which is the values match. Now it's going to assign that to the result variable. So you have to be very clear with yourself whether we're talking about the right side, which could be a really long expression, or the left side, which is the target variable that we're assigning the end result of the right side to. We are finally done with the comparison operators. I know this took up most of the video, but they are very important, and you'll see why once you start writing a good amount of code. You're going to use them a ton. Now, the last type of operator is what we call a logical operator, and there's only 3 of them. We have this double and sign, we have the double pipe sign, and then we have the exclamation point. Now, the exclamation point is kind of the same as what we talked about earlier with this exclamation equals, but it's kind of going to function in a different way, using it as a logical operator. We'll start with the and sign, and basically all this is doing is it's saying it's looking at 2 different expressions, so 20 triple equals 20, and then we put the and sign, and now we can say 10 triple equals 10. And what it's saying is, okay, on the left side we have this expression, 20 equals 20, which evaluates to true. And then in order for the entire expression, so this whole line, in order for this to be true, both sides have to evaluate to true. So in this case we get true, but we could also say 12, and in this case it's going to be false because the left side does equal true, but in order for the entire expression to be true, both sides have to be true, and you can see on the right side these are not equal, so we get false. Now the OR operator, if we did the same example and we said 20 triple equals 20, and then we use these double pipes, this is basically OR, and now we can say 10 triple equals 12, and it's going to be equal to true because it's saying this entire expression is going to be equal to true if one of them is equal to true. So in this case, the right side is equal to true, and that's all that we need for this to work. Now, if we tried to write this expression where both sides are actually false, I actually did that wrong there. We only have one pipe in there somehow. So we'll say 20 triple equals 18, double pipes 10 triple equals 12. Both of these are false, so it's going to be false. Now, the last one that we're talking about, let me clear the screen, is going to be this exclamation point. What the exclamation point does is basically reverses everything. So generally we're going to be talking about a Boolean value here. So let's say that we have an expression 20 triple equals 20, which evaluates to true, obviously. If we put some parentheses around this, and then we, it still equals true, but then we put an exclamation at the beginning of that statement, it's going to reverse it to false. Now, it's important to note you cannot put this at the end. That's not valid. You have to put it at the beginning of the expression that you're trying to reverse. So that's what this exclamation point does, and it's a little bit different than if we were to put in the exclamation and then the double equals. That does a slightly different thing as we talked about earlier in the video. So just to show you a practical example of how you might use one of these, this is a pretty common one that I've seen and I've used in my apps. And we're not going to actually be writing the code that I would write in an app, but you'll kind of get the point. So we'll have a variable that says is user logged in, and we'll set it equal to true. So our user is going to be logged in this case, and then we'll say does user have permission, and we'll say false on this one. So it might be a pretty common thing to see if we were to check both of these values to see whether a user can perform a specific action in an app. So what we might do is we'll say can user perform action, and then we'll set that equal to is user logged in and does user have permissions. And in this case, if we were to evaluate this expression on the right side of this equal sign, the is user logged in is true, but this does have permissions is false. So this entire expression resolves to false. So in many cases in our apps, we might say if can user perform action or something like that, then we can allow them to perform the action. So that's just a practical example of how we might use these operators in the real world. And the final part of this video, before we get to the actual challenges that I'm going to give you, is going to be combining all of these operators. And this is where this concept of an expression really comes to life. So I'm going to put a pretty complex expression on the screen here, and we're going to walk through how it's actually working. So we'll say result is equal to exclamation point. We're going to put a couple parentheses here. Say 40 divided by 20 equals 2, and then we'll say something like, I don't know, true, and then we'll say on the right side, try to make this clear, we'll say or, and then put another parentheses, yes, triple equals to no. And when we evaluate this expression, we're going to see that it equals false. And this is actually a totally valid JavaScript expression, although it's very confusing to look at. But if we take this step by step, I think you'll understand how we can combine all these operators into a single expression. Now, I will say before we get into this, you generally are not going to be writing something this complex. If you're writing something that is this confusing to read, then you could probably break it out into several steps, and it's not a sign of intelligence when you're trying to make it so complicated like this. You want to be as simple as possible, and in many cases, you're going to write more lines of code in order to improve readability of your code. So this code is not readable. This is something that would take someone, let's say that I wrote this code and you had to go review this code. This is going to take you, at least 20 seconds to figure out what it's doing. And in most cases, we want it so that you can see exactly what the code is doing as quickly as possible. Nevertheless, we can see how this evaluates by breaking it out into different steps. So I'm going to just store each step in a variable, and then we'll kind of work our way down to understanding the entire expression. So if you remember, we're talking about the right side versus the left side. Left side is the variable, right side is the entire expression. So we'll say step 1 is going to be equal to 40 divided by 20. So we'll start right here. So we'll save that into step 1. Now the second step is we take this 40 divided by 20 and use the equality operator to set it equal to 2. So we'll say step 2 is going to be equal to step 1 triple equals 2. Okay, so now we can check this at this point. We're equal to true right now. And the next step is going to be taking this entire expression that we just basically combined into step 2 and adding the and sign and putting it to true. So we're going to say const step 3 is going to be equal to step 2 double and true. And you can guess that since we already had it equal to true right here, and we're doing another Boolean value of true, it's going to equal true. So step 3 is actually equal to true right now, and you can see that right there. And now we want to combine this with, we've already done this entire expression here, so maybe we want to store this in a variable. So we'll say step 4 is going to be equal to yes triple equals no, which is obviously going to be equal to false. So that's our step 4. So now let's take our step 3 right here and our step 4 and combine them using these double pipes. So we'll say step 5 is equal to step 3 double pipes and then step 4, and that's going to be equal to, let's see, step 5 will be equal to true. I'll try to scroll up here. So we've got this one, and this entire expression evaluated. So the last thing we need to do is just add the exclamation point at the beginning of everything. So all we have to do here is say step 6 is going to be equal to not step 5, and step 6 is going to be equal to false. And if you see up here, the total result of this entire expression is equal to false. And all of these steps that we did down here were just intermediary steps that we used to kind of break out this entire expression and figure out what the result variable was ultimately assigned. So in summary, an expression on the right side of the equal sign can be as complex as you want it to be. And furthermore, it can actually be something other than just what we've been working with. We've been just looking at simple variables like numbers and strings and simple comparisons, but it can be much more complex than that. So you could even have something like a function evaluating to a specific variable. So let me refresh the page, and we're going to set result equal to a function. And we haven't covered this yet, but I just want to demonstrate what I'm talking about here. So in this case, we're going to return 20 from that function. So what's happening here is, again, we have to be very conscious of the left side versus the right side. So left side is going to be our result variable, and right side is going to be the entire function. So in this case, we're going to set the right side equal to a function that returns a value of 20. Now this is not going to automatically execute itself, so we have to actually assign it using something called an immediately invoked function. And once we do that, we're going to actually be assigning that result variable on the left equal to whatever this function here returns when it is evaluated. So you can see result is equal to 20, and this kind of just demonstrates for us how the right side of this equal sign can be infinitely complex, and that's why it's so important to understand that an expression should be solved in individual steps. That's how the computer looks at it, and that's how I would recommend you to look at it when you're trying to figure out what it's going to set that variable to. Like I've been saying throughout this series, watching these videos alone is not going to do it for you. You have to actually practice. So let's jump into some of the challenges that I've put together for this video. And I'll say that as we get better writing code and as we go through all of the different parts of JavaScript, not just variables and operators, but getting into loops and functions and conditionals and basically learning how to write code, we're going to actually migrate ourselves over to a site called Code Wars. So if you go over to codewars.com, you're going to see this is actually a pretty popular site for doing different programming challenges, and I'm going to actually start recommending challenges from this Code Wars site, and we can basically work on them. I'll have a profile, and you can kind of go through these challenges on your own. But for now, we're not quite advanced enough to look at that, so I'm going to pop up a few challenges on your screen, and then I'm going to walk you through each of them and how we go about solving them. If you want to get the most out of this, I recommend trying them on your own first, so pause the video for each of them and try to work them out in your browser or your DevTools console, and then once you've figured them out, I'll kind of go through the explanation. Alright, so this is the first challenge, and the question is, why does this code not work? And the answer is going to be because of the const declaration that we've made at the beginning of the code. So if you remember, when using const, we cannot reassign the value. So if we say const number variable equals 0, and then we try to reassign this using our increment operator, it's going to give us an error. But if we go ahead and change that to let instead of const, so we'll say let number variable equals 0, and then we can say number variable plus plus, number variable plus plus, and then do it one more time. We're going to be able to do that, and then in the end, if we console.log number variable, it's going to be equal to 3. So that is the solution to the first challenge. Challenge number 2. So this one is a little bit of a trick question. These are not going to evaluate to the same value. I think you could probably figure that out. But the second part of this question is, which one of these would you recommend? And the answer to that, I would not recommend either of these blocks of code. So the first one is going to evaluate to false because we're using triple equals, while the second one is going to evaluate to true because we're using double equals. But in this case, the problem is not either block of code, but the variables that we're declaring. So this is how I would actually write this rather than what we have in both of those code blocks. So we'll say first number equals 20. We'll say the second number also equals 20. And instead of the string value, let's just put a number in there. That's the real solution right there. And then from there, we can define our result, which will be equal to first number triple equals second number, because we always want to favor triple equals, be explicit when we can. And then now we can print out the result, which is going to be equal to true. So that's how I'd solve that problem. Challenge number 3. Now this one is a little bit trickier, but I think you probably could have gotten it. Let's refresh this screen real quick. Now the question was, what does the expression 5 resolve to? And the answer to that is that expression 5, let me make sure I get this right here, answer 5 is going to resolve to false. And this is why it's going to do that. So let's just walk through each of the lines and see what they resolve to. So we have 100, we'll save them in the variables, so expression 1 is 100 modulus 50, and if you remember, 100 divided by 50 is 2 with no remainder, so we should get 0 for this. So expression 1 should be equal to 0. You'll see that here. Now expression 2 is going to be equal to 100 divided by 50, which does equal 2. So that's going to be equal to 2. Then expression 3 is going to be equal to expression 1 is less than expression 2. And in this case, expression 1 was equal to 0, and expression 2 should be equal to 2. So this expression right here should evaluate to true. So let's press enter on that and see if that's the case. We'll say expression 3, that equals true as we would expect. Now expression 4 is going to be equal to expression 3. We'll use the and symbol, and we'll say 300 plus 5 triple equals 305. So this is a little bit trickier. How we look at this using the order of operations is we first look at this one on the right. So we'll say 300 plus 5, what does that equal? That equals 305. And then so we replace this basically and say 305 is triple equals to 305, which is going to be equal to true. So then we kind of replace that with true, and expression 3 is true, so they're both true, and expression 4 is going to result in true. And then finally, we're just going to reverse that, so expression 5 is going to be equal to exclamation, or the reverse of expression 4, so it's going to flip this true to false, and we're going to get false for the final answer. And if you tried to solve the problem of getting this all into one expression, I'm going to just copy this into the console and just show you how it works. You can see that we get false just like we just looked at, and this is how I would combine this into a single expression. Remember, the order of operations matters here. Moving on to challenge number 4, this is actually a slight review of last time combined with the concepts that we learned in this video. So we're looking at an object and an array. So we'll say my object, I'm just going to write this out so that we have something to work with. And we'll say prop1 is equal to first value, and then prop2 is going to be equal to 20. So there's your object, and then your array, so my array here, is going to be equal to 40, 50, and 2. Now, if you remember from last time, the way that we access properties from objects and arrays is with dot notation and bracket notation, respectively. So if we wanted to, say, get this value of 20 from this object, all we would do is say my object dot prop2. You could also use the bracket notation with a string for prop2, and that will give you 20. But I would always prefer using this dot notation, so we'll just get it this way. All right, so if we wanted to get one of the values from this array, say we wanted to get 50, we would have to use bracket notation. And if you remember, an array is 0 indexed, so this is index 0, this is index 1, and this is index 2. So if we wanted to get that 50, all we would say is my array bracket, and then we want to pass in 1 because the index of 50 is 1. And that will give us that value of 50. So knowing that, this problem gets pretty easy. So we said in our result array, we are saying my object dot prop2 triple equals, and then my array 0 divided by my array 2. So if you remember, we'll store that in the result variable for now, but you just have to basically break this down into different pieces. So what is my object dot prop2? Well, that equals 20. Now, what is my array with the index of 0? Well, that is going to be equal to 40. And then what is my array with the index of 2? That is going to be equal to 2, if I can type it out here. So we got 2. So basically what this expression is it's saying 20 triple equals 40 divided by 2. And if we look at that expression, that's going to resolve to true because 40 divided by 2 is 20, set equal to 20 is true. So if you break it down into pieces, it's not all that hard. Now, challenge 5 is a little bit of a tough one, but we're going to use the same method that we did in challenge 4 to solve it. So I'm going to actually just copy in the object and the array, or basically just all the code here. So we'll copy this in, we'll resolve it, and let's open this up, and we need to print the result, which is going to be true. Now, we have to walk through each step of this one by one to really understand it. So the first thing that we have to remember is how to access different properties. So if we wanted to access the quantity of nested object 1, all we would have to do is myObject.nestedObject1.quantity, and that's going to give us a value of 5 down here if we were to evaluate that expression. Now, the only tricky part here is this line right here. We're actually putting the array, or we're assigning each of these nested objects as the values of this array. So to access this nested object number 2, we could do one of two things. We could say myObject.nestedObject2, and then we might say the price, which is going to give us 150. Now, since we put this into our array here, we can also access it like this. So we can say myArray, and then we would say we want the nested object number 2, which is the index 1. So this is index 0, this is index 1. So we're going to grab index 1, and you can see it's really nice in the console. You'll see exactly what that evaluates to. And then from there, we can use dot notation to get the different attributes from it. So the price, which is 150. So knowing this, it's pretty easy to evaluate this expression. So if we looked at myArray0 dot price, which is the first part of our little expression, this is going to evaluate to 100. Then we can say myArray0 dot quantity, which is going to be 5. And then in the second part of this expression, we have the second object in the array, and we're just getting the price and the quantity. So really what this result variable is saying is it's saying we want to look at 100 times 5 and compare that. We'll say that's greater than, and then we'll say 150 times 2. And what this evaluates to is true because 100 times 5 is 500, which is greater than 150 times 2, which is going to be 300. So that's going to give you the result variable, and you can see how if you just break it down into little steps, you'll be able to figure out what the expression equals, and you can actually access nested objects and array properties by mixing them together. In today's video, like I said, we're talking about functions, conditionals, and loops. And in the previous videos, in lessons 3 and 4, we talked about JavaScript variables, how do we declare and assign a variable, and then also JavaScript expressions, which includes all of the different operators, whether those be arithmetic operators, assignment operators, logical operators, etc. That's what we're going to do in this video. We're going to cover a lot of ground here, and then we're going to supplement it with a ton of practice problems. So I'm making a video where we're going to have 25 JavaScript challenges, and I'm going to walk you through them and kind of explain how I'm going about solving them, what I'm thinking about, and we're going to use the topics that we covered within this video and the previous lessons to kind of solve these problems, and we'll fill in a lot of the gaps that are not covered in the main content. All right, let's jump into conditionals in JavaScript. So we've actually covered this already, just briefly in previous lessons. We haven't talked about how it works though. So let me show you a basic conditional statement. We're going to say if some string, so we're talking about a string data type, is triple equals to, so we're comparing value and data type, another string. So these are obviously not going to be equal because although the data type is the same, the value is not. If that is the case, we're going to console.log the strings are equal. And then if it's not, we're going to say else, and we're going to console.log the strings are not equal. All right, so that is our basic conditional statement. When I press enter, you're going to see that the strings are not equal. So it basically went into the second code path. That's what we kind of call it, is the different paths that the code can take. So we're saying if this is equal, then I want to execute the code within these two brackets. Otherwise, so else, we're going to execute the code between these two brackets. So there's a couple things I want to point out here just to connect the dots for the previous lesson that we talked about. So let's just get the basic structure of an if-then statement. We have if and then else, and this is basically what we're looking at. And obviously there's indentation, line breaks, all that kind of stuff. That's just formatting, but this is the basic structure. So in this parenthesis, we have a JavaScript expression. And then we have some brackets that contains the code for the truthy code path. So if that expression evaluates to true. And then we have a brackets where we can put our code for the falsy path. So if the expression is false. And we've previously covered expressions in JavaScript in terms of variables. So we might have said something like, I don't know, say 20 triple equals 20 and 50 triple equals 50. So obviously both of these are going to evaluate to true, and then you combine it with the and operator, and the whole expression evaluates to true. And then we assign that true value to the variable right here. Now, that's all we've looked at in prior videos, but you can actually take this expression, which is right of the equal sign, and you can drop it into this parenthesis for the conditional statement. So just a different way to use an expression. You'll see it a lot, and it's something that I think is worth pointing out. I'm going to drop a couple of different ways that we can write conditionals on the screen. So it's a lot of code. We're going to walk through each of these. So let's open this up. So I've declared a couple of variables up top. So we have two number variables, 20 and 10, and then a JavaScript expression, which is basically saying is the first number greater than the second number, which is going to result in true. And then we've put these in some different conditionals. So the most basic one that we can do is going to be a basic if statement. So you don't even need to have an else statement at the end of this. You can just use if. And this is actually really useful. You'll see as you start coding when this comes into play. So we're saying if this JavaScript expression is equal to true, that's what we mean by just putting it in there. So usually you're kind of getting used to seeing like an equal sign put in an expression. Well, if we're looking at a Boolean, all we have to do is drop it in the parentheses, and it's going to evaluate to either true or false. So since this does equal to true, we would expect that this console.log statement will be reached, and it'll print this expression is true. And if you come down, the first console log has been printed right here. Now, moving on to the next one, we have an if-else statement. I'm going to skip over this because we just covered it. Basically, if JS expression is true, console.log this, otherwise this. And then finally, we can include other conditions. So not only can we do an if-else statement, we can also add some other code paths for our code to go down. So if this is equal to true, we want to console.log the expression is true. Else, if the first number is greater than 0, so basically what we're saying here is, I closed that out there. But if the JS expression is false, we're going to skip this first block of code, and then we're going to go to the next condition. So we know if we get to the next condition, that first one is going to be false. So we know JS expression is false, and then we're checking if the first number is greater than 0. If that is the case, then we're going to say the expression is false and the first number is greater than 0. But if it is false, so if the expression is false and the first number is less than or equal to 0, we're going to fall into the else statement, which is basically a catch-all for any other condition that we might have. So the expression is false and first number 0 or less. So in this case, obviously the variable is true, so we go down this first code path and you see this expression is true down here. Or I guess the expression is true. And then finally, the last one that we have is just a formatting difference. So we have an if statement, but we've put it all on one line. And this is just to demonstrate that we don't have to format it all pretty like we did up here, although it helps for code readability. And in other languages, such as Python, the indentation and formatting actually does matter for running your code. But in JavaScript, it doesn't. It's more of just a readability thing. The last type of conditional that you might see is called a switch case statement. And this is equivalent in many ways to the if, else if, else if, else if, else type conditional. So if you have a lot of conditions that you're testing, then a switch case statement might be appropriate for you. So let me paste some code on the screen again, and we're going to execute this. The output is the color is blue, and we'll see exactly why in a second. So first I put an array up here, and I put the indexes or indices on top. So the first one is an index of 0, 1, 2, 3, 4. And then we have to get a random index. So this is just some code that I wrote. You don't have to understand this, but we're basically going to get a random number between 0 and 4 and assign it to this random index variable. So just think of this random index variable as carrying any value between 0 and 4, which happens to correspond with the indexes of the colors array. Then we're going to grab a random color from the array. So remember, we can get something from an array by passing in the index value using bracket notation. And since random index here carries one of those values, we can pass that in to the colors array. So the right side expression is going to evaluate to one of these colors, but we don't know which one because we have a random index being generated. Then we come down here and we can write some basic conditionals. So if the random color, so again, this is going to be one of the array values. If it's orange, we're going to say the color is orange, and then you can kind of look down here and just see it's doing the same thing for all of the different conditions. If we get to the last else statement, there was no color found, but that's never going to happen because we know that we have an index between 0 and 4. In this case, the color turned out to be blue, but it was a random color, random choice. We didn't know that as the developer before it happened. Now, the reason that I bring this up is because this if-else-if statement, where we have a lot of else-ifs in here, it gets very confusing and it's tough to read sometimes. So this is why we might want something like a switch case statement, and I'll show you the same code written in the switch case format. Oh, and by the way, if you're tired of getting into this browser console, remember you just right-click Inspect Element to get here. I promise you we're going to get to an actual code editor soon, but I just want to keep this focused on JavaScript. We're not getting into setting up a local development environment yet. So anyways, here is that switch case statement. Same thing up here, same colors array, same random index, same random color. Obviously, since it's random, it might not be blue, which I think is the one we last saw. So let's press enter. It did turn out to be blue. Might have been a coincidence there. But basically what we're doing is everything's the same up here, but we come down to the switch statement. And what we're saying is that we have a switch statement and we put the expression that we're evaluating in the parentheses. So similar to the if-then or the if-else statement, we can put in that condition into the parentheses, and then we come into these little brackets, which is going to contain a bunch of cases. So if the case is orange, or in other words, if the random color variable evaluates to the value of orange, then we're going to hit this code right here. And when we hit this code, sorry about that, when we hit this code, the color is orange, it's going to print that to the console, and then this break statement is a special statement that we can write to basically say, okay, I've found the correct case, now stop executing the code entirely. So if we were to get the random color orange, it's going to print it to the console, and then it's going to break, and then basically all of the rest of this code down here will never be reached because we broke out of that statement. So that's what it's doing. It's basically just going down the different cases. It's saying, okay, what does random color equal? Does it equal orange? No. Okay, does it equal green? No. Does it equal yellow? No. Purple? No. And then we finally get to blue, which it does equal, and so it's going to console log that and then break out of the switch case statement. Now there's this last condition down here, which is called default, and this is basically the catch-all. This is the else statement in our conditional, and it's saying if random color does not evaluate to any of these cases, let's go to the default value, which we're just going to say no color is found. So that is the basic switch case statement. Let me write this, let me refresh, and I'm going to write this in a little bit simpler format. So we have switch, and then here we have case, or the different cases, and then the break statements. So this is obviously not valid, but we have a switch, then we put our condition in here, which can be any JavaScript expression, and then between the brackets we put all of the different cases. So switch case statements, how often are you going to use them? Well, in my experience, I haven't used them a ton. Usually an if statement or an if-else statement is going to be sufficient. And oftentimes if you start using too many switch case statements, that's kind of an indication that you may not be writing the most efficient code. But that's to worry about later. Right now, I just want you to kind of be aware of this, understand how it works, and just be familiar when you look it up and try to use it for the first time. All right, continuing on lesson 5, so conditionals, functions, and loops. We're going to talk about loops right now. And looping in JavaScript is a very effective concept, and you will use it all the time. So you really have to understand this. There's not a whole lot to it, but I think the hardest thing is understanding why we need loops in the first place. As we go through coding challenges a little bit later, and you do more coding challenges just in general, you're going to use loops a lot, but it's generally just to solve some sort of challenge. So you often will wonder to yourself, well, why do we actually need this in the real world? And the reason, at least in my opinion, the reason we have loops, or the most common use case of a loop, is to iterate or loop over a set of resources. So when we're talking about something called a resource, that's basically saying that we have a bunch of pieces of data that are very similar to each other, so often stored in a database, and that might include something like, if you have a blog, it might be a blog post. I'm trying to think of another thing. If you're running an app, you have a bunch of users. And there's a lot of different concepts that you can replicate, but basically resources is a list of similar types of data. And when we have those, it's more efficient to actually loop over those than to manually print them out. So again, if we have an array, something like this, so I'll just say array, and then we have 20, 40, 60, something like this. We can go ahead and print to the console using this bracket notation. So array of 0, and then array index 1, and array index 2. So that's how we can manually print each value of the array. But when you have 1,000 different blog posts that you want to render onto a web page, it's not going to be efficient enough for you to just go into your code and start typing out each and every index. Not only that, but once we add new blog posts to our database, we're going to have to go in and change the code, which is going to be extremely cumbersome. It's not recommended. You won't get away with that in software engineering. You have to do things more efficiently, and that is when loops come in. To demonstrate this, let's take a look at maybe a sample array of blog posts. So this is not something that you have seen before in my tutorial videos because we've been writing arrays on a single line. But arrays, just like conditionals and anything else in JavaScript, can be indented and broken onto different lines. This is all just a formatting thing. So basically what we're doing here is we have 3 different objects. So here's one object, then we have another object and a third. And you can see these objects are very similar looking. In each of them we have a title property, an author property, publish date, and content. Now obviously the values of these properties is going to be a little bit different for each of the objects, but you can see that you can already start to infer that if we're looping over this array of blog posts, we can use the fact that they have similar properties. And let me just show you something really quickly that we could do using a loop. Now I'm not going to explain how the loop works yet, but just to show you what I'm talking about. So let me collapse this so that we have some room here, and I'm going to paste in this line of code. This is what we call a loop, and there are several ways to write a loop, but again, I'm not going to cover that quite yet. But what you can see is that instead of hard coding the indices that we are passing in to our blog post array, so in other words, we want to retrieve a certain blog post object from that array, we would need an index to do that. Instead of hard coding it, we're using this variable called I. So all I'm doing with the first 4 variables here is I'm grabbing a specific object from this array, so I'm only grabbing one of them, and then I'm taking all of the properties and grabbing the value of those properties and assigning it to each variable. Then I'm printing the variables below. So when I press enter, you're going to see it loops through all of our blog posts pretty much instantaneously, or at least it seems like it to our human brain. And it's going to loop through and it's going to print each of the values for each of the blog posts. So this is our first one. What is JavaScript? It's by me, December 20th, 2020, and some post content here. And you can see that that is the first object in that array. And then we go to how do arrays work, and then how long does it take to learn coding. So you can see that here, and then finally here at the bottom. So we have looped through every blog post in that array. Now let me talk about how these arrays actually work. We're going to go into a little bit simpler examples so that you can really isolate these concepts in your head. So let me write a basic loop in JavaScript. So we're going to let I equal 0. We're going to go until I is equal to 100. That's just an arbitrary number that we're coming up with. You can obviously pass a variable in place of this like we did with that first example. And then we're going to increment the value of I. So remember this from the last lesson. This is basically the same thing. I'm going to come out here just for a second. That's the same thing as saying I equals I plus 1. So basically saying if I is 0, then we're going to increment it by 1. And then we're going to put some brackets here and press enter. And so everything within these brackets here is going to be considered one iteration of this loop. So the code within these brackets is going to be executed as many times as we do this loop. In this case, we've set the stop condition at 100. So let's walk through each of these and kind of connect the dots between the previous lessons that we've talked about in this series, and I think you're going to really understand this. So the first thing that we see here is we declare this for loop using the for keyword. So this is similar to how we have an if statement. So we say if, and then we put parentheses and some brackets. Now we're just saying for. Now in the parentheses is going to be the loop conditions. The first one is going to be the variable that we're looping over. So let I equal 0, and notice this semicolon to end that statement. We're just starting I at a value of 0. And the reason that we start it at a value of 0 is because arrays start at an index of 0. So it makes sense that if we're looping through our array, we want to start at the first value in that array, which has an index of 0. You might also ask, why do we choose I? What is I? Well, I is just a variable. We could put in anything that we want. We could say my iterator or something like that. And then all we have to do is replace each occurrence of that with our new variable. So we can choose whatever variable name we want, And if you see this entire expression, this is very similar to, or it's the exact same thing that we use to declare a variable in JavaScript. Now, the one thing you'll notice is that we're using the let keyword, and that is really important. It's important because this iterator variable, so I'm going to flip this back to I really quickly because this is kind of like an industry standard. A lot of developers will just use this as a convention when looping. So we're going to use the let keyword because I is going to be reassigned throughout the loop. As you can see at the end, we talked about this is going to add 1 to I after each iteration of the loop. So that's basically the same thing as reassigning it. And if you remember from the previous lesson, when we try to use this increment operator on a variable that was declared with the const keyword, it doesn't work. It throws an error. So that's why we need the let keyword in here. And then finally, we have this code in the middle, which is probably the most difficult to understand. This is the stop condition. So basically what we're saying here is we want to go through this loop. We want to do as many loops until I equals a value of 100. So each time we go through the loop, it's going to increment by 1. So basically, since we're starting at 0 and we're saying less than, we're going to go through 100 iterations of this loop. So all I'm going to do here is just demonstrate this. I want to console.log the value of I, and you're going to see when I press enter, it's just going to go 0 to 99. So we press enter, and we got 99 here at the bottom, and we started at 0. So that's 100 iterations, remember, starting at 0, ending at 99. And the significance of this is, we printed console.log, we just printed a number here, but you can do all sorts of things like we saw with the blog post array. You can loop through the blog post array and assign values and all that kind of stuff. To finish this topic off, let's just go through a super simple example. So let's make an array. We'll call an ARR for array, and then we're going to put in a couple different values here. So I'm just going to put some random strings in here. These are string values, nothing of significance. Just put whatever we want. And then let's put in some numbers. And then a couple more strings. And what we're going to do here is combine our knowledge of conditionals that we looked at in the previous video and looping to do an example. So let's write our loop here. We'll say I equals 0, and then we want to go until the array is complete. So you'll use this quite often where you're going to look at the array you're looping over, and you're going to grab the length of the array because that basically means we're going to loop until there's nothing left to loop through. So that's a very common thing that you'll see within arrays. And then, of course, our increment operator, and then we'll jump into our loop. And then in this case, we want to set a conditional. So we're going to say if the type of array, and then we'll pass in I. So remember, this I is going to be incrementing each loop of the, or each iteration of this loop. So it starts at 0 and then it goes 1, 2, 3, 4, 5, all the way up to the length of this array. So when we pass in I, we're basically saying, okay, I want to grab whatever's in this array at the index that I is currently at. So it'll start with 0 and we'll grab this first value, then it'll go to 1 and we'll grab this value, so on and so forth. So we're saying the type of the array value. So basically, this is equivalent for the first iteration of this array. If we copy this down here, the first iteration is basically going to be saying type of this value. And of course, this is going to return string as we've seen in prior videos, while the numbers are going to return the type of number. So let's bring this back to what we had previously. So we grab the array variable and we pass in I. And what we're going to say is if the type of the array, and I actually didn't even put a condition in here, if it equals number, so that's what it will return if we have one of these numbers, then I want to console.log the array at that index. So basically what this loop is going to do is it's going to loop through that entire array, and it's going to look at the value, see if it's a number, and if it is, it's going to print it to the console. In other words, we're going to skip all of those gibberish strings that we put in there. So let's press enter, and you can see that we have only the numbers printing. So this is just a super simple example that demonstrates how we can use an array to quickly iterate over, or use a loop, sorry, to iterate over an array. In this part of lesson 5, we're talking about functions, and we finally get to do something fun with JavaScript. In the previous videos, previous lessons, we've been talking about the rather mundane parts of JavaScript, things that you can't really do much with. But when we combine all of those concepts with functions, we have limitless possibilities that we can have with JavaScript. Of course, there's other things, but like I said, in this video series, I'm taking you through the most important parts. We're not going into the super fine details yet. We're going to do that through practice problems and through real-world practice. We're going to fill in those gaps there. So again, we're talking about functions in this video, and the first way that I want to start this out is by writing out a basic function. So here is how we write a function in JavaScript. We're going to say my function. So if you notice, this is kind of similar to what we've been doing with the if statements, the conditionals, and the loops. We have some sort of keyword at the beginning, then we have, well, this is different, we have a name of the function, and then we have a parentheses. So it's kind of similar syntax, and then we have these brackets here where our code will go. So with the function, we have to give it a name here. And in the parentheses, we don't actually have to put anything in there. We'll talk about that in just a second. Let's go ahead and print something. Hello world, this is my first function. We're going to end that statement with the semicolon and press enter. And what you'll notice is that it doesn't do anything. And this is different from what we've talked about with some of the previous concepts where everything happens at once. So remember, if we, declare a variable, set it equal to 20, something like that, when we press enter, the variable is declared and it's assigned at the same time. And with functions, what's happening is we break out those steps into 2 steps. So up here, what we've done is we've declared the function. But what we haven't done is called this function, or what we call invoked this function. Those are kind of synonymous terms. In order to do that, we just grab the name of the function, which, as you can see, similar to this variable, this my function word right here, this is just a variable that the computer remembers. So since the computer remembers it, since we already declared it, it's going to recognize it when we type it out. So if we said type of my function, it's going to give us function because it remembers what that is. And to execute this, so I'm kind of using all these different words, to execute a function, to call a function, and to invoke a function. For our purposes, they are all the same thing. So anyways, we call the function using these 2 parentheses right here and a semicolon. And when we press enter, it's going to say, hello world, this is my first function because it ran the code within the function. So just to review, with functions, you first have to declare it, and then you have to call, invoke, or execute it, all the same kind of terminology. Now, there is one way that we can declare and call the function in the same step. And although you're not going to use these all that often, I do want to show you them just so that you have an awareness of them. And what these are called is an immediately invoked function. So let's say that we write another function, so another function here, and we enter down, we say console.log, hello. Now, if we pressed enter, this is going to just declare it. But all we have to do is wrap this entire function in some parentheses, and then put our parentheses that we used to call it at the end, semicolon, and you're going to get this function to declare and execute at the same time. Obviously, the computer does it in different steps, but for our purposes, it's happening all at once. This is what we call an immediately invoked function. And like I said, you're not going to use this a ton, but just be aware of it. You might see it pop up in some Stack Overflow answers, or you might even use it at some point. So we got a basic function, but it's not useful. Like, what are you going to do with the function that we just wrote? Obviously, there's more to it, and the thing that I want to introduce next is the concept of parameters and arguments. And what I would say with these two terms is they're kind of two sides of the same coin. And once you get into more advanced programming, programmers are probably going to be using these parameters and arguments terms interchangeably because, like I said, they're two sides of the same coin. But for our purposes, we're going to distinguish between these. So let's write a function. We'll say my function again, and we'll enter down onto a new line. Now, what I want to do to add into this parenthesis is going to be something called a parameter. Now, these parameters are basically saying to the computer, hey computer, I'm going to pass in some sort of values into this function, so be ready for them. So basically what I'm going to say to this function is, hey, I'm going to pass in some number, and then I'm going to pass in some string value. Now, obviously, with JavaScript, it's a dynamically typed language, so you don't have to say like some number or some string. This is just an example. Maybe we could even say something like param1 and param2. So let's just go with that. These are arbitrary names that we have. And then what I want to do is console.log param1, and then we'll go on to a new line. Oh, I accidentally messed that up. Let me go ahead and try this once more. Oh, and we really messed up here. Okay. 1 second. Let's refresh the browser. Clear it out. And then we need to enter to a new line and console.log param2. All right. So what we're doing here is we're taking the value of param1 and the value of param2, which in this case, within the function, these are variables. These are variables that we can retrieve the value from and print out. So we're going to declare that function. Well, as you can see, it's a little bit later in the day here, so I had to take a break, but getting back to what we were talking about with these parameters. So the question is, what are they equal to? What is param1 and param2 equal to? Well, the answer to that is we don't know yet. And we don't know because we haven't assigned them as what we call arguments. So we know that this is a declared function, but we still have to call or invoke it. And to do that, you know how to do that. You just put in the little parentheses at the end and you'd press enter. Now, if we just press enter right now, it's going to return undefined because we didn't pass in any parameters. So when this code tries to execute and it tries to reference these parameter variables, there's no value to grab because we never gave it a value. So to answer the question of what they represent, well, they represent the arguments that you pass into the function. So if we have this function, we can pass in, say, a number and then some string of some sort. And now these are what we call the arguments. Now, like I said, arguments and parameters are kind of the, two sides of the same coin. But in this case, whatever we pass in, the values we pass in are called the arguments, and then the initial variables that we were declaring would be the parameters. So 20 is going to correspond to param1, and then some string is going to correspond to param2. So we should get 20 and then some string printed out when we run this function. Don't worry about this little undefined here. That's just kind of part of the console. We got our 20 and some string printed in order according to the function that we wrote. So that's just a basic overview of arguments and parameters. Now, the next thing that we're going to talk about is a brief introduction to scopes in JavaScript. So when I say scope, what I'm generally referring to is where these variables are available in the code. So in other words, we noticed that param1 and param2 were used within this function, but if we were to just try to print param1 into the console, it's not going to work. And the reason is param1 is not available in the global scope. It's only available in the function scope, which is any code that's written between these two little brackets right here. So we pass in these values, but these are only available to the function. It's not available to the rest of the code that you're writing in the file or the console that you're writing the code in. So that's just a basic introduction to scopes. There's a lot to this topic, and as I said, we're not trying to cover every last detail of JavaScript. That's something that I think you'll have to fill in kind of outside of this tutorial and as we do practice problems and get into some more like real world examples, you'll start to understand these scopes, and I'll try to point them out as we go through. Like I said, the You Don't Know JavaScript series is a great way to get a super deep dive into things, topics like the topic of scopes, but beware, it's very complicated and there will be a lot of confusion if you kind of go down that route. Up until this time, I've shown you how to write a function as we see on the screen right now, but there is actually another way to write a function. And let me show you how that's done. So let's go ahead and clear this, this console. And we'll create a function just like we are used to creating. So no parameters going in there, just a basic function, and we'll console.log something. All right, so that's our basic function. Now another way that we could write this is by assigning it to a variable. So in this case, the myFunction variable is already defined and it represents a function, so we can't use that in our variable declaration, but we can say something like another function, and then we want to set that equal to a function. So this is just a normal variable, and all we have to do is say function, define it, and we'll console.log another thing. All right. So we set that equal to another function, and if we say type of another function, it's going to give us the type of function. Now I'm saying this word a lot, so I gotta slow down here. But anyways, if we wanted to invoke this function or call it, it works the same way that we were using it before. So just like we call myFunction, just like this, and it prints out something, we can invoke another function the same exact way, even though it is a variable. Now, there are a few little subtle differences between these two ways of writing functions, and like I said, it gets into some details that we're not quite ready for, and I'm just going to leave out for now. It's not, and these details are not essential for you to write good code and get it up and running. They're more like edge cases where your code doesn't work and you can't figure out why. Well, it's because of this subtle nuance. So I wouldn't worry about it too much. All right, so we've got these two different ways. The main difference that I want you to recognize is the fact that this function right here does not have a name. This is what we call an anonymous function. And the reason we can use an anonymous function is because we are assigning it to a variable. So we're giving it a name. Now up here, we just do it all at once. We just give it a name and we're done. So if you tried to write a function without a name, so something like this, you're not going to get it to work because this is an anonymous function and you need to declare some sort of name. And you see the syntax error, it says function statement requires a name. So that is not valid because it's anonymous. You have to assign it to a variable. Now there is another way to write functions, and this is a little bit tricky, but I'd like to cover it because you're going to be using this next type of writing a function a ton. So as of 2015, when the ES6 standard came out, so if you remember back from, I think, lesson 2, we talked about ECMAScript standard and how there's a standards body that basically defines the spec for the JavaScript language. Well, they upgraded that spec in 2015 with ES6, and they came out with something called a arrow function. So that arrow function looks like this. So we'll say arrow function equals, and then we'll put some parentheses. We'll put an arrow, and then write it just like normal. So we'll say I am an arrow function. All right, so we press enter, and like our other functions, we can call it or invoke it the same way. So we just press arrow function with the two parentheses at the end, and boom, it executes. So it's functionally equivalent in a way. Again, there's some subtle nuances that we're not going to get into, but this arrow function is mainly here so it improves readability. And another benefit that it has is it really helps out with the scopes of your code, and specifically the this keyword, which we'll get into much later, but it does improve on that. That's why they came out with it in the first place. So this is a very different way of writing a function, but here's the basic syntax. You just have this little parentheses, which is basically here's where you put the parameters. Then you have this arrow, that's why they call it an arrow function, so an equal sign and then a right caret, or greater than sign. And then you have these two brackets just like you would any function. Once again, you cannot just use this alone. This is kind of similar to that anonymous function we looked at, and you can't just define a function like this and this won't work because it doesn't have a name. So you don't have a name specified. It didn't throw an error like the previous one, but you have no way of referencing back to this. You don't know how to actually call it because there's no name for it. So you have to assign these anonymous functions and arrow functions to some sort of variable. These arrow functions or anonymous functions can also be used in something called a callback, but again, that's going to be a little bit later down the road. All right, from now on, I'm going to be focusing a lot on these arrow functions. I'm going to be writing them for the most part. Now, obviously, if you're defining a function on its own, you have to write it, with the normal syntax. So you have to write it with the name and then the parentheses just like this. But for a lot of cases, we can just assign it to a variable, and I'd like to get you practicing the arrow functions because you're going to use them so much. So the next thing that we're going to talk about here is the concept of return values in functions. So far, we haven't returned anything from our functions, and if we're writing these, so let's say my function, save it to a variable, and use the arrow function syntax, and then we just console.log something. All right, very simple. My function does not actually return anything. So if we were to assign a result variable to it, so we're going to say my function, and then we're going to call it. So remember, this is just executing the function we defined above, and then it's assigning the result of that function to the result variable. So we press enter, and this is just the console.log that was executed as part of the function. But if we type out result, it's going to give us undefined. And the reason is because our function didn't return anything. So if we want our function to produce a value, we have to put a return statement in there. All right, so let's go ahead and do that. Return function, that's what I'm going to name it here. That's just a variable. We'll use the arrow syntax, enter down, and this time we're going to return a value of 20. And we also could have returned, some string. Or we also could have returned a variable. So if we wanted to, make a variable called a and that equals 20. I accidentally hit enter there. But if we wanted to, we could come down here and return a. Now it's going to bug out on me because I've already declared it like right here on accident. So let's refresh the page real quick so that we can get back into this. So we'll just say my function this time. We've got the fat arrow function, enter down, we'll define a variable, set it to 20, and then we will return that variable. Now we could also return like some sort of expression. So what if we wanted to return a is greater than 30, which it's not, obviously. So this would return false. So let's just see, how these different return types affect the function. We're just going to return a, which will be 20. And now we want to set that equal to a result variable. So we'll get my function, we're going to execute it, and then assign the result to that result variable. And now when we print out the result, it's going to equal 20 because it took the result value of the function and assigned it to that variable. Like I said, you can do expressions here. So if we wanted to define another function, we'll just put 2 at the end so it's unique. And then we want to say a is less than 30, which it is. This will return true. I'm just going to put a comment there. and therefore we would expect that this whole function is going to evaluate this last expression here and then return it. So let's press enter, and then we'll say result2 is equal to my function 2, and then if we get the value, it's going to be true. So you can see that there's a lot of different things that we can return from a function. Heck, we could even return a function from a function, but that's getting into way too much detail and it's not necessary for what we're trying to do. So I'm going to skip that. Hopefully this gives you a brief overview of return values. Now the last thing that we have to talk about is what happens after the return value. So let's say that we had, I'm going to go ahead and clear the screen. We'll say improper return function, and then we're going to set that equal to our arrow function, and we're going to return 20, or no, let's go ahead and set a variable. I messed this up again. It's kind of tough working in the console, but we will eventually get to a code editor, which is going to be a lot easier on us. So let's say my function, do this one more time, and in this case, let's define a variable. So we'll say let my number equal 20, and then we're going to return my number. Now let's enter down onto the next line, and then we'll say my number equals 50. All right, so we're going to press enter, and it's going to give us an error. It says unreachable code after the return statement. You won't get this from all, like this is just in the console. You may not get this error anywhere else, but this is giving us a hint that we've done something wrong here, but it is still valid. So basically what we're saying here is we're going to run the function. It's going to return 20, and that's because we've returned the value before we reassigned it. So this is valid code to write, but it's useless because this last line right here is never going to be reached no matter what happens. It's always going to return beforehand, and you'll never return a value of 50. So just know that for the return values, whatever happens after it doesn't matter, and you pretty much will never have a return value before the end of your function. So let's say that we have a global variable. We'll just say something like my number equals 20. All right, so we're going to set that in the global scope. Again, scopes are going to get important here soon, so just kind of keep that in the back of your head. Now we're going to define a function. So we're going to say, let's go ahead and use let, because in case I screw up again and we have to reassign it. So we're going to go ahead and say my function, and we're going to set that equal to an arrow function. Now we're going to say if my number, so this kind of seems like going against what I told you earlier about scopes. So if there's a parameter that has a function scope, it cannot be accessed at the global level. But if you have a global variable, you can access it from within a function. So it goes one way but not the other when it comes to scopes. So since this is it's in technically a higher scope than the function has, the function can actually recognize what this variable is equal to. So we're going to say if my number, and then we're going to enter down, and actually I need an expression here. If my number is, we'll say, less than 15, then I want to return the function early. All right, and then we're going to enter down, and then we're going to return 40. These are all random numbers I'm making up here, but it's just trying to show you that if you have a condition where, if the number is less than 15, which it is not in this case, you can actually return multiple things from the same function. So my number is not less than 15, so we're going to actually skip this return function and return 40. But if we change that, so let's say we change that to less than 50, and 20 is less than 50, so we're going to actually return this function early, and we'll never reach the second return statement. So let's go ahead and enter that down and execute it, and you'll see that we get that returned the function early output. So you can have multiple return statements within a function just you can't have like two of them on the same line. So if I were to recreate this function and maybe have, you know, like a return statement of 50 and then return 40 right after it, both of these code paths are going to be reached. So this doesn't make any sense. You only want to return one value. So that's just an overview of return values. We're going to get a lot more into this as we start writing some more realistic code. Just wanted to give you a brief overview. The last thing that I want to do prior to getting into the 25 practice exercises or coding challenges I have for you, I want to talk a little bit about objects and functions together. So this is a little bit of a confusing topic, but it's going to hopefully help you understand when we start talking about the built-in functions of JavaScript. We're going to talk about that in a few minutes. Hopefully this will help you understand that better. So let's go ahead and define a function. We're going to call it my function again. And then let's, I don't know, return a value of 20 from it. So this is a very simple function. We'll go ahead and execute it just to demonstrate. It returns 20. Now, what if I wanted to set this equal to another variable? I can actually do that even though it's already called my function. So I can say, you know, alias. You know, an alias is just another name for something. So we'll say alias variable equals my function. All right, so if we press enter, now alias variable is exactly equal to this function declaration that we made above. So if we wanted to execute that as alias variable, we're going to get the same answer of 20. So we can assign it to different variables, which means that we can also assign it to object properties. So let's go ahead and clear the, well, I guess we don't need to clear the screen. Let's go ahead and create an object. So we'll say my object, and then we'll set that equal to prop1. We'll just give it some random value just to have something there. And then we'll say prop2 is going to be equal to my function. All right, so we have declared my object, and prop2, just a random property name that I've given it, is going to be exactly equal to the function declaration, just like we made this alias variable equal to the function declaration. So what does this mean? Well, we can actually execute the function by accessing a value of, or by accessing a property of the object. So if we come down here and let's just go ahead and say my object, and then we need to get a property from the object. So let's go ahead and get property 2. And you'll see in the autocomplete down here, it's pretty much telling us that that is equal to my function. Now, if we wanted to execute it, we can still put those little parentheses at the end, and it's going to execute and give us the same answer. So what we did here was we grabbed an object, we grabbed a property off of that object using the dot notation, and then once we had that, we just threw those little parentheses at the end and executed it. So I just wanted to get you familiar with this because what we're about to talk about is the built-in functions of JavaScript. So JavaScript has a bunch of built-in functions and objects and all sorts of other stuff that we can use without having to write any code. And if you go to, there's several resources that you can use to see these. I'm on Tutorials Point, which has a good list of them, but they're all over, documented pretty much everywhere. And within JavaScript, there are different data types, as we have talked about. So you have strings, you have booleans, you have numbers, and all of these different data types will actually have some built-in functions that you can call on top of them. So if we go here and just look at some of the different methods, so method is another, I guess, synonym for function. We can call, like, it's not completely synonymous, but if you have like an object and then you have a function attached to that object as we just showed, that's called an object method. So it's kind of the same thing. And you can see that we have number methods, we have Boolean methods, and we have string methods, and we have array methods probably down here somewhere. So array methods. And depending on the variable type that you're working with, you can use all of these to modify your variables and just take a bunch of shortcuts with your code. So let me go ahead and show you a few of these just to give you an idea of how they work, because when we go into the coding challenges, throughout this course, we're going to be using these as much as we can. Now, the first thing I'll say here is don't try to memorize these. These are not to be memorized. There is documentation for a reason so that you can Google it and look it up when you need it. You'll pick up on a few of them over time, but for the most part, I only have a few of these actually committed to memory. All right, so let's go ahead and try out a few string methods. So let's say that we wanted to, I don't know, use this replace method. We go back to the console, let's clear everything out, and let's define ourselves a string. So we'll say my string equals Zach. And then we're going to use the replace method. So maybe I spelled my name wrong. This is how you spell my name, but what if there's a K at the end? So I might want to replace it. So I can say my string dot replace, and then I'm going to replace the H with a K. And when we press enter, it's going to return Zach with a K, and now my string is actually going to still be equal to the original because it didn't replace the value. It just returned a new value. So it doesn't alter the original value here, it just returns a new one. So if we wanted to say new name, we can just say my string dot replace H and K. And then we set that equal to new name, and now my new name is going to be spelled differently. Now, something that I want you to notice when we're looking at this is that we're using the same notation here that we used earlier when we accessed that property of the object and executed it as a function. Now, this works a little bit differently than that, but you can kind of think of it that way. So maybe the my string is considered your object, and then you use dot notation to get a property off of that object called replace, which happens to be a function that takes two parameters. And the first parameter it takes is the letter or string that you want to find within your string. So I want to find the letter H within my string. And then I want to replace it with the string K, just a letter, so my string will be replaced. So these are the parameters, and if you were to look at the replace method and you go ahead and click on it, it gives you a description of this, and we're going to learn how to, read through documentation a little bit later. But anyways, you can go down here and just see what kind of parameters are required for this. So here's the syntax, and it gives you the parameters that you want to search for, then the parameters you want to replace it with, a couple examples, some output, all that stuff. So that's how I've figured out how to use that. Again, we're going to go through it quite a bit as we go through the coding challenges. I'll just go through a couple more examples just to get you comfortable with what's going on here. So let's go ahead and use my string once again. And this time I want to use the string method called toUppercase. And you can see what that does is it returns us the uppercase version of our variable. Now I know we got a lot of different versions going on here, so let's go ahead and clear that out and reprint my string. So that is what my string variable is equal to right now. We can also chain the methods together. So this is a little bit of an odd concept to someone starting out, but you'll see how this actually works once we get into the challenges. So let me just do a simple example here. We have my string equal to Zach, but let's go ahead and say we want a new string or something. So let's call it, I don't know, let's make a new one. We'll just call it str for string. And this one we're going to say hello world in there. So that's the string right there. And what we want to do is first make it uppercase. So we'll say toUppercase, and we'll execute that method that sits on the string object. And that's going to output us hello world, as it's kind of telling us here. Now we can put another dot there, and we can chain these methods on top of each other. So I'm going to use another method called split. And what split does is it's going to take whatever delimiter that you put as a parameter, or not a parameter, as an argument. So if we put in a space right here, it's going to look at the string and it's going to say there's one space in there, so I want to split hello and world apart from each other. And then what it does there as you can see down here, is it actually changes the data type from a string to an array, where the first part of that array is the hello, and the second is world. So let's set this equal to a variable. We'll just say a result variable is what we want. And our result variable is now an array. And from there, we can actually do array methods. So let's go ahead and go back to the documentation here. And let's scroll down to some of our array methods that we can use. So what would be a good one to use? So we'll use the index of method. So this just basically gives us the index of a value. So we'll say result.index of, and then I want to search for the word world. And when we press enter, it's going to return us 1 because this is an index of 0 and this is an index of 1. And that matches the string that we are searching for that we passed in as an argument to this function. Now, of course, you don't have to do this by chaining them together. You can do it in separate steps. So in the case of above, we made this to uppercase and then we split it into an array in a single step. But if it gets too complex for you and you just want to stick to the basics, you can do this in different steps. So we'll say, first let's see what string is equal to. It's still equal to hello world because while we did this right here, we didn't modify the original variable. We just assigned it to a new one. So string still represents hello world. And in this case, we'll say step1 variable. We want to take that and we want to make it uppercase. All right, so we'll make it uppercase and then maybe just type it out to make sure that it worked. Now we're going to do step 2 right here, where we say step 1. So we want to grab whatever values in step 1, and then we want to split that based on a space. All right, so we set that to step 2. And then step 2, we can print out and we see that it's an array. And then we come to, say, step 3. And we'll say step 2, whatever value's in that variable. And then we'll say index of, like we did above. And then we'll search for the word world. And we'll set that to step 3, and we get an index of 1. So you can see we can split these out into different steps, but I just wanted you to know that as you see some different syntax when you're reading through code, this is a valid way to use these built-in methods in JavaScript. All right, there was a lot here. There was a lot going on in this video, and I would never expect you to take it all in at once and process it and understand every last bit of it. And that is why we're going to use a bunch of practice exercises or coding challenges to brush up on these skills and really cement some of the concepts. We've talked about variables, we've talked about operators, we've talked about conditionals, so if else, or else if, doing a tongue twister there. We've talked about loops and we've talked about functions. So there's a lot going on here, and to combine it all together and actually write code, I think it's useful to go through some exercises. In this video, we're going to go through 25, maybe a few more, we'll see how it goes. But we're going to go through some coding challenges, and these are going to be at the very beginner level, so like very beginner level of coding. And what I want to do with this is walk you through my own thought process and help you understand how I'm thinking about this and how you should use the previous lessons that we have gone through. So lesson 3 and 4, where we talk about the basics of JavaScript. I want to apply those to actual coding challenges. Like I've said throughout this series, I'm not taking you extremely deep into the JavaScript programming language. There are other people who have done that. And I think at this point, when you're just trying to get off the ground, digging into complex topics like, hoisting and advanced scopes and stuff like that, it's not necessary for when you're just starting, and you can fill in the blanks as you go later on. And partially why I'm making this video with these challenges is to help you do that. So if I haven't talked about it in the previous lessons, hopefully we'll kind of fill in the blanks here with these challenges. And to do so, we're going to do this on a site called Code Wars. And if you go here, pull up the screen, This is going to be the collection that I've put together. So there's 25 exercises here that I've put into a collection. We'll see how it goes. I might add a few more if we blow through these. But basically, just hit the link in the description to find this series of questions, and then get to this page right here, create a profile. Go ahead and follow me too. Let's see what my profile is, Zach Gall. Just look me up, follow me, I'll follow you back so that we can do this together. And then once you get to the collection, again, link in the description, you'll go to this top left corner and click Train Now. And when we click this, it's going to drop us into each of the problems that I have basically chosen for this video. And I just want to give you a quick tour of Code Wars if you've never been on here before. I actually just started using it for this purpose, just to go through some practice exercises. But basically on the left side here we have the instructions. So it's going to tell us the instructions, this code does not execute properly, figure out why, basically fix it. You can see the output here. This is when we actually run our test. So if we run our test, obviously it's going to fail, and this is where we see the output. And then over here is where we write our solution. So we can write valid JavaScript code over in this terminal over here. And then finally at the bottom, this is the sample test that we can look at. So obviously this is a little bit more advanced than we're probably accustomed to at this point if you're watching this video. But this is going to basically be a bunch of code that actually tests the code that you write. So it takes the inputs that, or it takes a set of inputs, it puts those inputs through the code that you've written, and then it gets the outputs and checks to see whether that matches the expected output. So that's just a brief tour. Just a few other things. You'll notice that we're writing in the JavaScript language. That's what this video is about. Node is going to be the runtime, so Node.js is kind of the back-end version of JavaScript, but just like we've been working on in this series, we can, this is the browser DevTools console, and this would be, the same code that we're writing here. So nothing new here. And then finally, this Vim versus Emacs thing, if you click either of these, it's going to actually drop you, or it's going to create this editor right here into, like, say, a Vim editor. I have a video on this if you want to check out the Vim code editor or text editor, but don't click this for now. That's a whole different ball game that we would get into if we started using those. So keep those unchecked. All right, so from this point, we're going to go through the exercises. I'm going to walk you through how I'm thinking about them. The first one is rather simple. If you've been following along with this roadmap series, you'll know exactly what we need to do here. It's saying this doesn't execute. How do we fix it? Well, right now, if we ran it and did the output, we ran it earlier, it says it expected undefined to equal 1. So basically that's saying that we haven't returned anything from this function, and therefore we just need to add a return statement right here, and then we can test it and it should pass. So we pass it, go ahead and click attempt at the bottom right corner. It passed all of our tests, so we'll submit it. All right, once you submit a solution and you did it correctly, it's going to show you other people's solutions to the same problem. And this can be useful, but also detrimental, so listen up here. The way that this can be useful is by scrolling down and just seeing the possibilities, because you can solve every one of these problems in many different ways. And so sometimes it's fun to see how other people have solved them, and it also can open your eyes to different types of thinking that you wouldn't have thought about. So it is good in that way. It's not good because sometimes people will solve these in very clever ways. And when I say clever, that does not mean the best way. Now, I'm not a competitive programmer. I don't claim to be. I don't really have any plans on becoming one. But when you get into the world of competitive programming, it's all about optimizing your solution, writing the least amount of code or the fastest code, that kind of thing. And I'm not that. I just want to write some code that helps you understand the solution and help you read the code in the simplest way possible. And some of these solutions down here, for example, this one right here, this is unnecessary. There has, nobody said that you have to check and validate all of the argument inputs. So in this case, A and B are the inputs to our function. And what this person has done is basically checked to make sure that, the inputs are not some, invalid input. It makes sure that they're a number. And this is totally unnecessary for this solution. It never told us that we have to check that. And this is just overly complicated in my opinion. You'll see that there's a lot of votes for the clever, and in many cases when you see a lot of votes for the clever solution, it's probably not geared towards the beginner. It's probably not what we want to focus on right now at least. Now I will point out one that's a little bit useful for us, and that's down here. So this would be our solution. That's what we came up with. We just added a return statement and called it a day. Now, there's another way to do this that is actually, it's very clever, but it's also something that we talked about in a previous lesson. So I think it was the previous video we actually might have mentioned this at one point. But basically, if you have an arrow function, which is what, we don't have an arrow function in the original solution, we just have this, standard function, a named function, but we could set this function equal to a variable called multiply, and then we set it equal to an arrow function. And with an arrow function, if you put it all on one line, you don't actually have to put a return statement in there. So this is a nice thing to look at because it gives you, kind of opens up your world to understanding, oh, I can write it like this as well. All right, so enough on this. We're not going to spend this much time on every challenge, but I wanted to walk through how you think about these solutions here. All right, so if you clicked that button, so let me actually go back to make sure that we're clear on this. We'll go to collections, go to the lesson 5 practice challenges, and if you just click on one of these challenges, it's going to take you to that challenge, but when you click next, it's not going to keep you within the collection. So make sure that you've clicked this train now button so that when you solve the problem and click next, it takes you to the next one in the collection. So I guess we got to solve this one again real quick. So we'll attempt it with that solution. We passed it. Let's submit it. All right, and now we can press next kata or kata. I don't actually know how to say that. I'm sure there's a reference to that I'm not getting. Be sure to leave that in the comments if you do know what it means. Anyways, this is the next problem that we have, so let's go ahead and, or actually is this? Yeah, this is it. So let's train again. I guess I've already opened this at one point. Yeah, when I was putting the collection together. So the function is not returning the correct values. Can you figure out why? So this is going to actually get us into the switch case statement that we talked about just in the previous couple videos. And if you remember with the switch case statement, this is basically like saying if and then else if and then a bunch of else ifs to test a specific condition. If you remember from the switch case statement syntax, we are missing something right here that is causing our solution to be wrong. And I think what's going to happen if we execute this, we're going to get Neptune every time. So let's see if that's the case. Yeah, so we got Neptune every single time. And the reason that's happening is we don't have any break statements here. So in other words, we're getting the ID passed in correctly. So that's passed in as an argument. ID is the parameter that we're defining within the function. And then what it's doing is it's looking at that ID, so that's in the switch statement, and it's saying, what does the ID equal? And then once it figures that out, it goes to all the cases, and so it says, does the ID equal 1? Okay, if it does, we'll set the name equal to Mercury, and then we'll return the name down here. But the problem is, since there's no break statement, it's always going to hit the last case. So let's say that the ID, we go down to the test and they're passing in 2 as an argument, and we're expecting that that will return Venus. So if we, pass in an ID of 2, it's going to get passed in, and then we're going to look at case 1 and say, okay, ID does not equal 1, so let's go to the next one. All right, ID does equal 2, so let's set the name equal to Venus. But instead of breaking and coming down to the return statement and returning that answer, it doesn't do anything. It's just going to keep going down all of the cases. So it's going to say, does case equal 3? Does case equal 4? Does case equal 5? So on and so forth till it hits the last one. So we need to add some break statements in here. And all we have to do is just put in break with a semicolon. And we'll do that for all of these lines. All right, so we've got our break statement. Let's test this once more. And this time we're passing it. So that's all we needed to do. This was purely a syntax error, and it's something that you would have had to kind of look up the documentation for a switch case statement or watch my previous lesson to figure out. So let's go ahead and attempt it. We know it's going to pass, and we'll submit it. All right, let's see what everyone else was doing. There's some clever solutions here. Obviously, this one is very clever, but I would not recommend doing this at our skill level right now. So looks like we did it okay. In this case, this person has opted to use a return statement, which is valid, but a break statement works just as well. So you can see that this was the top solution, most common, and that's kind of what we used there. The one thing I'll point out is I put a break statement after Neptune, but that wasn't really necessary since it's the last one. All right, we'll go to the next challenge. This is reversing a string. So let's go ahead and train on this. So basically all we're doing is taking this string and reversing it. And I know how to solve this solution with just a single line, but I don't actually know exactly how to do that. I can take a guess. So let me try and just return string.reverse and see if that works. Okay, so reverse is not a function, as I kind of suspected. So in JavaScript, as we talked about in the previous video, there's a bunch of built-in functions that come with JavaScript. And you can look these up. So we'll just say JavaScript built-in functions. And then we'll go to tutorials point. I like this one. It's pretty simple. And then if we go to the string methods, that's where we want to go, because what we're trying to do is reverse a string. So anytime that you're trying to modify a certain data type, you can first look to those built-in methods so you don't have to do something manually. So in this case, we're working with a string and we need to reverse it. So let's go ahead and see what we can do using the string methods. And it turns out if we're just looking through these different string methods, there's nothing that says reverse here. I had actually, for some reason, thought that we did have a reverse method. Don't know how that slipped my mind, but we don't, so we have to think of another solution. Now, realistically, if we were solving this problem, in the real world, where we had to write some code that reversed a string, what I'm going to do is this. I'm opening up Google, and then I'm going to type in how to reverse a string JavaScript. All right, and usually there's going to be a Stack Overflow post, because Stack Overflow is where you basically get the answer to anything when you're coding. And what's going to happen is we're going to find a solution here. So I wasn't that far off. We actually do have a reverse method, but this is not going to be entirely apparent to you if you're like a complete beginner. But what we're doing in this solution here is we're actually converting this to an array first. So let's go back. This is all I need to see for now. Let's go back to our documentation and take a look at the array methods. So if we have a data type of an array, we can actually reverse it. So it looks like there's a reverse method right here. And I'm going to go ahead and go to the dev console. Just right click anywhere on the screen. Let's just show you how to do that. Right click, inspect element. If you've been watching the series, this is not news to you. And now we can type away with any JavaScript. So let's see how we can do this with an array. We'll just set an array equal to 1, 2, 3. And if we want to reverse this array, we can just say array.reverse, and it's going to reverse the values in the array. So basically what this Stack Overflow solution is telling us is that we first need to convert the string into an array by letter, and then we need to reverse it, and then we need to join it back into a string. So this is a one-step solution where we can basically do it all in one step. We talked about chaining these built-in methods in just the prior video, but I want to break this out into individual steps just for clarity. So let's go ahead and do that right now. The first thing we want to do is split the string into an array. So basically it's going to take every character in the string and it's going to make each character a value of that array. So again, let's come back to our console. Let's say that we have a string and that's equal to hello. All right, and then we want to say string dot, what were we using here? We're using split, and we're going to just split it with an empty character. So if I can get back here. So we'll say string dot split, and we'll put in just an empty character, and that's going to give us an array where we have each letter being separated in the array. All right, so now that we have the array, we can split, or we can reverse it. So let's just go back and do that here. So the first thing we have to do is put it into array. So string.split, and then we just need to pass in an empty character. And then from there we can reverse it. So as we saw, so we'll save it into a reversed variable. So we'll say array.reverse. All right, so that's going to assign it there. And then oftentimes when I'm solving a problem like this, I'm going to write some code and then actually test it out before I move on. So let me go ahead and console.log the reversed value, and then we'll click test, which is obviously going to fail. But what we do see is that we get some output. So you'll see that we logged this to the console and this to the console, which basically tells us that we have our reversed variable is an array, and that array is reversed from the original string. So the last thing we need to do, since we have it in the form of an array data type, is we need to take that reversed array and just combine it together into a string. And to do that, I think all we have to do is join it. So if we do string.split and then we say join, it's going to join it by a comma. So we actually will have to replace those commas. Let's see how the Stack Overflow solution did it. Okay, let's see. And we have to, when we join it, we have to also enter that empty string right there. So that's just a little tricky part to this. So let's go back to our problem, and then we'll say final answer equals the reversed array. So this is an array, and then we join it by that empty character, and then we go ahead and return the final answer. And let's go ahead and test that. You can see that we passed all of the tests, so let's attempt it. I think we'll be fine here. And we solved it. So that's just how we take it out into different steps. Of course, we could have solved this by just saying we want to do string.split, .reverse, .join, and this we can delete all of these intermediate variables right here. We can test this and it's going to pass everything. Let's go ahead and attempt it and submit it. So like I said, there's a couple different ways to solve it, but you might be asking at this point, well, you're cheating. Like you went on Stack Overflow and figured this out that way. And well, yes, if I was doing a programming competition, I would be cheating. And that's why I'm not a competitive programmer. I'd never want to be, because Google is, your best friend when you're a programmer. And it is not cheating to Google something. So we'll try to do more of these on our own for the remainder of the video, but for now I just really wanted to beat that into your head that it is okay to go to Google and search something like that. And that's how pretty much everyone that operates in a real world environment is going to do. So just a tidbit of knowledge there. Take it for what it is. All right, so we'll go to the next challenge. See what we got here. Okay, even or odd. Let's see what we are trying to solve. So it says create a function or write a script in shell. That's not something that we're going to do. That takes an integer as an argument and returns even. So notice that they're asking for a string, a capitalized string that says even for even numbers, or capitalized odd for odd numbers. All right, so let's see what we can do here. The first thing I'm thinking about is maybe a modulus operator, but I don't even think that we need to do that, or do we? Yeah, that is correct. So a modulus operator, if we were to divide something by 2, right? Okay. I don't know what I was thinking here. So just divide it by 2, right? So let's go over to our little playground here and refresh, just so that we can test a few things out. So if we got 20 divided by 2, that comes out to an even number. If we have 21, which is odd, divided by 2, we have a decimal. Now, we would have to complete some additional steps to actually figure out which one's a decimal, which one's a whole number. So I kind of like the idea of the modulus operator, because if we do 20 instead of divided by 2, but modulus 2, it's going to give us 0. But 21 modulus 2 is going to give us 1. So basically, every time we have an even number, doing modulus 2 is going to return 0, because there's 0 remainder if we do that division operation. So in previous lessons, we talked about this modulus operator in my video about operators. And basically what it's doing is it's doing a division problem, and it's returning what the remainder of that division problem is. So as we know, going back to basic math, if you divide something and it goes into it evenly, there's going to be a remainder of 0, which we're going to see for any even number. So if we do 40 modulus 2, that's 0. If we do 2 modulus 2, that's 0. So that's basically how we're going to solve this. And we could do some intermediate steps, but we can actually just return the solution. Or actually, no, we do have to do some intermediate steps. So if we need a conditional in here, we want to say if the number, so we're grabbing that from the parameter, and then the test cases are going to pass in different arguments, and then this parameter called number, just think of it as a variable available to this function, is going to be different per the test case. So replace that number with whatever argument you have. And then what we want to do is write an expression that says the number modulus 2. All right, so we want to say if that is equal to, so we'll use triple equals to check both the value and the data type to be the same. And we want to set that equal to 0. So if the number modulus 2 equals 0, then we know that it is an even number. So we'll drop down into our if statement and we'll return what we need to return based on the instructions over here called even. All right, and then we'll put an else statement so we know that if it's not even, it is odd. So we're going to just return odd in that case. And let's test this out. All right, we passed all our tests. Let's go ahead and attempt it. And we passed all of our tests. So let's submit this answer and see what everyone else did to answer this. I'm sure there's some more clever solution than what I came up with. All right, so this is just using the ternary operator. We talked about this very briefly in the operators video, but it's basically just a shorthand, clever way to write an if-else statement. And we could have used this, but I just don't want to confuse anyone unnecessarily. This looks to be our solution. Actually, there's not much variance here. So these are just abbreviated ways to write our function. They're just using the arrow functions rather than our classic function here. So we did pretty good on that one. Let's go to the next challenge. All right, we're counting sheep in this challenge. Let's see what we got here. Okay, we are returning the number, or the count, of the vowels in the given string. We will consider A, E, I, O, U as vowels for this problem, but Y is not going to be in there. Okay, so that's good to know. The input string will only consist of lowercase letters and or spaces. All right, so this is another point that I really want to bring up. If you're just starting out, you're a beginner, and you're solving problems, this is kind of how an interview question might be laid out, where the last part is going to tell you something about the input. So obviously the functions that we have been writing here, they're being executed by something, and that something are the automated test. This is a sample test down here, but there's code that's going to run when we actually click this test button. This site is going to execute our function with a bunch of different parameters to make sure that we implemented it correctly. You don't want to just test it with one set of parameters. You want to put in a bunch of different things. And with that, we could have an infinite number of things passed into this function as arguments. And oftentimes in more complex problems and harder challenges, they're going to challenge you to handle all of the different edge cases that might come up. And when I say edge cases, it might be something like, okay, what happens if I pass in an undefined value as my argument? Or what happens if I pass in a number instead of a string into this as an argument? Well, all of these things need to be handled by your code. So this last sentence here it doesn't seem very useful, and you might even ask, like, why is it here? But this is telling you something about the input. It's basically saying to us as the programmer, it's saying, hey, this is only going to give you lowercase letters and or spaces. And that's basically saying, in other words, we're not going to pass in numbers, we're not going to pass in undefined values, null values, Boolean values. All you need to worry about are, single lowercase letters and spaces. All right, so that is very useful information. It's going to save us a lot of time when we're solving this problem. All right, so it says enter your magic here, spelled incorrectly, at least in English. I don't know how we spell it in other languages. Anyways, let's see what we got here. So we have a starting point. Now, one thing I'm going to fix here, they're using the var keyword, and in the lessons, I've basically told you we're not using this, and I also stand by that. So let's go ahead and set that equal to let, because it looks like we're going to have to reassign this at some point. All right, so this is actually a fairly easy solution once you've been programming for a little bit. How I see us solving this is, first, let's put in our input into an array of some sort. And then I want to loop over that array and check if it's a val. All right, so let's go ahead and do that. There's actually a lot of ways that you can solve this, but let's just stay consistent with what we did in the previous one. So we'll we'll convert this to an array by saying string dot split, and then we want to pass in that empty character. So if you remember, what that does is it takes every letter of the string and it puts it out, it expands it out into an array. So going back to this tab, we'll just say, let's look at an array, and then, we'll look at a string. So the string will be hello, and then we can just say string dot split, and then that's what it's basically going to do here. So it's going to split it into an array. And then from an array, we know that we can write a loop. So this is kind of the previous couple videos that we've been talking about loops. So we're going to loop over every single value in that array. So to do that, we're going to say, let I equal 0. This is just the syntax we use for looping. And then we want to go for the length. So the array that we just created has a certain length, has a certain amount of characters, but we don't know that beforehand. So we're just going to pass in array.length, and then we're going to increment I using the increment operator. All right, so we're going through this array, and now we're just going to write a simple if statement. So we'll just say if, let's say we'll grab from the array each of the indexes. So remember, I is going to increment. It's going to go from 0 to 1 to 2 to 3 to 4, and all the way till it reaches the end of that array, which has the individual letters of this input argument. So we're going to grab that, like basically this array or ARR bracket I is going to represent a single letter of that array. So we're going to ask whether that equals any of the vowels. So there's actually some really short ways that you can write this, but I'm going to go ahead and do this the clunky, really drawn out way, just because it's the most clear for a beginner. So we'll say if the array, or actually we can use a switch statement, as we saw in a previous challenge. So the thing that we want to evaluate is that single letter, and then we're going to come down here and we're going to say case, does it equal A? All right, if it equals A, then I want to take this vowels count variable and increment it by 1. So that's what we're doing there, and then we will break out of the statement. Remember, that's very important. All right, so we're going to do this for all of the different vowels, and we're just going to paste this code below here. And it's going to get all messed up with formatting. So let's see. And like I said, there is a much quicker solution, and I'm sure that we'll see someone that used it. But this is, in the scope of what we've talked about already. So I just want to stay consistent with what we've talked about, not throw any huge curveballs here. All right, so we're getting to our last one. Let's pass that in. We actually don't need a break statement for this last one here. And so basically what's going to happen here is we're going to loop through this array. So basically we're going to look at every single letter in the array from that original string, and we're going to ask, does it equal A? If it does, we're going to increment the vowels count. Does it equal E? Increment the vowels count. And if it doesn't equal any of those, the vowels count variable is going to stay where it is. So at the end of this loop, we're going to have a total count, and then we just return it at the bottom. So let's go ahead and run the test on this and see what we get. You can see we passed one of the tests, so let's go ahead and attempt it. And we passed all 5 of them. So we obviously got this correct, so let's submit it. Guess it didn't submit, so let's try that again. Sometimes this is a little bit slow. It has to actually run a bunch of tests. So, all right, so let's see what we got here. The first answer, very clever. This gets into regular expressions, which we haven't even come close to touching on, and I don't want to, so we'll skip that. This right here looks a little bit similar to what we did. So this is actually a double loop, so we're actually looping through 2 different arrays. I really don't want to get into that either, because that will make anyone's brain spin, to be honest. Got some more regular expressions. Let's see. I'm just looking for the one that I was thinking of that would be a lot. Okay, there it is. So we looped through this array, and what we could have done is just checked, instead of writing out this switch case statement, all we would have had to do is put the vowels in an array, and then we would have to take that array and use the includes method, and then loop through all the letters and check if that letter was included in that vowels array. So that's what I was thinking of, just a little bit easier way to do it. Looks like this person kind of solved it like us. But like I said, there's a ton of ways to solve each of these challenges. We can solve them however we want. So let's go to the next one. Looks like Jenny's secret message. I wonder what Jenny's secret message is. So let's train on this. I gotta take a little break here. solving all these challenges. It's tired. All right, here we go. So Jenny's secret message. Jenny has written a function that returns a greeting for a user. However, she's in love with Johnny and would like to greet him slightly different. That's romantic. All right, she added a special case to her function, but she made a mistake. So let's look at the function. It looks like we're just trying to edit some code here. All right, the first thing I'm going to do here is just run the test, see what we're getting. Kind of gives us some clues. All right, so now let's look at the code. Let's see what's happening here is that we have a single parameter called name. So that's basically saying, all right, this function expects a single argument to be passed through it when it's executed, and that is called name. Then we're going to use that name to figure out if we're dealing with Johnny. If we're not dealing with Johnny, then we don't want to add, any specialized message. We just want to say hello to that name. So up here, this is how we would do that. We're just concatenating a bunch of strings together. So we're saying we have a hello string, and then we're adding the name that is passed in, and then an exclamation point. So this is basically what we want to return for everyone except Johnny. All right, so that's what we want to return there. Let's space it out a little bit. And then if the name is Johnny, we want to return hello, my love. All we have to do here, I think, is reverse these. So what's happening right now is we're going through this function and it never even gets to this if statement because we're already returning something. So basically every time we run this function, it's returning hello, name with an exclamation point at the top. It never checks to see if Johnny is the name because that's like this code block down here just never gets reached. So all we have to do is cut that from there and put that at the top. So if the name equals Johnny, return hello, my love. So let's go ahead and test that. And it's going to pass. Now, something that you might be wondering about right here, if you've been watching the videos, is this if statement. So normally we write an if statement with these brackets, and then we would put the return right in there. And that's how I prefer to see it, but JavaScript has a bunch of little quirks. And if you have a simple if statement like that, where you're just returning a single line, you don't actually have to add the brackets. That's just a syntactical thing. This is totally fine. If we run the test again, it's going to pass. And let's go ahead and attempt it. So we passed the test. Let's go ahead and submit. Just going through a couple of the possible answers. Again, this is another ternary, or no, it's not. Yeah, this is using a ternary operator, so it's basically enclosing that ternary operator within parentheses, and then it's putting it in the middle of that string concatenation that we're doing. So very clever, but it's not something that we need to do. Totally unnecessary, and it's honestly not quite as readable as what we have done. All the other ones, these are rather simple. This is a nice one. This is a good solution. If the name is Johnny, we return this, else we return something else. We kind of did something similar, we just didn't add the else statement. All right, let's go to the next problem. The next problem is n divisible by x and y. Let's see what we got here. Okay, so we got quite a few examples. Create a function that checks if number n is divisible by two numbers, x and y. All inputs are positive non-zero digits. So again, this last sentence is useful because it's telling us, hey, we're not going to throw any, crazy arguments through this function. You don't have to worry about handling, different types of data. You don't have to worry about a string being passed into this data. In that case, you might have to convert it or just throw an error. But in this case, all inputs are positive non-zero digits. So it's going to be from 1 to infinity, basically. All right, so here are some of the examples. We might as well use these. So n equals 3, x equals 1, y equals 3. This is true because 3 is divisible by 1 and 3. All right, n equals 12, x equals 2, y equals 6. True because 12 is divisible by 2 and 6. All right, so it's basically, looking at all these numbers, trying to figure out if they're divisible by each other. All right. Immediately, I'm kind of thinking about that modulus operator again, because anytime we look at something that says, is it divisible by, that comes in handy. So, and then also the other thing that I'm thinking about initially is that it's saying checks if number n is divisible by both of these numbers. So this and is capitalized, which tells me that we're probably going to be using this and operator at some point. So just keeping that in mind as we solve it. Again, all inputs are positive, non-zero. So basically what we're going to do is we're going to do two different math problems. So we'll say result 1 is going to be equal to n divided by x. And then result 2 is going to be n divided by y. All right, so we're just running both of the math problems and we're getting it into a result variable. And then from here, all we have to do is basically divide, let's see, so let's go ahead and console.log out these results just so that we can see some output that we're receiving. So we will test it. Obviously everything failed, but you can see what we were getting here. So we're getting some decimals as we might expect if it doesn't go into it evenly. Now, a good way to check whether a number is a whole number or a decimal is using that modulus operator. And if you think about it, if we divide a number by 1, it's going to always go into itself, right? Unless it is a decimal. So if we were to, let's go over to our playground here. If we divide this by 1, it's going to give us 20. 19 divided by 1 is 19. But 2.5 divided by 1 is 2.5. So it's not a whole number, it's a decimal number. And because of that, the modulus operator is not going to return 0. So if we did 20 modulus 1, that's 0. 19 modulus 1 is 0. But 2.5 modulus 1 is 0.5. So any whole number is going to, if we do modulus 1, is going to return us with 0. So we can use that in our solution here. So we'll say if result 1 modulus 1 equals 0, and then this is where that and statement comes in, and result 2 modulus 1 equals 0, then we know that we have a correct answer. So let's see what it wants us to return again. It says checks if it's divisible, okay. Okay, so we're returning true or false. So in this case, we're going to just return true, and then if that's not true, then we return false. So if the first result, the first division problem, and the second division problem, if both of those are not equal to 0 when we use the modulus operator, then we return false down here. So let's test it, see what we get. Looks like we passed. That's great. Let's attempt it. And you can see that we passed all the tests. Let's see what everyone else was doing here for this. I'm going to guess that a lot of people solved it this way. But of course, there's always these clever folks out here that are just solving it in one line. This is interesting right here. I'm not going to go into it. These are not totally relevant to us. We solved it in a very straightforward way. It wasn't clever, but it was very straightforward, and that's all we're asking for here. So feel free to look through these. Let's go on to the next challenge. At this point, I'm going to try to solve these a little bit quicker, just so that we can blow through the rest of the video. I'll point things out as we go, of course, but I've kind of, harped on a lot of the most important things, like how to look at a test, how to think about it, how to Google, all that kind of stuff. So we'll try to speed through these a little bit faster. All right, so this one is return negative. In the simplest assignment, you are given a number and have to make it, or in this simple assignment, you are given a number and have to make it negative. But maybe the number is already negative. All right, so it's kind of implying to us that we have to check whether the number is negative first, and then we have to apply some sort of operation on it. So immediately we know that if we multiply something by a -1, then it turns it, the opposite sign that it was. So all we have to do is say if the number is less than 0, we know that it's negative, so we're just going to return the number because it's already negative. Otherwise, if it's not less than 0, then we're going to return the number multiplied by -1. And that should be the solution right there. We passed. I think this is going to work. It's a pretty simple, straightforward answer. So again, if you have caught on to this, when we're using the if-else statements, that's an opportunity to use a ternary operator. And you're going to see that in some of these solutions. So here is the ternary operator at work. It's basically the same exact thing that we did, has a little bit of a different thing. So you can just put a negative at the beginning of your variable to flip the sign of it. That's just a shortcut in JavaScript. But then there's another solution. This is actually interesting. If you use the built-in math function called the absolute method, that's going to turn any number to a positive value. So if we just turn everything that we get to a positive value and then reverse that to a negative, we're always going to get a negative value. So that is a clever solution, and honestly, I think that's the best solution if you just thought of using this. But of course, if you're a beginner, you're not going to think of using the math.absolute method because you probably don't know about it. But again, you can look up these JavaScript built-in functions, and I'm sure that this one might not show you. Yeah, so we have the math methods down here. And you could, once again, I'm on tutorials point. I just searched for JavaScript built-in functions. But we have these math methods, and the first one is the absolute method. So it returns the absolute value of a number. And if you knew that, you could think of it and just use that for our solution. So anyways, like I said, we're not going for the most optimized solution. We're going for the most straightforward and clear solution for a beginner. All right, so we're finding the smallest integer in the array for this one. All right, given an array of integers, your solution should find the smallest integer. All right, so this looks like a perfect opportunity to write a loop. And you can see in our solution here, this is actually getting us into the concept of classes, which we have not talked about one bit so far, but basically, each class is going to have, several different instance methods, and then the find smallest int is actually an instance method. So I'm not sure if we might be able to edit this. Let me see. Well, as you can see in the test, it's instantiating this new class, so we can't really do anything about it. But I'm just telling you, don't worry about the class right now. All we have to do is implement this method and we should be good. So within this method, we're going to get some arguments. This is actually what we would call this would be params, because that's what the params are, what we define within the function declaration, and the arguments are what we pass through it. But again, in those previous lessons, I told you that arguments and parameters are two sides to the same coin, and in this case, that's been demonstrated there. We're using args and params interchangeably. All right, so we'll just change it to params to stay consistent here. And then from here, we're going to go ahead and loop through this array. So the params that we're going to receive is an array of integers. All right, so and then it says at the bottom, you can assume for the purpose of this challenge that the supplied array will not be empty. So we don't have to handle the case where it's empty. But it doesn't say anything. Well, actually, yeah, it does. We're going to get an array of integers, so we're good. So let's go ahead and assume that the params is an array. So I actually want to name this something even more descriptive. So we'll call this array of numbers, just so that we can remember what we're doing. And now we're going to make a for loop. So basic for loop here. And let's go ahead and go until we get to the end of this. So we're going to grab the length of that array of numbers. And then for each number in the array, we're going to check if it is the smallest integer. So to do this, we actually have to declare a variable here that's going to keep track of the smallest integer as we loop through the array. So let's just call this the smallest number, and we're just going to declare it because we have not looped through any of the numbers yet. So, or actually, yeah, let's go ahead and declare it the smallest number that we can possibly get. It's an array of integers, and we might get negative numbers. So let's just go ahead and initialize this at 0. So just for comparison purposes, you'll see what I mean in a second. So as we loop through this array, the way that we're going to get an individual number from the array is by using this syntax here. So we're going to grab the array itself, and then we're going to pass in the index, which should be I, which is going 0, 1, 2, 3, all the way till the length of the array. So that's going to represent our number. And just for clarity, I'm going to go ahead and say that. So we'll just say individual number equals that. So that's what we're going to do for each loop. We're going to declare and assign a variable for that. Then we're going to check and we're going to say if the smallest number is greater than the individual number. You also could have said if the individual number is obviously less than the smallest number, either way works, then we're going to set it to a new value. So if the smallest number is greater than the individual number, so the well, maybe we should name this something more descriptive. So individual number, array, we'll just say array number. That's a little bit more descriptive. I'm sorry, this is not right even at all. I just need to take a little break here from talking. So what we want to do is we want to say if the array number that we're looking at, in this iteration, if this is less than the existing smallest number, then what we want to do is we want to set the smallest number equal to that array number. So it takes its place as the new smallest number. And basically what's going to happen is as we loop through the array, it's going to check each number, and if it's not smaller, then it's just going to skip it and it's going to go to the next iteration of the array. So we really can come down to the bottom of this and return from this function the smallest number after we've looped through all of the numbers in the array. Let's go ahead and test this. Looks like we failed some, so I think this is because we didn't handle negative numbers. Let's see. Oh, actually, this is just a mistake on my part. So I initialized this at 0. But this is a problem if we have positive numbers, because if we have an array that are, full of positive numbers, so let's say that we had an array that looked like this. We had 2, we had 5, and we had 6. It's going to loop through all 3 of these numbers, and it's going to compare it to our already smallest number of 0, and none of these are smaller, so the smallest number at the end is going to return 0. So we need to actually not declare this. We're going to actually just declare it and not assign it, and then the first thing we're going to do at the very first iteration of the loop, we're going to set the smallest number equal to that first number. So we're just going to say if I equals 0, which basically means we're at the very first iteration of our loop, we want to set the smallest number equal to the array of numbers, and then we want to grab that index of I. And actually, we can actually put this below. So let's get the number that we're talking about first, and then we can replace this now with array number. Okay, so just to review what I just changed here, what we're doing is we're saying we're going to initialize this or declare this variable. It's not going to have a value yet, so we have to assign it a value on the first iteration of our array. So the first value of the array basically. And we know that that's always going to be when I is equal to 0. So first, let's get the number that we are looking at in this specific iteration. We'll assign it to the array number variable, and then we're going to ask, is this the first iteration of the array? If it is, I want to set the smallest number variable equal to the first number in the array. So now we have something to compare against, and in the same iteration, so still on the first iteration of this array, we're going to compare the array number to the smallest number. They're going to be equal, so we're not going to get there. It'll go through, and now it should work a little bit better for us. And now we have an infinite loop because I'm just getting scatterbrained here, and I actually set I equal to 1 when I was looking at this conditional. And that is a big no-no, because what's happening is now we're going through this for loop. In each iteration of the loop, we're resetting I to 0, and therefore we have an infinite loop. And that is actually something that you'll stumble upon a lot, and infinite loops are not fun. So make sure you don't make that mistake. Let's replace this with triple equals, which is going to actually do a equality comparison. We should be better off this time. So we passed all of them. Let's attempt it. And we passed the test. At this point, I'll probably take a break because I'm getting a little bit fuzzy in the brain here. So let's submit this, and let's just look at what other people did. Obviously, there's a better solution in all cases, but I don't think any of these are at the level that we're at right now. At this point, I just can't even think anymore, so I'm going to take a break, and we'll come back and finish the rest of the problems. The next challenge is grasshopper summation, so we'll see what that's all about. It says write a program that finds the summation, the sum, of every number from 1 to the variable called number, or num. The number will always be a positive integer greater than 0. Remember, pay attention to this right here. We don't have to worry about negative numbers in this case. Let's just look at an example, because I want to go through that first. So if the number is 8, it's just saying go from 1 to 8 and add everything together in succession. So the first thing that we'll notice here is that it's only adding 1. So it's not only adding 1, but the number that we're adding only increases by 1. So it looks very similar to a for loop. So we can probably write a for loop. So let's go ahead and template that out. So we'll let I equal 0 to start. We might have to change that actually. And then we'll say I is less than num. I is less than num, because we want to go through as many iterations as we need to get to num, or the value that's passed in, and then we'll say I plus plus. So we start at the value of 0, and if we add 0 to something, that adds 0, so that doesn't matter. So we're fine doing that. And then it wants to go until I is less than the number. So in this case, we may have to actually start this at I equals 1, and then we say I is less than or equal to number. So let's go ahead and do that. Let's start it at 1 and then go up to the number. And for starters, I just want to print this out to the console and see what we get. So I want to print out I each time in the loop, and since it's not a very good place to do that, I'm just going to go over here to my DevTools console, and we're going to paste that in there. And of course, num is not defined because we don't have that passed as a argument or anything to the function. So let's just put a random number. Let's put 10 in there and press enter. And what we're going to see is that it counts 1, 2, 3, 4 all the way to 10, which since we started it at 1, we get to 10. But if we were to start this at 0 like we normally do for a loop, and then we take away this equal sign, it's going to go from 0 to 9. And if we add all these numbers, it's not going to add up to the right sum. So it's very important that we start it at an iteration of 1, and then we go all the way up to 10. So we put that little equal sign. We also could have, deleted that and gone up to less than 11. But you kind of get the point. Just be conscious of that. Now, all we have to do is make a variable called the sum, and we'll initialize that at 0 because we start at a sum of 0. And then all we have to do is say sum equals sum plus I. So when I starts at 1, so we're saying 0 plus 1, then I increments to 2, our sum is going to be stored at 1. So we do 1 plus 2, and then we go I equals 3, so our current sum is going to be 3 because we did 1 plus 2. So then 3 plus 3 is 6, so on and so forth. So that's going to give us our sum. Another way we could write this, if you were paying attention during the previous video where we went through the mathematical operators, you can just do plus equals and then you can say I. So what this is going to do is it's going to take sum and it's going to say what is the value of the variable called sum, and then once it finds that value it says take that value and add the value of I to it. So this is an abbreviated version of doing that, but again I'm going for readability here, so I'm just going to say sum equals sum plus I. That's the most clear way that we could probably write that. So then we get to the bottom, we've gone through all of our iterations, so this sum variable should equal the sum of all of those different I values. So now we just return the sum. Let's see what we get. We passed both test cases. I think we've got it. All right, so we passed all 105 test cases. I'm not sure why anyone would want to write 105 test cases for this, but nevertheless, let's submit our answer. All right, let me just check to see where we are within this series. We'll go to collections. All right, so we are on get the mean of an array. So let's see where we are here. All right, so we're right here with 1, 2, 3, 4, 5, 6, 7, 8 left. All right, not bad. Let's go ahead and train on this. So get the mean of an array. All right, the instructions say, it's the academic year's end, fateful moment of the school report. I'll remember that. The averages must be calculated. All the students come to you and entreat you to calculate their average for them. Easy, you just need to write a script. All right, when they say a script, that's basically just saying you need to write some code. Return the average of the given array rounded down to its nearest integer. The array will never be empty. So you're always going to get a number in this array. And it says round it down. And what I'm going to think about immediately is we are going to use one of those utility functions or the built-in JavaScript functions. So how do we round a number down? Let's go to the built-in functions. We're already looking at the math methods, and we can see that if we look at the floor method or function, it says it returns the largest integer less than or equal to a number. So basically rounds it down. So math.floor is going to round our numbers down, and if we go to the console here, let's go ahead and clear this because we got so much stuff going on. And if we say math.floor, and then pass in a number 20.54, it's going to give us 20, so it just rounded it down. So that's basically the round down function. We're going to use that in our practice or our challenge here. This is kind of a useless comment. Once again, this marks right here, I don't like the name that they've given this, so I'm going to rename it because we can name our parameters anything that we want. So I'm going to say score array. So we're going to have all of the test scores or whatever scores we're doing here. Now within that array, let's see, what do we have to do again? We have to get the average. Okay. So what is the average? The average is going to be the sum of all the numbers divided by the count of all the numbers. All right, so that's your average formula. Pretty simple there. So to get the count, that's the easy part, we'll just say the score array dot length. So that's going to give us how many numbers are in this array. And then for the sum, unfortunately, this is something I know from just writing code, there is no sum function of an array like built into JavaScript. So if you were to go to Google, let's go to Google and search how to sum values in array JavaScript. And let's go to Stack Overflow. You can use this method called reduce, and then you can actually use an arrow function. But this is rather complicated, and it's not really at the level that we're trying to be at right now. Right now, we're just trying to do it in the most straightforward way possible, and this kind of comes later when you're more experienced writing JavaScript code. So in our case, we can do it a little bit easier with a for loop. So all we have to do is write ourselves a loop, start it at index of 0. We want to go until we've hit all the numbers in the array. So we can actually, in this case, we've already gotten the length of the array. So all we have to pass in here is the variable count that we stored that in. So that's a way to simplify your code. And then finally, let's break down here. All right, so we're going to loop through each of these, and what we want to do is add them all together. So kind of similar to the last problem we did, but in this case, we want to assign, so we don't want to count, we don't want to say the same variable. So we'll say the sum equals 0 right now. And for each iteration, we're just going to say sum equals the existing sum amount, so it starts at 0. And then each time we iterate through the array, so the score array, we're going to grab that individual number that we're looking at and add it to the existing sum. So now we get down here to the bottom, we have the count and we have the sum. So let's go ahead and just return the average, which is going to be the sum divided by the count. Let's see what this results in. All right, so we passed 2 of them, but we failed 1 of them. And the reason is because we forgot to round down. I forgot that requirement. So all we need to do is surround this with the math.floor function, and that should return the right answer. I could have broken this out onto the another line just for simplicity. So we'll say the average is the sum divided by the count. And then we can say rounded down equals math.floor, and then pass in the average. So take the variable we just assigned here. And then we just want to return the rounded down variable, and that should give us the same answer. Hopefully we get this right this time, and we did. Let's attempt it. We should be able to get this. Awesome. So that's just how we would solve that problem. So as you can see, just to take a slight break and review what we're doing here, a big part of solving these problems is obviously getting the instructions right and understanding what type of input we're going to be receiving into this function. The second part, with these easier challenges, we're going to do a lot of looping through arrays and stuff like that, and that is actually really consistent with the real world. When we're writing code and building apps, we're going to be doing stuff like this quite a bit. We're not going to be solving useless problems like this, but we're going to be looping through arrays a lot and setting counter variables and sum variables, all that kind of stuff. So this is actually going to be testing us on very useful skills that you're going to use in the future. All right, so if you remember from that Stack Overflow question, they're talking about reducing it to get the average, and you can see that that's exactly what the top solution, or I guess the best practice solution, is doing. It's basically using marks.reduce, so this is going to get us the average. Then we're going to divide it by the length, and then we're going to put it to the floor, so basically round it down. So that's what I was talking about with this Stack Overflow solution. Honestly, if you ask me, it's kind of weird that the arrays don't have an average method. Seems like a very common one to have, but nevertheless we don't. So, all right, so this challenge looks like we have a picture to look at. Let's do some rock, paper, scissors. Okay, so it says let's play. You have to return which player won. In case of a draw, return draw. Okay, and this is just a reminder of how rock, paper, scissors works. I think most people would know that. Immediately when I look at this, I'm not a huge fan of this. So we're naming the variable that we're storing this arrow function in as RPS, or rock, paper, scissors. I'm going to just rename this because we need to have meaningful variables here. So we're going to name it rock, paper, scissors spelled out. And then P1 and P2, again, these are not very descriptive. So let's replace those parameters with something that makes more sense. So player 1 and player 2. All right, so now we've got this written out. I like this a little bit better. Now let's go through our different cases. So first thing you might want to do is write some pseudocode. So pseudocode is basically, just writing out like logically how this should work. And maybe this isn't even considered pseudocode, but let's write out all of the different scenarios that we can have. So we'll say rock is R, paper is P, and scissors is S. All right, so for player 1 over here, and then player 2, and then the result. So let's go ahead and write these out. We have player 1, we'll do rock. And then since there's 3 different possibilities, we're going to have just a matrix of possibilities. So we'll go rock, 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 paper, 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 scissors, scissors, scissors. Okay, so that's all of the possible plays that player 1 can do. And then obviously we will go through with player 2 over here and we'll alternate. So we'll go rock, paper, scissors. And then again, we'll go rock, okay, so in this comment, we've written out all of the different possibilities and who's going to win in each case. So you can see that there's 3 draws, 3 times where player 2 wins, and then 3 times where player 1 is going to win, as we might expect. So how can we convey this, what we're seeing right here, in code? And to answer that, there's a couple methods that you can go about doing it, but once again, I'm going to try to go with the simplest, most straightforward, and easy to read method. So seeing this written out like this, where we have all these different scenarios, I think that we can say that we're going to go with player 1 and just have 3 if statements. So if player 1 chooses rock, if player 1 chooses paper or scissors. So we'll just put out those if statements real quick. So we'll say if player 1 equals rock, and then we're going to copy that down. Okay, so we got rock, paper, scissors. So these are the 3 scenarios for player 1. And then for player 2, we're obviously alternating between these. So let's say player 1 plays rock. So we could probably put a switch statement in here, but I don't know if we need to. So we'll just say if player 2 equals rock, then that's going to be a draw. So we're going to return draw. Then we'll say if player 2 equals paper, then that is going to be return player 2 won. And then finally, if player 2 equals scissors, then in this case, return player 1 won. Okay, so now we can basically just copy these same 3 down into each of these. And this is going to work. So this one's complete. So let's just fill out the rest of the results. So if player 1 chooses paper, player 2 chooses rock, it's going to be player 1. So if we're going paper against paper, it's going to be a draw. And then player 2 for that last one. All right, and then scissors versus rock. So we're going to say player 2, 1. This one will be player 1, and then this one will be a draw. Let's go ahead and test this. Looks like we failed, and it's complaining that RPS is not defined, and that's just because I changed the name of the function at the beginning of this, which I guess I can't do after all, but I would not prefer to see it like this. It should be more descriptive. So let's go ahead and test that. And it looks like all of them passed. So we fulfilled all of our different scenarios that we wrote out for ourselves, but I can guarantee you that there is a more efficient solution, because in many cases we have like overlapping scenarios. But if you're just thinking about this logically and you want the easiest thing to read that, you know, even a beginner could go through and understand what it's doing, this solution works okay. So let's attempt it. We passed our test, and let's see how someone who is going to optimize it a little bit more would have solved this problem. Okay, so here's the first one. So it's saying if P1 is equal to P2, then we return a draw. So that eliminates 3 of our scenarios that we had to write out in separate if statements. So that's already reducing our amount of code by a lot. Then what they're going to do is they're going to put the rules within an object, which is actually quite interesting. So they're basically saying that for one player, here is the rules. So rock is always going to beat scissors, paper is always going to beat rock, and scissors is always going to beat paper. So that's very interesting how they're doing that. And then they're saying if P2, so player 2, is equal to the rules, so it's grabbing whatever player 1 responded with, and then it's going to grab the value of that and compare it to what player 2 responded with. Yeah, so this is a very, very smart solution, very efficient, but at this point, after solving however many we've solved here, 20 or so, my brain's a little shot, and we're going with the simple answer here. Now this is something a little bit closer to what we might have been able to do. So we could have combined the conditions into expressions. So rather than separating it out into a bunch of if statements, we could have combined them together. This is how we kind of started doing it. So obviously there's a lot of solutions to this problem. All right, this next one looks relatively straightforward. Oh, it says it's pretty straightforward. So your goal is to create a function that removes the first and last characters of a string. You're given one parameter, the original string. You don't have to worry with strings with less than 2 characters. Okay, so this is going to be a great time to use one of these built-in functions. So let's go to the string methods and see what we have available to us. And string, so this is what we're looking at. So we could use this character at, because we could specify the end of the string and the beginning of the string with 0, and then, you know, we could find the length of the string to find the last character. That seems a little bit indirect though. Let's see. We can also return a substring. This is actually going to be the most direct route here. So a substring is going to return the characters in a string beginning at the specified location through the specified number of characters. Okay, so I'll show you how we're going to use this, but first let's kind of get an idea of how it works. So if we have a string and that string is hello, what we can do is say string.substring, and maybe I want to start at the very beginning, which is going to have an index of 0. Now we haven't really talked about this. We've always talked about arrays having indexes, but strings also do as well. You can think of each individual character within this string as being a separate index. So H is going to be an index of 0, E 1, L 2, so on and so forth. So if we're starting at index of 0, that means we're starting at H. And then the next argument that we get to pass in according to the instructions that we looked at here, I kind of know how to use this already, but you could click on here and it's going to say we're going to pass in what we want to start with and then the length that we want to grab. So let's go ahead and grab 2 characters from this string. So we start at H, and then we grab 2 full characters starting there, and we get he. So if we would omit this, we're just going to start at 0, or start at the beginning, and get all of the characters. But if we replace this with 1, we're going to get all the characters except for that first one. So we're actually partially to our solution. We've got the first character removed. Now we have to figure out how to remove the last character. And to do that, we have to figure out how long the string is in total. And to find out how long the string is, I believe there might be, I think there's a method for that, or a function. So there should be, yeah, string.length. So let's try that out. Let's get rid of this. And we'll say string.length is equal to 5. So if we know the length of the string, and we know that the string starts at an index of 0, we then know where our substring is. So all we have to do is say string.substring. We want to start at index of 1 because that omits the first character of our string. And then we want to end, or not end, we want to grab how many different letters? Well, we want to grab, let's see, the string.length minus, what would it be, 2? Yeah, it would be 2 because we've removed the first letter and we want to remove the last letter. So we want to grab just the total length of the string minus 2. Okay, so that is our solution right there. Let's just go ahead over to our problem and write it out. So this is pretty easy. We just return string.substring, or maybe we can break this out so that it's, you know, clear as day for you. Length of string is going to be equal to string.length. And notice how I have not added these parentheses at the end. That is just the nature of this function, and I just know this by experience, but you'd figure it out probably by Googling it or at some point after you try doing this. So let's say we try to do this as we would think. This makes logical sense, but it's going to say string.length is not a function. Now go ahead and copy this, just copy this, and paste it into Google, and you're going to get Stack Overflow answer that tells you how to do this, and it says, oh, you have to use just .length and you don't have to add those parentheses. So that's how you might figure that out on your own. But I happen to know that that is how we write it, so string.length, and then we need to get the substring, so we'll just return that straight away. String.substring, we want to start at the first character, or actually the second character, and then we want to get the length of string minus 2 characters. Okay, so let's see what we get. Passed the test as we expected. Okay, let's submit it. Now, as you can see, there's a maybe even simpler way to do this. So we can use the slice method. If we go to the built-in functions, if we would have looked, so we grabbed the substring method, but there is a slice method, which is right above it. So extracts a section of a string and returns a new string. Well, in this case, I was just not being smart. I overlooked that and didn't realize. But if you just read through these, this would obviously be a better selection than substring. But it does give us the idea that you can solve this in multiple different ways. And I'm sure that at some point, yep, down here, someone solved it the way that we solved it. In this case, they're doing string.length minus 1, which is very interesting. Oh, so this is actually not the same. So substring is different than the one that we used. As you can see, we have the one that we used and then substring. So these are two different methods. They work kind of similar, a little bit different. So that's why that one works that way. But you can see that this person used exactly what we did. So multiple ways to solve a problem. Let's see if we can blow through the last couple of these. So let's go to sum of positive. You get an array of numbers, return the sum of all of the positive ones. Okay. So we're going to loop through this. We're going to grab every number from that array, and then we're going to say if the individual number that we have grabbed is greater than, we'll say greater or equal to 0. Or I guess we don't even need that. We just say greater than 0. Then we want to sum it. But we need to have a sum variable, so let's initialize a sum variable and set it equal to 0. And then we'll say if it's a positive number, we're going to say sum equals sum plus the number that we're using there. And then at the bottom, we just return the sum variable, and we should get the correct answer. Passed it all. This is pretty similar to a previous question that we did in this video. So we'll submit this. As you can see, this is a well-commented solution that is kind of the same thing that we just did. So we didn't do too bad. Now obviously you can use a simpler method, so reduce, similar to how you'd find the average of an array. But once again, this is pretty complex. Like, you're using a pretty complex function on an array, and you're using a ternary operator within here. So that is optimized to the max. So we got some basic mathematical operations. Let's go ahead and go here. It says your task is to create a function that does 4 basic math operations. It should take 3 arguments. So we want the operation, which is going to tell us, are we adding, subtracting, multiplying, or dividing? And then the 2 values we're doing. So this is rather simple. This person has formatted this function a little differently than we're used to. This is just a different way to format it. I'm just going to bring it back to how we're used to seeing it. Doesn't really matter. Okay, so the basic operation. So the first thing we want to do is write a switch statement. You're probably getting used to this at this point. And for the switch statement, we want to pass in the operation. So it's going to evaluate that and see what the operation is. And in the case that the operation is a plus, we'll do something, add a break statement, and then we'll fill in the rest of these with case statements. And then I believe all we have to do is just fill these in. So we can return from here, or we could set it equal to a variable. So since we added the break statements, let's go ahead and just initialize a variable. We'll call it result. And we're going to say the result is equal to value 1 plus value 2. We can copy this same line down. And then at the end, we can return the result, whatever we get. So let's indent these correctly. Doesn't really matter, just for readability. And then we'll just change the sign here. So we can put a minus sign here. We can put a multiplication sign here and a division sign here. All right, let's go ahead and attempt it. All right, that worked. I have a feeling that someone solved this in one line. We'll see. This is how we did it. Yep, right here. So this is very simplified, but let me explain what this is doing. So if we type in eval, let's look at JavaScript eval, and we're going to learn about this a little bit. So what this does, the eval function evaluates or executes an argument. So if we have 3 arguments passed in, we have the operation, we have the first number and the second number, and it's always going to be the same for each one. So each one we're just substituting this operation. Well, you might think, oh hey, let's go ahead and train again on this one so that I can show you exactly what I'm talking about. So let's go up here, and in this case we might just say return the value 1 and then the operation and then value 2. Now this is going to obviously not work. That's not valid JavaScript right here. And all we're trying to do is we're trying to turn this operation into a JavaScript operator. And all we have to do to make that happen is surround it in this eval statement right here. And basically what it's going to do, I believe you separate it by comma separated values. Or no, you put it in one big string. So let's go ahead and create our string. So our operation string is going to equal value 1 plus operation plus value 2. And in this case, some of these are going to be numbers, so yep, that should work because value 1 is a string, so everything else is going to be coerced into a string, so that should work. So operation plus value 1, value 2. And then I want to just console.log that so that we can see what it represents here. So we'll console log that and comment out this return value for just a second. So let's test that. And you're going to see that the console log is giving us the following operations here. And if you look at these look like valid math operations. But right now we just have them as a string. But once we enclose it in the eval function, so we say eval, and then we pass in our operation string, it's going to evaluate that string. So in other words, it's going to evaluate the string of 4 plus 7. And then we can just return the result, and this should work the same as our much longer code that we wrote. So let's go back and just see what that one person wrote there. They just, abbreviated everything but did the same exact thing. So just another way to solve it, more efficient. Next up, we have a string repeat. Write a function called repeat string, which repeats the given string source exactly count number of times. Okay, so this is what we're going to get. They're going to pass in, we want to repeat it 6 times or 5 times, and here's the string that we want to repeat. This is another classic example of where you can use a loop. So we'll just set a loop equal to just the basic syntax. We want to go until I is less than n. So let me replace these number of repeats and then the string that we want to repeat. So number of repeats. Okay, so we're looping through this, and let's go ahead and make a starter string. And we'll just set that equal to just an empty string here. Now, all we're going to do is concatenate strings as many times as this loop goes. So we'll just say starter string equals whatever exists in that starter string plus the string value. And this should return the correct answer for us. It works. Pretty consistent with what we've done in previous problems with the loop. And then we have a variable up here that stores some sort of value that we later return after we've modified it several times with values in a loop. And of course, there's an easier solution. So you can see down here that we can just use the repeat function. I didn't actually know this was a function. But if you go to the string methods, there should be some sort of repeat. So let's see. I'm not seeing it right now. What are they doing here? So that is a string method. Did I miss it? Let's search for it on the page. Don't see it here. This might be a new method. Okay, so maybe use W3 schools. It's more updated. That must have been a recently added method of some sort. Yeah, it looks like this came out in ES6, which is the newest version of JavaScript spec. So that's probably why it's not on the other site there. Interesting. So you can use a repeat string to repeat a string number of times. Very interesting. Okay, go to the next problem. Convert a string to an array. This should be very easy because we've already done it. At least I think. We've done so many problems at this point. I think all we have to do is say string dot split, and then we split it with an empty character. Oh, that's not how we do it. Okay. We don't want to split it like that. So let's see. Oh, okay, so we want to split it by spaces. So there's a space in between these words. So all we have to do is press the space bar in between these quotes, and it adds a space in here that we want to split it by. And this one does pass. You can see that pretty much everyone solved it the exact same way here. Should be getting to the end of these problems here. Congrats if you are still around and solving these problems with me. I would presume that very few people would be. So remove string spaces. So remove the spaces from the string, then return the resultant string. Now this one feels like there is some sort of built-in method that we can use. Since we didn't find the newer methods on tutorials point, let's go to W3 schools. I'm thinking something called trim. Yeah, like trim might do this. It says remove white space from both sides of a string. I think that's what we're looking for here. So let's go ahead and return x, which should be a string. Like, I don't know why they're calling it x here. Just call it a string. So string dot trim. Let's see what that does. This is not going to work. Looks like there's some numbers put in here. And it looks like the trim method is only going to do this at the end of the string. So let's try this out in our dev console. Let's do a test string, string that has spaces between. Oh, I'm just blanking out completely. I got to name this variable. So string equals that. Sorry about that, I'm kind of losing it here. All right, so if we use string.trim, it looks like what's happening is it's only removing the spaces at the end, kind of as this tells us. So I wonder if there's another method. Don't know if there is. So what we're going to do is we're just going to combine the methods together. So first, maybe we put this into an array. So we'll say string.split, and we want to split it by a space. So now that we have everything split out, now we want to go through each of these in the array, and we want to remove the white spaces around them. So let's go ahead and write this code out and see what we get. So we'll turn it into an array. So we'll split it by spaces. And then we're going to loop through this array as we've been doing. And for each item in the array, we're going to remove the spaces around it, and we're not actually going to build a new array. And so this is going to introduce the push method. So we'll say new array.push, and what that's going to do is add an element to the end of the array. So right now it is an empty array, and we can push items into the array. And what we want to push is going to be the trimmed version of each string that we have, or each different array item, which just happens to be the subsets of that original string. So in this case, we'll say trimmed string, just breaking this out for clarity, is going to be equal to the, what are we looking at? So the array at index I dot trim. So now we know that this string is trimmed together. There are no spaces anywhere. And now we're going to push this into the array. So at this point, let's go ahead and console.log that new array that we're getting. So let's test that. And you're going to see that we have an array in every case that's going to have, the characters with no spaces around it. And in this case, it's just an empty string that's not even a space or anything. So if we combine that, it's not going to add any spaces of any kind. At this point, we can use a method called join. So all we have to do is our final string is going to be equal to our new array.join, and we want to join it by that empty character there. And at this point, we can return the final string, and I think that that should solve the problem. All right, so we passed it. Looks good. Okay, I think we're closing in on the end here. Beginner, lost without a map. Given an array of integers, return a new array with each value doubled. Okay, so there's actually, it says for the beginner, try to use the map method. And this is basically just saying to you as the beginner, like, hey, you could solve this in an easier way, but go ahead and try to use the map method. So we'll do that. We might as well. So we're going to get some array. I'm just going to rename that so that it's not undescriptive. And then we're going to go and look at the map method. And this actually belongs to arrays. So we go to JavaScript Arrays, and then we go down to the array methods or functions. And you're going to see this one called map down here. And what this map function is going to do is it's going to take the original value in the array and it's going to apply a transformation to it. And that transformation is just basically going to return a brand new array where every unit of that array has been transformed. So previously we have been going through these for loops and storing things in variables and creating new variables and stuff like that, but we could always use this map method. So let's go ahead and try it. So we're going to return the array.map, and then in this case we actually have to pass in an arrow function. So this is what we call like a callback function. We'll get into this a little bit later, but we're going to have a callback function. So this right here, let's just break it out, into a separate space so you can see what we're doing. So all we're doing is writing an anonymous function or a arrow function, and then within that arrow function, we're going to break down into the new line, and we're going to return a value. So this is a very weird setup here. So I'm actually going to go ahead and remove this. So I'm going to say our result array is equal to whatever this map function returns, and then we're going to return the result later so that we don't have that weird syntax. So basically whatever we return from this map method, or this function that's actually embedded within the map method, whatever we return is going to be the transformation. And then whatever we pass into it, so we can just provide a parameter. So array item is going to be what's going to be passed into there as an argument. So we're going to just say array item multiplied by 2, which is what they want us to do with each value. So this is going to return us an array with the values doubled in it, and we return the result. We passed. I would suggest reading up on that method, trying it out a little bit, but just realize that what we've done here is we've put a function within this other function that takes that function as an argument. So to summarize this, we've basically passed in a function as an argument to another function. And then that function actually executes our function that we passed in. So it's a bit of a tongue twister, but you will understand this with due time, and I would definitely put this on your radar as something that's very useful in JavaScript. At this point, I'm doubting myself for picking 25 problems. This is exhausting, but again, congrats if you're still around. Let's keep going. All right, is he going to survive? A hero is on his way to the castle to complete his mission. However, he's been told that the castle is surrounded with a couple of powerful dragons. Each dragon takes 2 bullets to be defeated. Our hero has no idea how many bullets he should carry. Assuming he's going to grab a specific given number of bullets and move forward to fight another specific given number of dragons, will he survive? Return true if yes, false otherwise. Okay. So basically what this is saying to us is that we don't know how many bullets are coming, and we don't know how many dragons are coming either, but we still have to figure out if this hero is going to defeat the dragon. So let's see how we do that. The rule is this: each dragon takes 2 bullets to be defeated. Okay. So basically what we could say is if the bullets is double or more than the amount of dragons, then we return true. So we'll basically just say, in this case, let's go ahead and use the ternary operator. I know it's late in the video, brain's probably fried at this point, but let's use the ternary operator. We'll store it in a result variable. So we'll say if the bullets divided by dragons is greater or equal to 2, then we're going to return true. Otherwise, we'll return false. And then we can just return the result, but we don't even need to do that. We can just return that ternary operator. So let's go to the beginning and hit return. So basically what it's doing is it's looking at this expression and it's evaluating whether that expression is true or false. And then if it's true, we return true. If it's false, we return false. So there's actually some duplication going on here. We don't even need this ternary operator in the first place. All we have to do is return that expression, because if this evaluates to true, then the hero defeats the dragon. If not, then we return false. So we should be able to just do this. We passed it and it works. So that's how you would solve this in the most simple way possible, and honestly it's just a math problem plus a JavaScript expression with some operators. Array plus an array. So let's train again. I'm new to coding and now I want to get the sum of 2 arrays, actually the sum of all their elements. I'll appreciate for your help. It looks like this person was not writing a challenge, they were asking a question. Okay. P.S. Each array includes only integer numbers. Output is a number 2. Maybe they weren't asking a question. Very, very weird wording for this. Okay, so this is not going to work. Let's go ahead and test it as it's written. You can't just add an array together. But what you can do is you can loop through each value of the array. And this is actually a perfect time to talk about embedded for loops. Let's go ahead and do that. First, we're going to write our outer for loop, which is just what we've been writing all this time. So we're going to say until I is less than array.1 or array1.length, I++, and then we go into it. Okay, but we also want to grab the values of array 2. So basically what we're trying to do here, let's say that we have an array of 1, 2, 3 and an array of 2, 3, 4. Our resultant array should be 3, 5, 7 because we added the number at index 0 for both arrays, then we added the number at index 1 for both arrays, and then we put it into a new one. So that's what we're going for. I'm going to leave this down here for a second just for our reference. But in this first loop, all we're able to get is, or actually we don't need an embedded for loop. I don't know what I was thinking there. All we have to do is this. We just have to say array1 value is going to be equal to array1 I, and then we can come down and say array2 value is array2 I. All right, and then we want to say added value, something like that. So we'll say array1 value plus array2 value. That gives us the sum, and now we want to start building a new array. So new array equals something empty, and like we did in a previous problem, we can use the push method to push a new value to that array. So we'll just say the added value here, and now when we get done with this for loop right here, we should have this new array populated with our new value, which should be this resultant summed array. So let's return the new array and see how it goes. Looks like we failed in a lot of cases. Okay, let's see why. Oh, so I misinterpreted this question entirely. We want to actually give a single number. Okay, so I'm new to, okay, blah, blah, blah. So we got two arrays, we want to sum all of their elements. Okay, so we don't need a new array, we just need a sum variable, which is going to start at 0. So the added value, we can keep that. Then we can just say the sum equals the sum plus the added value, and then return the sum at the end. This time we passed it. Okay, just misread the question, and honestly, I don't know if this was the best question to choose. I think this is our last easy question coming up. Maybe so. All right, so this one has some nice clear instructions. That's nice. So the introduction, the first century spans from year 1 up to and including the year 100. The second from year 101 up to and including the year 200. The task is given a year, return the century it is in. So the century of 1705 returns the 18th century. Okay. I mean, this is just pretty basic, so let's go ahead and solve it. Now it looks like the catch here is going to be these two examples. So 1900 is going to be the 19th century, while 1601 is going to be the 17th. So like it says, if it's, you know, one greater than the even year, then we go up a century. Okay. I believe we can use some sort of modulus operator here. Let me try. So let's say that we have a century of 1901. Let's go ahead and do modulus. We'll just start with 100. Okay, so 100 goes into 1901. Well, it would be, what, 19 times with a remainder of 1. But if we had 1900 modulus 100, we get 0. Okay, so that's interesting. So what we could do is we say if the century we have modulus 100 returns us 0, then we want to just grab the first two letters or first two digits of that number and return it. So in this case, 1900, we just want to return 19, I believe. Right, so we just want to return 19. So let's just say that. This may be a bad solution, but let's try it. So if the year modulus 100 equals 0, then that means it's an even century. So we're going to just say we want to return the first two digits. And to do that, we can, let's go ahead and look at some of the number values. Okay, so pretty much what we're going to have to do is we're going to have to convert it to a string, grab the first two, digits or characters, and then convert it back to a number. This may be an indirect way to do it, but we'll try it anyways. So we'll say year to string, Then I'm going to chain something on here, and I want to grab the substring. In this case, I want to start at 0 and grab 2 characters, and then I want to turn this entire thing into a number. So we'll just cast it into a number this way. And let's go ahead and test that to see if we solved a couple of these. Excellent. So we solved the ones where it's an even. Now, if it's not, then we know that it's not an even year, so it's always going to be one greater. So 1705 returns 18. So again, we can grab that substring. So we're going to grab first 2 digits. It's going to be equal to the year, toString, substring 02. So that gives us the first 2 digits. And we want to keep that as a number. And since we're repeating ourselves here, let's go ahead and put this at the top of our code and just get that from the very beginning. And now we can take this expression here and replace it in here. So all we have to say is first 2 digits. So now that works the same. We're turning that into a number. But down here, what we want to first do is we want to return a number, of course. Well, it's already, okay, never mind. So this is going to give us a string. We need to return a number. So the first thing we need to do is turn that into a number by saying first 2 digits. And then we want to add, since this is a number, then we want to add 1. So I think this may work, actually. Okay, so the problem here is the test for year 89. Since we're doing modulus 100, of course this is not going to work if it's less than 100. So in this one edge case, we could just put this at the top, at the very top, and say if the year is less than 100, we just return 1. So that takes care of that case, and we test it. Should pass all of them. We'll see if it passes all the tests. Okay, so clearly that was a quick fix solution. It didn't actually solve our greater problem. So let's dig in to see what we're dealing with here. Obviously there are larger numbers at stake and much smaller numbers at stake. So our attempt at using modulus 100 is not going to work very well. So I believe our solution may be close. I'm actually going to go ahead and see if there's something in the discussion down here. So you can always look at the comments and suggestions to see what other people are thinking about. We'll see. Okay, these are very useless. Okay, so this is not really helping us that much. At this point, my brain's so fried, we're going to go ahead and search this on Google Stack Overflow. We'll just say century from year JavaScript Stack Overflow. Just curious to see how other people solved this. Okay, so it looks like what they're doing here is using the math.ceiling function. Let's see what this is. Okay, so here's the ceiling function. It returns x rounded upwards to the nearest integer. So we'll go back and attempt this again and see all of those different test cases. So let's just grab one of them here. So 400, 390. And let's see what math.ceiling returns for that. Oh, and we have to divide it by 100. So let's do that again. So 4004, which is what we're trying to get at because we round this up to the nearest 100. Okay, so that's basically the answer then. Couldn't think of that on my own here today. So let's go ahead and try that. Instead of all this stuff, let's just return it. Math.ceiling is year over 100. And this may not get the cases where it's an even, or maybe it does. Let's attempt it. All right, there you go. So that's very clever, but I guess in this case, when I was trying to solve it here, I did not go through the scenario in my head where the years would be, greater than, say, 1720 or 1930. Like, I didn't think about what if we have like year 20,000, something like that. So in this case, it's a little bit of the instructions. Like, they didn't, say a whole lot about what the input was going to be. They didn't say that we're going to, go up to a huge input like they ended up doing. So that's partially the instructions, and then it's partially, I should have thought of all the edge cases and should have thought of the fact that the number could be greater than 4 digits like this. So we solved the problem with a specific set of input, but not all of the possible input. And that's very common when you're solving coding challenges. You always have to think of the edge cases. So while I didn't get this the first time, it's definitely a good learning opportunity just to see, how it is when you're trying to solve coding challenges. All right, for this one, we're converting cat years and dog years and human years. So we're only going to get whole numbers, and we're only going to get human years 1 or greater. Okay, so 15 cat years for the first year, 9 cat years for the second year, and 4 for each year after that. 15 dog years for the first year, 9 for the second, and 5 after that. So notice we have some similarities in the first two. They both go up by 15 and 9 in the first 2 years. Okay, so what are we getting here? What's the input? I have a cat and a dog. I got them at the same time as kitten and puppy. That was human years ago. So we're going to get a number passed in here. Return their respective ages now. Okay. So the easiest one is going to be human years plus, or no, we just say human years in there. So that should be the answer to the first part of the array. The second two are a little bit harder. So we have to get the dogs and the cats. All right, so the first thing that we want to do, let's see. Let's say human years is 1. Well, in that case, we're going to return 15 for both of them. So let's make a variable here. And then we'll say if human years equals 1, we want to return this right here. So we're going to say human years, and then we're going to say the cat's age is going to be what? 15, and the dog's age will be 15. If the human years are equal to 2, let's see, we're going to add 9 to that. So we're going to return something very similar, but this time we're going to return 24 here. All right, and then the remainder, we're going to say in the first 2 years we get to 24 for both the dog and the cat, but then they increment by different amounts. So how do we solve this? Okay, so let's say cat excess years is going to be equal to human years minus 2. Or we'll just say, we can just say excess years and use this for both. So we're basically trying to find, how many years above the first 2 years are we looking at here? And then from there, we can probably just multiply it by whatever this multiple is. So we'll say extra dog, or no, we'll start with cat. Extra cat years equals excess years times what, 4? And then for the dog years, we're going to do 5. So we're just going to make a new variable and say extra dog years. So then we just return at the bottom here, if we have not hit either of these logical statements, because if we return from here, everything's done. We don't reach any of the code below. But if we have not reached either of these code paths, we're going to reach this. And we're going to always return human years just as the number of years. But then we're going to say we know that we've got at least 2 years if we reach this code. So we'll say 24 plus the extra cat years. And then we'll say 24 plus extra dog years. Let's see if this gets it right. Awesome, we got it right. So that's how I would solve that problem. Let's see how other people would solve it. Okay, so this is interesting. It's a similar concept. We asked if it was the year 1 or year 2, and then we basically just did the same thing, just in less code. So I feel pretty good about that. We did pretty good on that one. So especially not being able to think. I've been going at this for a while now. All right, I think we have like 2 more in total. I'm gonna make it to the end. Our football team finished the championship. The result of each match looks like X:Y. Results of all the matches are recorded in the collection. All right, write a function that takes such collection and counts the points of our team in the championship. The rules for counting points. If X is greater than Y, 3 points. If X is less than Y, 0 points. If they're equal, 1 point. There are 10 matches total, and X is going to be between 0 and 4, or not between, it's going to be inclusive of 0 to 4, and then Y is going to be 0 to 4. Okay. So this games, let's just make this more specific. That's going to be a games array. We'll initialize by saying let total points equal 0, and we're going to set up a for loop. All right, so we're going to go through each, and we expect each value to equal something like this. So we'll just say value, and that's going to be games array with the index of I, which starts at 0. So just for reference, I'm going to say sample value in a comment, and this will be 3:1. All right, so the first thing I'm going to think about doing, since 3 and 1 are used for calculating this, I'm going to split them. So we're going to say parts are going to be equal to value dot split, and we're going to split it by a delimiter of a colon. So now let's console.log the parts of this array, and we're just going to see what that looks like. So these are the values that we're getting in each iteration of the for loop. So we're getting, 1 and 1, 2 and 2, 3 and 3, so on and so forth. And now what we're going to do is we're going to say all of these different scenarios. So we're going to say if parts 0, so the first one, if the first value, so X, so X and Y, so the first one is X, so if parts 0, which is going to be X, we might as well break this out into a descriptive variable. So there's your X and there's your Y, the first and second value of that array, and we're going to say if X is greater than Y, we're just following the rules over here basically. We're going to do something. And if X is, we'll say else if X equals Y, and then finally else, which is just basically going to be that last condition, which means X is less than Y. Okay, so let's just put it in there. We'll say total points equals total points plus, and in this case it's going to be 3. And then down here, let's just use a shortcut because we can. So we'll do plus equal. This is just an operator that does the same thing as here, except just in a shorter way. So we'll do plus equal, and then in this case it's a tie, so it's 1 point. And then otherwise it's 0 points. So in this case, we actually don't even need this last block because it's adding 0, which doesn't even matter. Let's return the total points here. All right, we passed it. Awesome. Not even going through the explanation there. I will assume that you're pausing the video to do that. Oh, that's an interesting solution right there. Not going to get into that though. Okay. At this point, I believe this is the last question. No, we finished it. Looks like we finished all of them. I don't know. I think we skipped this last one, the val count. No, we did that at the beginning. Anyways, if you enjoyed this video, give it a like. Subscribe to the channel. Please, I'm very tired right now from going through all of these challenges together with you. Be sure to follow me on Code Wars, and I'll follow you back. And stick around for the next video in this lesson series. See you later. Now, in the last couple of videos, we have talked about the basics of JavaScript, essentially. So we started with some variables, and we went through, functions and loops and operators, conditionals, all that good stuff. So at this point, we're ready to jump into some of the built-in functions and objects within JavaScript, which is going to save us a ton of time when we're actually writing our code, because it basically it's a bunch of shortcuts essentially, and also just kind of the basis of the JavaScript language. Here's what we're going to cover in this video and the next couple videos, but all encompassed within lesson 6 of the series. So we're going to learn how to read documentation. That's a really important thing as a developer. We're going to do a quick start, kind of an overview of callback functions. They're a little bit confusing, but we'll get through them. And then we'll talk about primitive values versus object values within JavaScript. We'll talk about dates, regular expressions, string methods, array methods, the math library, error types, and then a couple data types that we have not actually covered yet. That would be not a number, or NaN, and then also null and undefined values. So we've got a pretty big laundry list of things to cover in this lesson. It's going to take a little bit of time, but I promise you when we get to the end, you're going to have a much bigger overview of what the JavaScript language is all about. Now, the one thing that I'll say as we go into this lesson is this is probably going to be the last one where we're just focusing solely on JavaScript. We have to get through a lot of different things. So we have to cover HTML and CSS, and then a couple different other things before we're actually writing our web apps. So this will be the last kind of lesson that we're talking about JavaScript alone. Now, there are other things in JavaScript that we will not cover quite yet. So that would be like the async, await, and promises, and classes, object-oriented programming. It all kind of goes together. And those are some more advanced JavaScript topics that I'm going to pick up later down the road when we've actually written some sort of substantial web app. So hold tight on that. I'm not going to cover it yet, but we are going to get through the basics here, and then we'll start getting into actually building that web app of ours. The first thing that I want to do is actually go through how do we read documentation. And we can start at the Mozilla Web Docs, which is called MDN for short. And we've looked at this previously in the code challenges from the last lesson, lesson 5, but we didn't actually go into depth on how to read this documentation. And I think it's really important to do so. So you get to the homepage of the MDN Web Docs, you go to Technologies, and you'll find JavaScript. Now, JavaScript is documented in a variety of places. This just happens to be what most people consider the official JavaScript documentation. So once we're on the JavaScript homepage, you can see on the left you've got this navigation bar. There's some tutorials that you don't need to go to because this is a tutorial about JavaScript. But then what we're interested in is the references. So when we talk about references, that's generally going to be a big part of any sort of documentation that you're looking at. Generally with documentation, you're going to have some sort of quick start guide just to get you started with whatever library or framework that you're reading the documentation for. Then you're going to have some sort of tutorial usually. And then finally, you're going to have an API reference. Sometimes they just call it a reference like they do here. Sometimes they call it the API. Sometimes they call it the API reference. Whatever the case, it's all kind of centered around, okay, here's the core of this library or language or framework, and this is where you need to go to learn more about using it. So that's what we're interested in for JavaScript, and particularly right now, since this video is all about the built-in objects and functions, we can go to this built-in objects dropdown. And here you'll scroll down and you'll see a variety of different types of objects, and these objects have things called instance methods. It kind of gets into object-oriented programming, and I don't want to go there, but that's why I'm saying objects and functions. Now it's going to say objects here, but the functions are kind of what we call a method on top of these objects that you can call from the object. So you can scroll down and see a bunch of different ones. Most of these are going to be irrelevant to you as the complete beginner. And quite honestly, they're going to be irrelevant to you even as you get better. So the point of this video is to point out the most important ones, the ones that you're going to be, that you're going to need to get the most familiar with. And we'll go through them in more detail, but I just wanted to give you an overview of this. And then as you click through a specific object, so let's say we go to string, which as you'll learn in a little bit later in maybe the next video or something, a string is actually an object in JavaScript like everything else. So it's a little bit confusing, but you'll get the point in a little bit. Now, once we're on the string documentation page or reference, it's going to give you an overview of everything, and this is kind of the main home page for this string object. Now, in JavaScript, everything kind of behaves as an object, and it has these things called methods on it, which are the functions I'm talking about. When I say method, you can just think of it as a function that is, attached to that object. So as we scroll down here on the left, you're going to see this thing. It says string.prototype.whatever method we're talking about. Now the prototype part, that's a complexity of the JavaScript language that we have not covered and we will not cover in this series. That's a little bit above our pay grade, and we don't need to get into that to actually start writing the code. Once again, I've said this in previous lessons, if you want to understand the prototype chain and all of these complex things about JavaScript, of course, after you've kind of mastered the basics, you can go to the You Don't Know JavaScript series. It's completely free, so You Don't Know JavaScript, and it's actually hosted on GitHub. I think his name is Kyle Simpson. I would go to the first edition branch here, and then you can scroll down and just see all of the different books that he's written on JavaScript. It's a really good guide that's going to take you through the nuances of this language. Anyways, coming back to here, so we have the object at the beginning, .prototype, and then the method. So let's click on one of these methods and see how we actually read the spec or the reference for each method. I think a good one to start with, let's see, which one do we want? So we want to start with the pop method. This is a really easy one to get used to, and this is not part of the string spec, so we need to go to arrays actually. So let's go to JavaScript, and then we'll go to built-in objects and click array. Now, same thing, you have all these methods here, and we're going to go down here to the pop method. Now, when we get to the pop method reference, you're going to see a little summary and then an example. And this is the case for all of these different methods. usually you should be able to figure out or get the gist of what this does and how to use it from just this starting section. But it's really important to start developing the skill of learning how to read documentation, and oftentimes it can be a little bit confusing, especially since each language and site and framework and library, it depends on how they've written their documentation. It might look a little bit different. So anyways, the pop method removes the last element from an array and returns that element. This method changes the length of the array. All right, so we know it is mutating or changing the existing array that we're working on. Now, if we come down to the syntax section, this is what I want to focus on in this video, because if you are a more experienced developer, you should be able to kind of figure out all of the nuances of a specific method or function from this syntax section. Now, when we look at the pop method, it just gives us this basic little syntax, and you can see that there's nothing in this parenthesis, nothing that you pass in, and then when you come down to the return value, it says the return value is the removed element from the array, and then it says undefined if the array is empty. So it tells you here's what the normal return value is, and then if you by chance pass in an empty array, which you probably won't unless you're looping through it or something, then it returns undefined. So this is a really basic one, and just by looking at this, you can see how it works, and we can come over to our console. We can create some sort of array here. So we'll just put a couple numbers in here. Now, if we print the array, it's 1, 2, 3, and then array.pop. It's going to return the length of the array. So 3 is the length of the array. But now, if we print the array, we only have 2 elements in it because it removed the last one. Now, this is a really simple one, but the next one that we want to look at is going to be the join method. And that's because it's going to add in a little bit harder documentation for us to read. Now, before I do that though, let me go back to the pop method. So we got this overview section, the syntax. The description just gives you some more context around it, and then you have some examples. Now, as we get to the specifications, this is going to actually take you to the specific link within the ECMAScript spec. And we talked about that in, I think, lesson 2 when we talked about what is JavaScript. But this spec is going to, we might as well click it and just see where it takes us. So it should take us to the pop method, you can see up here. And this is the spec for, the JavaScript language. So just takes you there. It's not something that you'll be probably clicking on all that often. And then finally, you come down here to browser compatibility, and you'll see all of the different browsers, and then you'll also see a runtime over here. So Node.js is not a browser, but it's a runtime that runs JavaScript. So it shows you the compatibility for this method within all the different browsers. In this case, the pop method is one of the oldest array methods in JavaScript, so it's supported by all the browsers. But as you'll see with some other methods that we look at, it's not supported in all of the different browsers, and oftentimes it's Internet Explorer that doesn't support it. So not a big deal. All right, so anyways, let's go back to, let's see, not the pop method. We wanted the join method, which is going to be somewhere here. All right. So looking at the join method, this is going to be a little bit more complex. I'm going to kind of skip over this first section just to get an overview. It says it creates and returns a new string by concatenating or joining all of the elements in an array. All right, so that's the basics. Now coming down to the syntax where we're trying to focus on, you'll see that this code block here has a little bit more complex syntax going on. So it says array.join, and then in here we have this word called separator, and we have these little brackets around it. Now, what these brackets mean within the JavaScript or the MDN documentation, it means that they are optional. So the separator, this is just a description, like that word is arbitrary. So it says separator just to give you an idea of what type of parameter it takes as, I guess, an argument. So remember we talked about parameters and arguments, two sides of the same coin. Parameters are what we define when we declare a function. arguments or what we pass in to that function when we actually invoke it, call it, whatever you want to say there. So in this case, we have separator, and we can read more about this here. So the separator specifies a string to separate each pair of adjacent elements of the array. The separator is converted to a string if necessary. If omitted, the array elements are separated with a comma. If separator is an empty string, all the elements are joined without any characters in between them. So if you are following along with the 25 practice problems from the prior lesson, we used this method a couple of times, and we actually had to use that empty string to join all of the elements together with nothing between them. So this is where we would have found that. Now, of course, it's optional, so if you don't pass anything in there, it says if omitted, the array elements are separated by a comma. So it's optional. And then we come down to the return value, and it says a string with all array elements joined. If the array length is 0, an empty string is returned. So we can go ahead and test that too. So let's go into our console. We have an array here. Let's actually create a new one. So let me clear the screen, and we'll say string array, and then we'll say hello world. All right, so what if we wanted to combine those together? Now we'd use the join method, so we can say string array.join. Now as we see it right here, we omit all of the arguments. It just joins it with this little comma down here. Now if we go back and look at what else we can do, so if the separator is an empty string, it joins it without anything between them. So let's put in an empty string here. And you can see that it joins those together into one string with nothing between them. Now we can add a space here and press enter, and this is probably closest to what we would want if we were doing this. So that's just how you would read this. Now the last one I'm going to look at for reading documentation is a little bit trickier, and we're going to have to kind of use these concepts we just talked about to get through it. The example that we're going to do is the array.includes method. So let's click on that wherever it is. Now this includes method determines whether an array includes a certain value among its entries, returning true or false as appropriate. Now we're going to cover this a little bit later in this lesson, so I'm not going to go too deep into it, but let's go ahead and look at the documentation here. It says, this is the code block that we're looking at, and you'll notice that we have a value to find, and then we have the brackets here and the from index. So breaking this down from how we understand it, there are no brackets around the value to find, which tells us that that is a required parameter. You really can't run this method effectively without that required parameter. Now, it has this comma here, which basically means, okay, we're going to the next parameter that this function will take, and then it's surrounded by these brackets at the beginning and end, which means that the second parameter is going to be optional. Now, if we look down into the parameters description, value to find is the value that we're searching for, and it says it is case sensitive, so that's nice to know. And then the optional parameter is the from index, and it's basically saying you can start looking within this array at a certain index. So, if the value to find is earlier than that index you specify, it's not going to include it. So that's just how we would read the syntax of this, and again, we're going to go through this a little bit later in the lesson, so I'm not going to do an example right now. And just to point out what I was talking about earlier, if you scroll down, so includes is actually a little bit of a new method, I believe. I could be wrong on that, but I thought that it was offered only in the latest spec of JavaScript. So if you scroll down to the browser compatibility, you'll see that Internet Explorer has no support for this method. So if you're developing an application that has to run effectively in Internet Explorer, probably the only case that's going to happen is if you work for like a really large company and that company kind of has legacy systems and applications that still run in Internet Explorer. You don't want to be using this includes method because it might screw up your application. So that's just what I was talking about earlier. In the next part of this lesson 6 here, we're going to be talking about callback functions. When I first started, I was really confused about these, and I honestly think that it's just because I never stumbled upon a good explanation, something that really broke it out into the pieces that I could understand. So hopefully in this video, I can do that for you and prevent you from suffering from that confusion for several months like I did. Now, the reason we're talking about this is because the built-in functions that we'll see later in this lesson are going to use callbacks or callback functions heavily. And if you don't understand them, you're not going to be able to use those built-in methods. So with callback functions, they're not any different from the functions we were writing in the previous lesson. Use the same syntax, so you can use the regular function syntax. You can use anonymous functions or arrow functions. It's all the same. It's just a different way of using functions, and it's just a little bit different way of thinking in general. To start us off, I'm going to paste in some code that we're going to actually understand by the end of this little lesson. So this would be an example of using a callback function. Go ahead and pause the video just so that you can take a look at it and get yourself acquainted. So I'll press enter here, and you can also simplify that code that we just looked at into this right here. So it does the same exact thing. You can see the answer is the same. And I would just pause the video and just look at those two code blocks just for a few seconds to just get your mindset around what we're doing here. Now, the entire reason that I'm walking you through callbacks here is because oftentimes you're going to see code that looks like the second option here, which is simplified, yes, and it's how I would write it, but it definitely does not display the concepts that you're supposed to be understanding very well. So in this section, I'm going to be writing code that I normally would not write just because it's a little bit longer form and more broken out than I would write it, if I was developing an application. But hopefully, that longer form of the code is going to clear up some of these concepts for you and really help you understand what callbacks are all about. So let's take a look at each of these code blocks. Let me clear the screen and just get us the main code block, and I have some comments pasted in here. So let me clear the screen and we'll paste this in here, maybe space it out a little bit so that we have some room to work with. All right. And if we look at this code here, there's a couple things going on. The first thing is we have two different functions here. The main function right here, and then the callback function. So oftentimes you'll see the callback function kind of just embedded within that main function. But in this case, like I said, I'm breaking it out for clarity. So this main function, it takes 3 arguments. The first argument is going to be some number. I just called it random number. It's arbitrary. And then should call. So this is going to be a Boolean value, which is basically going to ask whether we should go into the callback. And then the callback itself. So walking through this code, let's first look at result. So the result variable is going to be set equal to the random number. Now, what is random number? Now, of course, random number is a parameter to this function, and therefore whatever we pass in as the argument to the function is going to be the value of random number. So if we go to the bottom where we actually invoke or call this main function, you'll see that the random number is going to be 20 right here. So in this case, random number equals 20, and therefore the result variable also equals 20 because we're assigning it. Now, if we come down to this next part, there's some comments here that's not affecting the code at all. We just have a simple if statement. So we say if should call. So if you remember, we can pass a Boolean value alone. We don't have to put any equal signs or anything. And we can place that within a conditional to evaluate it. So if should call is true, then we're going to reach the code within this, this conditional block. If it's false, then we just skip this conditional block and we return the result. So basically, if should call is false, then we're going to skip this and the result is currently equal to 20, and then we return the result. So the return of this main function is going to equal 20. But of course, it returns 40 as we see down here. So therefore, the should call is true as we see here in the invocation of the function. Now, the last part is the tricky part. That's the callback. Now, the first thing I want to point out here is that callback, this name that I've given it, is entirely arbitrary. You'll see this very often. You might see either this as callback, or you might see the letters C and B for callback. And that's probably a convention that you're going to come across, but it doesn't have to be that way. You can call that whatever you want. It's just a normal parameter, but in this case, instead of passing in a number or a Boolean like we did for the first two parameters, we're actually passing in another function. So basically what we're doing is we're passing in a function to another function, and we're asking that parent function to execute the function that we passed in. In this case, my callback is what we've passed in. You can see in the arguments down here at the bottom. So we've passed in my callback, which has just been declared, hasn't been executed yet. And so callback right here is going to equal the declaration of this function called my callback. So if you know how to run this, if we wanted to run my callback, all we have to do is put these parentheses at the end and pass in some sort of number. And you can see if we execute this, we get 40, which is the same answer. Of course, that would be the more direct way to do this, but this is a contrived example that's hopefully going to explain callbacks to you. All right, so we've got this value called callback, and that is equal to a function data type that has not been invoked yet, so just a declaration. And we can basically call this just like this, but in this case, the callback is actually the function that we want to call. So we're doing that, sorry about that, we're doing that in this line right here. So if should call, that is true, so we get down to this code right here, and what we're doing is we're taking that function that's been passed in, and we are executing it with the random number parameter, which happens to equal 20. So we're basically doing what we did down here, but within the main function, we're letting our code actually execute the function. So we're setting that equal to result, which returns 40, and then we're going to return result at the bottom. So that's going to return 40, and that's how we've gotten to our answer. Now, like I showed you with that second example a little bit ago, it's a little bit more abbreviated way to do this, and you do not have to write a separate function called myCallback in order to, basically run a callback function. So what we could have done, in the first case, this is how we executed main function. We passed in 20, we passed in true, and then we passed in a predefined function that we had already written up here. But we could abbreviate this, so let me collapse this main part. And what we can do is say main function, and we know that we have to pass in a random number. So in this case, we'll stay consistent and we'll pass in a value of 20. We want the callback to actually be called within the function, so we need to pass in true as the should call argument. And then we need to pass in the function. So in the first case, we just put in my callback and it worked. But we also could do it like this. So we could write a anonymous function, and this function is going to take a number. So that's just the parameter that we're defining. And we know that if we go up to the main function here, it's going to pass in this random number as the argument. So that's what number, or num, is going to represent. And then we have to break it down here, and then we have to return the num times 2, which is going to ultimately return us 40. And that's another way that we could write that callback. There's other simpler ways. So we can also do it like this. So let's do main function, pass in 20, true, and then in this case, let's just put in an arrow function. So we have num, and then we use our arrow function syntax, and then we return the num times 2, and once again we get 40. So just another way to pass that in. And we can even simplify this a little bit more. So we can pass in the same parameters. We don't actually need these parentheses here because it's a single argument. So we'll take num, and then we also don't need to break down onto the second line. We can actually just take num times 2, and that's going to return it the same way. And now we've gotten our answer of 40 once again. So as you can see, that's how we get from the most contrived, simple, elaborate example to the code that you're probably going to be seeing in a lot of examples. This is what a lot of people will use because it's just a much simpler, quicker way to write a callback function. So hopefully this section, I know it's a little bit confusing, but rewatch it again if you are not totally clear on this, because we're going to be going into the built-in functions that use these callbacks very heavily, and it's going to be important that you understand how they're working. So you might understand callbacks now, but why do we actually need them? They seem overly complicated, don't they? Well, the reason we need them is, in my opinion, this is just based on experience and just observation. The two things that it enables is reusability and asynchronous programming. Now, I'll talk about each of these. We're not going to go too much into asynchronous programming in this video for reasons I'm about to explain. But let's start with the reusability thing, and that is going to be crucial to really connecting the dots when we get into some of those more advanced array built-in methods that we're talking about later in the lesson. To really understand the reusability thing, we're going to look at a common array method that's called map. So we're going to look at this a little bit later in the video too, but I really want to show this as a lesson of why we need callback functions. So what this map method does, if we look at the documentation, is it creates a new array populated with the results of calling a provided function on every element in the calling array. So it's basically doing a transformation, and you're able to define the function that has all that logic to figure out what it's doing to each element in the array. Let's take a look at a very simple example. Now, this isn't going to make total sense, but it will kind of connect the dots from what we just did with that original callback example. So what I'm doing is constructing an array, very simple one at that, and then I'm going to define my custom map operation, and we'll just say callback. So we want to be very specific with what this function represents to us. And then the parameter is going to be the item from the array that we're mapping over. And what we're actually doing here is we're kind of iterating over the array. So when we get each element of the array, which is going to be passed in as an argument into this function, we want to return a value. And that value is going to be the transformed value that will kind of occupy the new array that we have. So we're going to take the item from array and we're going to multiply it by 2. So we're basically going to take this entire array up here, and for each element we're going to multiply it by 2. So we've got that function defined. So far it's not really doing anything, but if we take my array and then we need to set this equal to a new array, because the map method is going to actually return the modified array. It's not going to modify the original array. So we're going to take my array dot map. So we're just calling the function that's built into our array, and what it requires is going to be a callback function. And in this case, we've already defined that, so we're going to pass in my custom map operation callback, and then we're going to execute it. Now, if we look at the new array, you're going to see that every element has been doubled. And what it's done is it's looped through, it started at 2, then it's taken that value of 2, multiplied it by 2 to get 4, so on and so forth. So you can see how we've kind of iterated over the array and applied some sort of transformation defined by our callback function. Now, here is where we really understand this concept of reusability. So in this case, sure, it works, we're multiplying something by 2, but it doesn't really convey to us why this callback is so useful. Now, when the creators of the JavaScript programming language introduced this map array, what they wanted was to enable the developer to use this same method for a variety of use cases. So what if we had an array that was full of strings? So let me copy in a new array here. I need to name it something different. So we'll just say string array. And this is going to have a bunch of strings in it. And you might say, okay, well, I need to find a different built-in method to map over this and do some sort of transformation. Well, because we have a callback as one of the parameters of this predefined function, we have a lot of flexibility. And instead of looking for a new method, we can just redefine our custom map operation. Now in this case, I'm not going to do it longhand like we've been doing. I'm going to show you the shortcut. So we'll say, not my array, but the string array, which we just defined. We're going to call the map method on it, and then we're going to pass in a callback function. So let me template that out. I'm going to have an arrow function right here, and what I'm going to pass in is going to be the item from the array. So we'll just say item from array. We don't need any parentheses around that because it's a single argument. And now the transformation that we're trying to do, so if we do this on one line, whatever is right of this arrow is going to be returned from that function. So all we have to do is transform it in some different way. So maybe we wanted to construct just the first letter of each of these words. So maybe we wanted a new array that has the letter H, W, M, N, I, and Z. All we have to do is maybe return the item from the array, and actually what I'm going to do here is pass in, no, I don't need to. I'm just going to take item from array, and then I'm going to give it the 0 index, because you can access the first letter of any string by using the 0 index, second letter by 1, third by 2, so on and so forth. So you can see that we've returned the first letter of each of these elements in the array, and we did this for an array of strings by just redefining that callback function. So that's the value of these callback functions. It enables us to reuse the same function over and over again, so in this case the built-in map function, and kind of modify it for whatever needs that we have. And we can do something way more complex than just multiplying by 2. We can have conditional logic in here. We can say, you know, if the number is prime, then we want to multiply it by 2. If it's not prime, then we just want to return the number itself. You know, you can do all sorts of different things with this, as complex as you want it. All right, so I think you probably understand why callbacks enable reusability, why they're important, you know, how they work, all that kind of stuff. Now let's move on to the asynchronous topic. So I told you that callbacks enable asynchronous programming, and what that gets us into is a whole nother topic that I'm only going to briefly touch on here. So when I say asynchronous, all I'm talking about is code that does not run immediately. So with the code that we've run here on this screen, you'll probably notice that when we press enter, it executes immediately. It pretty much seems instantaneous to our human brain. Now, there are times when we're writing code that it might even take up to 2, 3, or 4 seconds for a piece of code to execute. And a good example of that is, let's say our application database that stores all of our data is, you know, in a different continent from where the user is actually clicking. So maybe I host my database here in the United States, but someone from, I don't know, Italy or something is visiting my web app and has to access the web app from their browser in Italy, and so it's going to send off a request to my server and then to the database, and that request to get all of the information for that web app and perform different functions is going to take a certain amount of time, and it's not instantaneous. So we have to handle that with our programming, and you might just say, well, okay, let's just wait until it's done and then execute the next line of code. Well, in that case, with a web app, you're going to have multiple asynchronous operations going at the same time. So you're going to have multiple calls to a web server that are going to take, you know, half a second, 1.5 seconds, maybe even a little bit more. And if you added all of those together and you just did it in order, your web app is going to take 30 seconds to load. And in that case, nobody's going to use it. So we have to run all of this code kind of at the same time. And for that reason, we have asynchronous programming, which basically allows us to run some code and then run other code while that previous code is still running. Now, I know this kind of gets into the topic of like threads, execution threads on a computer. It's not really what we're talking about here, and I really don't want to get into all of the details of this. But as we go through this series, we're going to be talking about asynchronous callbacks, promises, and the newer ES6 async and await. So these are all different ways that we can write asynchronous JavaScript code. You'll see how it comes into play a little bit later in the series. If you've been following along with this series, you might have heard me say that everything in JavaScript is an object, but I haven't really explained myself on that one. And since we're talking about all of the built-in objects within JavaScript in this lesson, I really want to give an overview of this concept of primitives versus the actual objects themselves. I'm going to put some code on the screen that will hopefully give you a little bit of an introduction and some things to think about here. So when we run this code, you can see that we've defined two different strings and we have compared these strings with each other. So in the first case, we've got this weird syntax here where we're actually using this thing called a new, it's actually the new operator we're going to talk about in a second. And then we are defining our string with this uppercase string, which looks like some sort of object or something. And if you go to the JavaScript docs, or documentation, so let's go to JavaScript built-in objects, and then you go down to string right here. That is the same syntax, the string, that we use to define this string right here. So string 1 is actually an object. Now string 2 is what we call a primitive. Now this is because we didn't, instantiate it with the object syntax, and you can see if we compare the equality of these two, the triple equals, which compares both value and type, is going to return false because in the first case we're looking at an object, in the second case we're looking at a string primitive. And if we use the double equals, they're of course true because they are the same value, they're just not the same type. So at this point you probably have a lot of confusion in your head. You're probably thinking a couple things. Well, you're telling me that string 1 is not actually a string, and the answer is yes, it is not a string, it is actually an object. And then furthermore, you're saying that this string down here, so string 2, that is a string, but how would we execute any of these built-in methods on something that's not an object? So there's a couple floating questions here, and to understand them, you have to know a little bit of the behind-the-scenes stuff that's going on with the JavaScript programming language. Let's start off by asking the question, what is a primitive? Now, a primitive, this is not a topic that is specific to JavaScript. We talk about primitive data types across varying languages. So, Python, Java, C++, they all have their primitives. But in JavaScript, a primitive, there are 6 different primitives that we can look at, and we can go to the documentation here for primitive, and it will maybe show us all of the different primitives that we have. So maybe it doesn't actually. I thought that it did. But anyways, the 6 that we have are a string, a number, a big int, Boolean, undefined, and symbol. Some of these we haven't talked about, but that's totally fine. We don't need to talk about it yet. But what you can think about when we're talking about primitives is that it is the simplest form of something. So if a coding language had a periodic table of elements, then the primitives would be those elements of the periodic table. So that's kind of how I would think about it, and those primitives can actually be used to build up other things. Now, as you would expect, a primitive data type does not have any sort of methods or functions that you can call on them. So it doesn't make any sense if we were to come here in the console and let's define a string here. So we've got some string, and now I'm going to put a dot at the end of it, just like I was calling a function or a method on an object. And if I were to take this some string and say to uppercase, so that is actually a built-in function on strings. So if you go down to the bottom here, you can see that to uppercase is a built-in method on the string object. But if we're saying that this is a string primitive, then it shouldn't be able to work, right? Well, wrong. It does work, and that is because behind the scenes, when we have a primitive value like this, where we define it with those little quotes or the double quotes even, it actually wraps it in that string object. So what we did up here, right here, this is actually happening behind the scenes when you call a specific built-in method on a primitive data type within JavaScript. Now, this is kind of interesting and all, but what do you actually do with it? Well, the answer to that is not really anything. This is more of something that you should be aware of. It's just good to know type of information so that you're not wondering in your head, well, what is going on here? You know, we're talking about strings, but if we go to the documentation, it sure looks like this is some sort of object here. So it just clears that up for us. And if you go to the string built-in object and scroll down a little bit, we have this section called string primitives and string objects, which kind of explains the same thing that I just talked about. So feel free to read that and really dig in if you want to understand this a little bit better. So the takeaway here is that you should not be using this syntax up here with the string constructor. This is not the way that you write strings. I taught you the correct way to write strings in the previous videos. This is just for clarification. Now, if you go to the actual documentation, you'll see in this section on string primitives and objects, down here it says, for these reasons, the code may break when it encounters string objects when it expects a primitive instead. So the documentation even recommends to not define them like this because JavaScript takes care of it for you. But anyways, that's just some information around here. Now, the next thing that I want to talk about is that keyword that we looked at, because this is also a little bit confusing. And as we go into the next couple sections of this lesson, it's going to be important to understand. And that is this new keyword, which is actually considered an operator, although we didn't talk about it when we covered operators in a previous lesson. In the next section of this lesson, we're going to be talking about JavaScript dates, which you actually have to use that new operator for to actually create. So if we wanted to create a date here, what we have to say is new, and then we pass in the date object with these parentheses at the end. And this is what we call constructing a instance of that date object. So you can kind of think of this in terms of like you have this template that you're working with. So the date object would be the template, and then you're going to actually take a copy of that template and store it in a new variable that has all of those attributes of the template. It does everything that that template has kind of predefined it to do. Now, this is kind of an object-oriented programming discussion. I don't want to get too far into it, but just know that this new operator is a special keyword in JavaScript, and that's what it's doing. So if you actually look into the new keyword, it's going to do a couple things. So it creates a blank object, and then it links that blank object to the parent. So when I talk about template and an instance of that template, that's what I'm kind of referring to. So there are additional steps that get into the prototype chain. Again, I'm not going to talk about that because it's another complexity that we don't need to visit right now. In the previous parts of this lesson, we've talked about a lot of the essential concepts that we're going to be using when we're talking about these built-in JavaScript objects. And the first one we're going to be talking about is JavaScript dates. Now, these JavaScript dates are a little bit confusing, and I'll be honest, I think a lot of developers, even more experienced ones, have a little bit of trouble with certain types of dates in JavaScript. And the reason is because writing JavaScript dates is not really all about coding skill. You also have to understand how time zones work and all of that stuff when you're actually getting into implementing the date objects and stuff like that. Now, I've written a post on this, so I'm on my site here, so I'll just scroll down. At some point here, I talked about JavaScript dates. So right here, and with this date post, I really go into detail about all of the different time zones and how we use dates and all of the different nuances of it. So I'd check that out if this is not enough detail for you. But here we're going to actually go into the basics of writing dates. And how we do that, I showed it briefly in the last part of this lesson. But all we have to do is define a variable and then assign a new date object, or kind of a copy of that template, which is date. And we're going to assign it. And now if we print out to the screen, it's going to show us a date object here, and it's going to be the current time because we passed in no parameters or no arguments to that date constructor. Now here's where dates get a little bit confusing. What we have defined here, the value that is stored within this date object actually represents the number of milliseconds that have elapsed since midnight on January 1st, 1970 UTC time zone. That's a lot to handle in one sentence here. And you might be asking, why January 1st, 1970? Well, the answer is not so simple. And again, I would read this post that I wrote to really get a background on that. But basically, it's an arbitrary date and time that we are basing all of our future dates off of. And what I mean when I say the value that we're storing within this date is equal to the number of milliseconds, because right here, it sure doesn't look like milliseconds that we're printing. But if you said now, which represents the date that we just defined, and then you say value of, it's going to print the number of milliseconds since January 1st, 1970, and that is in the coordinated universal time zone. So if you converted this to years and then days, you would get exactly to this. With dates, there are a variety of things that you can pass into that constructor as an argument to define a date. And what I'm going to do is just paste a bunch of code onto the screen because we don't need to go through writing all of it. You can pause the video, look through this for a second. I'm going to walk through it. But again, read that post if you want a ton of information about dates. So the first example, we're passing in the year, the month, the day, and then the time, or I guess hour, minute, second, millisecond, whatever. And we're passing that in as comma separated arguments to the date constructor. We can also pass in just a string in a variety of different formats, as you can see in this code right here. And then going down, we can input a number of milliseconds. So we can just give it the value itself, or we can pass it in as ISO 8601 format. Again, that post talks all about it. And then finally, you can do time zones down here. You can pass in time zones. This last part, the date.now, that's kind of an interesting thing that we can talk about here. So, we're used to creating a date by saying new date, but you can also create a date with a static method. That's what this is called here. And you just say date.now represents the same thing as new date. Obviously not anymore because time has elapsed, but it's just giving you the primitive value of that date. Now we're here in this video to talk about some of the instance methods that we can use on a date object, the built-in methods. So let's define a date. So that'll be equal to now, or maybe instead we'll just say my date, because now is sometimes not descriptive because the second you press enter, it's not now any longer. So that's a little bit confusing. So let's create a date here, and that's going to represent pretty much, right now minus a few seconds. And from this date, we can use a couple different methods. So one of them will be the toString method, and that's going to print what we've used here in the console, but of course this is a REPL, so it kind of read, evaluate, print, loop, all that kind of good stuff. So we can use this toString method to print out the string of the date, and this is actually going to print the value of that date, which is stored in the coordinated universal time, or UTC, and it's going to convert it to our local time zone, which is the time zone that our computer has stored on it. So that's actually stored in some file on our computer. I'm not going to go into that, but anyways, here we go for the next method. So we have my date, and then we can use the toISO string. So the ISO string is a specific format, and let's scroll down in my post here because we've got it up anyways. And I think I have a little screenshot of the UTC time, or not UTC, but ISO 8601. And let's expand this just a little bit. And you can see this is going to be the format that we're using for the ISO 8601 standard. Pause the video, look at this if you're curious. All right, so let's bring this back and, well, not clear the screen. And then my date, get date, is going to give us the actual day of the month. So today is the 16th of January, so we get 16. We can also use myDate.getMonth, which is a little bit unique because this is going to return the zero, or it's going to return the month of the year, but it's going to use zero indexing. So instead of January being equal to 1, January is equal to 0, which is what we're seeing here since this is being filmed in January. So we'll go to myDate.getFullYear, and that's going to return 2021. So those are some of the basic methods that you can use on a JavaScript date. And honestly, these are probably the most common ones. You won't be looking at anything else for the most part, but you can go to the docs JavaScript documentation. So again, JavaScript, built-in objects, then you can go down to date, and then you can see all of the different methods that we're using here. Something to point out, you'll see this a couple times within the documentation. If you look at the date.getYear method, it has this little thumbs down icon, which basically means that it's deprecated. And a deprecated method is something that is no longer going to be supported, so you don't want to use those. Now, if you click on the getYear method, you'll notice that in our example, we used the getFullYear method, and the reason is because it says the getYear method returns the year in the specified date, blah, 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 and it says it is no longer used and has been replaced by the getFullYear method. So that's how I knew to go to that getFullYear method as a replacement. So in the previous section, we talked about JavaScript dates, and now we're talking about the built-in object called regular expression. And this is not just a built-in JavaScript object. This is an entire topic. Like, I almost think of this as another language that you're kind of trying to learn in programming. It's obviously not Turing complete or anything, but regular expressions are basically a way to pattern match within strings. And you might be asking, well, why would we want to do that? And to show you why, let me just open up a web application. We'll just go to You Need a Budget, and this is a budgeting app that I use and really like. But if you go to the login page, log in right here, and you type in your email address, but you type it in incorrectly, it's going to say, please enter a valid email address. And you might be asking, well, how does it know what is an invalid email address? You may go through a bunch of different types of emails, like a big long list of emails. That's probably not going to be efficient, of course. But what we can do is we can use regular expressions to pattern match and basically say, okay, I expect to see these certain characters and then an @ symbol, because every email address has an @ symbol, and then some sort of valid domain or whatever for that email address. So we can pattern match, and that's why regular expressions are so powerful. You can validate emails, and you can also do a whole host of other things. It's great for validation, but it's not only for validation. Now, as we're going through this, just keep this in mind. This is a very loaded topic, as I said, and you don't need to fully understand how to write these regular expressions. It's really not a high priority thing for you right now if you're trying to learn how to code, because you can get away without regular expressions while writing web apps. They're just very nice to have. They can really speed up your workflow down the road, and you need to be at least exposed to them. So all I ask here in this video is you understand what they are, what they do, and just how to read them in general, just kind of understanding the symbols and be able to piece together what a regular expression is doing. I wouldn't worry about learning and mastering how to write them. So if we go to the JavaScript documentation, let's see here, we'll go to Technologies, JavaScript, as we've been doing. I'm just kind of reiterating this. Then you go to built-in objects, and then we can go down to the regular expression object, which is going to be regexp. And it says it's an object used for matching text with a pattern. So as I said, pattern matching. Now let's go ahead and write a basic regular expression. I'll show you how to do this here. So we'll say email validator regular expression, and this will be kind of similar to what we just looked at, where it's validating whether the email address is correct. Now, this implementation that I'm about to write is by no means exhaustive, and it's definitely going to miss a couple cases. And I guarantee you, YNAB or you need a budget is using a much more complex expression than the one that I'm about to show you here. So, anyways, let's go through this and just get an idea of what we're dealing with. So let's say that our user input, this is what we type into the form. So, I go here, I type into the form, I type something. That's what this user input variable is going to represent. And I might put in something like invalid email at G. And obviously this is not a valid email, so we should reject this by using this regular expression. So we'll say a new variable, we'll say it's is valid, and then what we have to do is we take our email validator regular expression from up here, and we can use one of the built-in methods on it. So if you come down to the left, you can see all of the different built-in methods, and one of these, if we go down to methods, are we even on the right one here? Okay, we're on regular expression. Okay, I was just missing it completely. So here are the methods. These are pretty confusing to look at, but the two that we're looking at here is going to be exec and test. So we can use test to just see if something is valid. So we're going to go ahead and do that. We're going to use the test, and then we're going to pass in our user input. So we're saying take this regular expression, or this pattern that we've defined, and map it up against this string that we have defined. And if you press enter, it's going to, and then show what the value is, it's going to be false because this is an invalid email and that expression up there, that regular expression, did not match it. Now, if we look at this regular expression, there's all these characters which probably look like complete gibberish to you, but I'll quickly walk you through what this is doing, and then we'll go back to the basics and really understand it. So this first character just says, I want to start at the beginning of the line. This period represents all characters, and then this plus sign that comes directly after the period says I want to match any character one or more times. Then we have the @ symbol, which is just looking for the @ symbol, and then we have this period again, so we want any character one or more times, and then we use this slash to basically escape and actually look for a period. So if you have gmail.com, we need that period, and in order for this special character to be escaped, we have to use this backslash right here, and then we use another period for any characters one or more times, and finally the end of the line with the $sign. So I know that's super confusing. I would never expect you to follow along with what I just said, but just to give you a taste of what we're dealing with here. All right, so let's go kind of to the very basics here. With regular expressions, I like to think of it in two pieces. So you have the identifiers, and then you have the quantifiers. And the identifiers can be one of a ton of different things. It can be special characters or just the characters or phrases that you're trying to match. These identifiers are what you're actually trying to pattern match within the string. So if we created a regular expression, we'll say new regular expression, and then we're going to pass in the letter G. And now I'm going to pass in a couple of strings here. So we'll say string 1 and string 2. And you'll see that if we're trying to match the letter G, it only occurs in the second string right here. So if we were to say the regular expression dot test and then pass in string 1, we're going to get false. But if we test it against string 2, it's going to give us a value of true because it did in fact match the G in the middle of the string. But in this case, our regular expression is just taking a single character and looking for it, which is probably not what you're going to be doing. You're probably going to get a little bit more complex than that. So maybe you test for an entire word. So let's type another one. So we'll say regex, or regex2. Some people would say regex, some regex, regular expressions, whatever. But anyways, we're going to say this one is going to be equal to an entire word. So in both strings, we have the word favorite. So now if we test the second regular expression up against both of the strings, it's going to return true. So no matter which string we put in there, it's going to return true there, as you can see. So we can also match a full word in addition to just a single character. But the interesting thing about regular expressions, or I guess maybe not interesting, but important thing, is that it's case sensitive. So if I were to make another regular expression, let me go ahead and just clear the screen for a second so we get some more room. And let's say our regular expression is going to be equal to favorite with capital letters at the beginning and the end. And we of course need to bring in our strings again because we refreshed the page. But this time, if we map up the regular expression and test it against string 1, we're going to get false because there are no capital, there's no word in there called favorite that has a capital F and a capital E. So you'll see string 2 also returns false. So this is case sensitive. You have to pay attention to the uppercase and lowercase letters. Now, you don't have to just use single letters or single words or phrases. You can use special characters, and that's really where the power of a regular expression comes in. So there are a multitude of special characters that we can use, but I'm going to put on the screen a couple of the really popular or common ones. So the first one is going to be anything that we put into brackets. And another thing that I want to share here is that you don't have to write a regular expression like we did up here. This is one way to do it, just like we saw with the strings. You can modify or create a string in two different ways. Now, the more common way that we're going to be creating a regular expression is you put 2 forward slashes and then you put in your regular expression here. So in this case, I could put in G, and that's going to be our regular expression that we wrote first. We could also put in favorite, and that's going to be a regular expression. And as we saw, you can actually execute methods on, a literal like this. So we can test string 1 against this. But if we go back and lowercase these letters, now it's going to return true. So this will be good for me to show this syntax so we can quickly loop through a bunch of different patterns here. So we're just going to change the regular expression here and we're comparing it against string 1. The first thing you can do in a regular expression is a character group. And all you do is have these 2 brackets, and then whatever you define in that character group is going to apply to the regular expression. So what we could say is A to Z, uppercase. And what that is doing is matching all uppercase letters. Now in our string 1, there are no uppercase letters, so we return false because it doesn't match. But we can also pass in A to Z, where we have all lowercase letters, which obviously does match at least one of these letters. Moving on, we can also have 0 through 9, which is going to match all numbers within a string. Now there's no numbers here, so it's not going to match, returns false. And then you can combine these together. So you can match all uppercase letters, all lowercase letters, all numbers, and then you could even match spaces in here. So if we added a space here, we could match spaces. And this is going to return true because we're matching the spaces, the lowercase letters, so on and so forth. So that's what we're using with these brackets. You have a lot of different options within those brackets. Now, we talked about earlier that this period, when used in the context of a regular expression, represents any character whatsoever. Now, this is going to return true because it represents any character. Now, the next one we'll look at is \D, and this is going to match all numbers. This is equivalent to saying brackets 0 through 9. So it's completely equivalent, just a different way to write it. In this case, there's no numbers, so it returns false. We also have \S, which will match any white space characters. There's spaces between the words in these strings, so it does match. Then we also have \W, which matches all letters and numbers, so alphanumeric. So these are just some shortcuts that you can use. As I said when I was interpreting that email validator, this little caret represents the beginning of a string. So if we put in the caret and then we put in an F, it's going to return false because the first letter of the string we're testing it against, so string 1 is actually M. Now if we put in M, it's going to return true. But we could put in the F, returns false because we're starting at the beginning of the line, but if we take that out, it then returns true because we're no longer constrained to the beginning of the line. Now what we could do also is the end of the line, which is a $sign. So F is not the last letter of this string, it's actually K, so that's how we would make that return true. And then finally we have these little groups that we can make. So if you put parentheses here, and then you can say, you could say code or steak or something like that. And that's going to match either code, the word code, or the word steak. And in this case, we're looking at string 1. Steak is in there, so it's going to match. So those are just some of the different ways that we can write the identifiers, and you can see how flexible this is and how creative you can get to match different patterns within a string or like a line of text. Now the next thing, and the second piece of this equation, is going to be quantifiers. Now so far we have been using this test method to basically show whether or not we have matched a certain character in the string. But if we, let's rewrite this here. So let's say that we want to match all lowercase letters, which returns true. That's all that's telling us is that in string 1, we have at least one lowercase character. Now, if we come over here and change this test method to exec, it's going to do a little bit different operation. And you can read about this here in exec. It shows you kind of what it returns, the different values of this array that it returns. But basically what this is telling us here is that all that it matched when we wrote this regular expression is the letter M. Because it started at the beginning of the string, it matched that one lowercase character and it said, okay, that's all I need to match. Now, if we want to match more than just one character, we want to match a section of a string, then we have to actually tell it that. And the way we do that is through quantifiers. So there are a couple different quantifiers, and I'll try to roll through all of them and explain all of them just really quickly, as this, again, is just an overview. So the first one is a star. And the way that this works is you put your identifier at the beginning, and then you follow that by a star or another quantifier that you're trying to use. And so what this is saying is that I'm trying to match any lowercase letter, and the star is saying I want to match any lowercase letter 0 or more times. So in this case, it's, since we're matching 0 or more of the preceding character, it's pretty much going to return something every time. Now we can change this to a plus sign, which is going to match one or more of the preceding character. And then we can put a question mark to represent either 0 or 1 quantity of that previous character. And in this case, you see that the matched value is going to be only the first letter because we're looking for 0 or 1. Now we can be explicit about this. So we can say we want to match a certain amount of characters, but before we do that, I want to add a little space within this identifier, because right now we're only matching this first word here. So if we add a space in here, now it's going to start matching the entire sentence or string. So if we put in the plus sign, you can see my favorite food is steak, so it matches the entire string because they're all lowercase letters. Now if we wanted to be specific, we wanted to match a certain amount, all we'd have to do is these little brackets as a quantifier, and then we can pass in a specific number. So let's say that we wanted to match, say, 5 characters. Well, it's going to get the first 5 characters, so my space, that counts, fa, and that's going to match the first 5 characters. Now, we can also do a range. So we can say we want to match between 2 and 6 of the preceding character that we're looking at. So it's just going to match 6 because that's the upper bound, but you can match like a range of characters. So these are all the different quantifiers, and you can use these to take the pattern that you're matching and tell it how much of that pattern you want to match. Now, before we go into kind of a final example to just tie all the concepts together, I want to show you one other thing, and that is going to be in the documentation. There is this thing called a flag. So if you define a regular expression, so we'll say our regex is going to be equal to, a new regular expression, but we could also write it with these 2 slashes. You can also pass in a flag, and that goes at the end of these 2 slashes. And here are all the possible flags. In this case, we might want to do a global search, so it will search for the pattern even if it occurs multiple times. And if you wanted to use that, all you would have to do is write your regular expression here. So we might say we want to match all lowercase letters 1 or more times, and then at the end we put a G, which represents that flag. So that's just a slight nuance to this, and you'll see this, so just be able to recognize it. Anyways, let's move into a basic example where we can just apply those concepts of the identifiers and then the quantifiers, and then we'll wrap it up for this section on regular expressions. So we're going to write first a string. So here's the string that we're going to want to match. So we'll say hello world, and then let's put in a couple numbers, 2021, and then let's put in a couple spaces here, and we'll put in, I don't know, we'll put an @ symbol in here as well, and then more of a string at the end. And our goal is to basically write a regular expression that is going to match this entire string. So we can do it in a multitude of ways, but I'll just go with the most obvious ways that I can think of. So we'll write our regular expression, and we're going to use this syntax here. So the first thing that we'll notice is that we have some lowercase letters to start. So we can use the brackets here. So this is, again, not the most simple way to do this, but this will hit home all these concepts for you. So we'll say that we want to match lowercase letters and spaces. So let's add in that space right there. And we want to match that 1 or more times. And then actually I'm going to do this in real time so that we can see what's happening. So instead of putting it in a variable, we'll do it how we did it before. So we're going to look at all lowercase letters and then add a space, and then I'm going to execute that against the string so we can kind of begin to see what we're matching here. So we're looking for all lowercase letters 1 or more times. So we got the hello world. Then we're looking for a comma. We can just put the comma in as it is. Then we're looking for some spaces and numbers. So why don't we pass in 0 to 9 and then another space, and we want to match that 1 or more times. And then we want to match the @ symbol, and then we want to match lowercase letters. So again, A to Z, and then we need a space in there, and then we say 1 or more times. And then for good measure, this is not necessary, but we can just put this little upwards caret to indicate the beginning of the string and a $sign to indicate the end of the string. You can see here that we have matched this entire string. Now, of course, we can do this a lot simpler. All we need to do is put a period in there and a +sign, which matches any character 1 or more times, and there we match the whole string. But hopefully this was just a brief overview, a very basic explanation of regular expressions. It's a built-in object within JavaScript, like we talked about, that you're going to stumble upon, and eventually it may come in handy for you, but most importantly, just have an understanding of what they are, what they do, and how to read them. So we've covered a lot in this lesson, but we're finally making it to the string built-in object in JavaScript. So again, let's come to the beginning. So technologies, JavaScript, built-in objects, and then you go down to string right here. So we kind of talked about the string object versus primitives, got an overview of this, but what we didn't do is talk about some of the methods that we can use on this string. And what I want to do, as I've been doing in this lesson all along, is basically give you the most important methods, the ones that I've used a lot myself, that other developers use commonly, and just give you a brief overview of them so that they're kind of in your memory bank and you have them for recall later when you have to use them in your code, or maybe some code challenges or interviews or whatever. So we're looking at strings, and you can see there are a lot of different string methods that we can use. And again, this little downwards thumb means that it's a deprecated method, so don't go trying to use any of those. But again, there's a lot of them here, and I want to point out some of the most important ones. So what we're going to be looking at, let's go ahead and refresh this. Oh, I don't know what I've done here. Okay, there we go. We'll clear the screen. And what we're going to be looking at is the replace all method. We're going to look at the toUpperCase method, the substring method, the trim method, and the match method. So that's what we're going to be covering here. And again, just basic examples of each. As we go through these, I'm going to show you the documentation first, because I really want you to get used to reading it and understanding how it's working. So let's go to the replace all method. It says this method returns a new string with all matches of a pattern replaced by replacement. The pattern can be a string or a regular expression, so we just learned about that. And the replacement can be a string or a function to be called for each match. Now, we're not going to get into that function piece. That's a little bit complicated, but if we look at the syntax here, you'll see some new symbols here. So this little pipe means that there are multiple types of parameters that you can pass in, or not multiple types of parameters, because obviously there are multiple parameters, but for this single parameter, there's multiple types of data that you can pass in. So in this case, it's saying either a regular expression or just a string to match. And then the second parameter, so we have the comma here to say, okay, we're on a new parameter, a new substring, so just a regular string, or a function that will return basically whatever we want to replace it with. So come down here to the parameters. You can read a little bit more about that, but we don't need to, because I'm going to show you how to use it. So let's go ahead and define a string really quickly. So we'll say my dog jumped on the bed. My dog is a bad dog. All right, and you'll notice that I have some weird capitalization in here, which is going to be what we're replacing. So we want to say we want a new string, and then for the string we want to replace all. So this is different from the replace method, because obviously we're replacing all occurrences of the match rather than just the first. And that's why I use this one more frequently, because in most cases I want to replace all rather than just the first match. So in this case, we could just say we want to replace the word dog with cat, and that's going to assign the new string to our variable, and you're going to see my cat jumped on the bed, my dog is a bad cat, which obviously makes no sense whatsoever because we missed one, and that's because this is case sensitive. But what we can do is write a regular expression, and we just learned about that, so we might as well do it. All right, so we're going to say correct string equals my string dot replace all, and then in this case we're going to pass in a regular expression, and then we're going to replace that with lowercase cat. So all occurrences of the word dog, uppercase and lowercase, are going to be replaced with this right here. So in this regular expression, we're going to put a character group, and we're going to say we want either an uppercase D or a lowercase d, and then we want to match exactly, so we're going to put these little brackets and put a 1 in there. So we're going to match exactly one of these characters, either uppercase or lowercase, and then we're just going to pass in OG, because it's always going to end in OG in the lowercase form. So then we're going to finally pass in, let's see, we need to pass in the global flag, because we want to replace or find all instances of that. So let's go ahead and press enter and see what we got. So the correct string, it looks like we have cat in all of these instances, so we replaced it correctly. Again, this G at the end is just the global flag, and there's a bunch of different flags that you can bring into a regular expression, but this just means match all occurrences, not just the first. The next method we're looking at is the toUpperCase method. This is a pretty easy one. Let's go to the documentation and take a look. It says toUpperCase returns the calling string value converted to uppercase, and the value will be converted to a string if it isn't one. All right, so very simple function here, and we can pretty much figure out what it does by just experimenting around. So we'll say that we want my string to be equal to some string, and then all we do, it's saying I redeclared my string, so I need to refresh the browser because I already did that. So my string equals some string, and then we say my string dot toUpperCase, and you'll see that it capitalizes every single character within that string. So it's very straightforward. You'll see where this comes in handy in just a second. So the next one we're looking at is the substring method. I use this quite a bit. If we go to the documentation, you're going to see that there are actually two methods, and if you have been following along with this tutorial, in the prior video, the 25 challenges, I actually used the wrong method here. So you can see that we have the two methods. We have the substring, and then we have substr. And this substr has the little downwards thumb, which means don't use it, it's deprecated. And of course I used it in the previous video, so apologize for that. But we're going to be using the non-deprecated method, and it says it returns the part of the string between the start and end indices. So if we go down to the function signature, you can see that there's one required parameter. It's not surrounded by those brackets, and then one optional parameter, and these represent the index of the first character that we want to include in the return string, and then the last character if we want that. Otherwise it's just going to take everything after that first character. So let's go ahead and give this a try. We'll use the same string here, so we'll say my string dot substring, and let's say that we want to get everything starting at, I don't know, the letter M. So if you think about this, the S has an index of 0, the O has an index of 1, M will be 2, E 3, the space will be 4, and the second S will be 5. So maybe we'll start it at 5 so we just get the second word. And then if we don't pass in a second parameter, it just goes to the end of the string, which is kind of what we want. But you could also pass in something like 7 and it kind of cuts it off there. So that's kind of how the substring method works. Now I want to provide you with some common ways that we might use all these methods, and one of the common ways that I've found to use the substring method is if you want to maybe capitalize the first word of a sentence. So let's say that we wanted to take my string, which is some string with all lowercase, and we just wanted to capitalize this S and combine that into the full string. So basically what we're looking for is this right here. Now if we wanted to convert that, here's what we would do. We would say, let's just assign it to a result variable. So we will say my string, and then we want to grab the first letter of the entire string, which is going to be that S. Now we're going to use that toUpperCase method that we saw in the previous method right there. And what that's going to do is it's going to grab that S and then it's going to capitalize it. So all we're getting right now is a single letter. So we can use the plus sign, we can concatenate two strings together. So now we have to get the remainder of the string right here. And the way that we do that is using the substring method. So we'll say my string, and then we want to use the substring method, and we want to start at an index of 1 because we've already got the first, the 0th index of S. So we want to start the substring at 1. All right, and then we can go to the end of the string. So all we would have to do is basically just leave it like that and we're done. But if you, I don't know, maybe have a good reason to do this, you could also grab myString.length to get the very last character in the string as our bounds of that substring. So if you press enter and then you type out result, you can see that we have capitalized this string or sentence if it was longer. So that's just a common use case of the substring method combined with the toUpperCase method. And you can start to see how when we combine them together, it makes our job a lot easier. The next method we're talking about is the trim method. And this may not seem all that useful when we first start looking at it, but I will show you why we might use this in the real world. So the trim method removes white space from both ends of a string. Notice it says both ends. It doesn't remove white space from in the middle of the string. White space in this context is all white space characters, space tab, no break space, etc. And all the line terminator characters, so a carriage return here, but we don't need to worry about that. And the call signature, the function signature, is very simple. You just call it on the string and it removes the white space. So again, you might say, well, this is not very useful, but what if we got some external data that looked like this? So this might be some data that you retrieved from an external database or something, and you have no control over how you receive it. And in this case, we have some spaces in these strings. So how would we go about removing those and returning an object that has kind of a cleaned up piece of data? Well, we can do that using a loop and the trim method. So let's just write a loop, a for loop. So we did this a lot in the challenges, the code challenges from the last lesson, and then we also learned it in the last lesson. So you should be familiar with this. So we're going to write the loop, I++. Now we're going to loop through each piece of data, and what I'm going to do is actually break this out. So I'm going to say the current title is going to be equal to external data. Then we're going to grab the index that we're on, .title, and then we're going to go down and we're going to grab the current author equals external data I.author. Now we're coming down here, and this is where we're going to reassign the values of these properties to the trimmed version of them. So we're just going to say the external data I.title is going to be equal to the current title.trim. So it's going to trim the white space and assign it back to that property. And then we'll do the same thing for the author, so external data.author equals the current author that we're iterating over .trim. And there's our for loop. So if we print out external data and we look at the array here, you're going to see that all of these values have been trimmed of the white space. So that's just a way that I've used it in the past, something that has come in handy for me, so I just wanted to show you that method for that reason. Now the final method that we're going to look at, the built-in method on a string object, is the match method. Now this is going to be very familiar to you because we learned about regular expressions already. So I'm going to actually bring in something that we've already looked at here. So let's write a regular expression, and we'll just say we want to match any lowercase characters in a quantity of 1 or more. And that's going to be our regular expression. And then our string is going to just be a bunch of gibberish. Let's write this correctly. Bunch of gibberish, and then maybe some numbers in here, and then some more gibberish letters. All right, so there's our string. And there are actually two ways that we can test this. The first way is something we've already seen, where we just run the exec method on the string. And of course, since we're matching lowercase letters in a quantity of 1 or more, it's going to grab all of these until it gets to the numbers, and then it no longer matches. So that's one way we could do it. But we can also do it in reverse. Like, it does the same exact thing, except we're doing it from the string method. So all we have to do is say string.match, and then we pass in the regular expression, and it's going to show us kind of the same thing. Now, this is going to be exactly the same as long as you are not using the global flag. So if we were to put in let's say, if we defined the regular expression and we put in A to Z, one or more, and then we put this global flag in there, that would be when these two methods do not behave identical. But for our intents and purposes, you can use either one. It really doesn't matter. Just pick one and go with it. To this point in this lesson, we've talked about dates, regular expressions, and built-in string methods, but we haven't talked about arrays, and this is where it gets really fun. Now, I will say that this list of methods that we're going to be going through, you can actually see them on the screen, all of these different methods here. So we have the push, pop, shift, and unshift. Those are kind of grouped together. We have slice, splice. These are actually different. We have find index and index of. They're kind of grouped together. Map, for each, includes, filter, and reduce. And I chose these because these are the ones that you're going to be using most of the time. And these represent kind of the bulk, if we can kind of go with that whole 80-20 rule. This is the 80-20 rule of array methods. And it's obviously not exhaustive, and I'm not going to go into every last detail of each method, but I hope that this can basically walk you through the basics of each so that when you have to use them, it's not a complete shock. You kind of know what's available to you, which is kind of half the battle sometimes. Just remember, these are not to memorize. Don't try to memorize these. Like any built-in method, you can always look them up, and as I've been going through in this video, you know how to read the documentation now, and I'll continue doing that for each of these array methods so that you can just get better and better at acquainting yourself with the different syntax of this documentation. So let's get started. We'll start with the push, pop, shift, and unshift methods. And we're not going to really go through all of these in the documentation because they're so similar. But let's go to JavaScript again, built-in objects, and we're going to the array object, which has instance methods that we're going to be looking at here. All right, so we will start with pop. We've actually already looked at this when we talked about reading documentation. This is going to remove the last element from an array. Now, we also have shift right here. This is going to remove the first element of the array. Then you have the method that we're going to be using the most out of all of these, which is the push method. This just takes an element and or more than one element and adds it to the end of the existing array. And then finally, the unshift method down here somewhere. This is going to add an element or elements at the beginning of the array. Again, I think the push method is probably going to be the most widely used, but let's just go ahead and see what we're dealing with here. So we'll make an array, we'll add 3 elements in there, and maybe let's go ahead and put a gap in there. So we'll skip 4 and we'll put in 5 and 6 or something like that. All right, so there's our array. So what if we wanted to basically add the 4 in there? So basically all we have to do is array.pop. That's going to take off the 6, and it returns 6 not because the value is 6, but because there are 6 elements, or maybe it did. It does return the element that it removed from the array. I'm sorry about that. All right. Anyways, we will go and do that again because we need to remove one more. So now our array looks like this. We just have 1, 2, 3, and now we can push 4, 5, and 6 to the end. And we are back to what we started with, but this time it has all of the numbers in order. So, of course, we can add the 0 at the beginning, so we just say array.unshift, put a 0 in there, and now our array has 0 through 6. So you can kind of get an idea of how this works, and there's not a whole lot to it. All right, let's move on to the slice method. Now, this one is going to come in handy when you need to make a copy of an array. And this is not going to be apparent why this is useful right now, but once you start getting into front-end programming where you're writing code in either Angular or React or Vue.js or something like that, there's this concept that we call state, which basically it's how the data flows through the front end of your application. And when a user updates their profile or whatever, and that data update affects another part of the application, the state is what makes those changes propagated across the entire application. And when we're dealing with state, we often are dealing with immutable objects, things that cannot be changed. So making a copy of the data that you're putting into state is going to be extremely useful. And to do that, you can use this slice method. So let's look at it in the documentation. We'll go to slice. It says it returns a shallow copy of a portion of an array. When it says shallow here, that just means that you have, like, if you have nested objects or arrays, it's not going to pick up on those. It only gets like the first layer or whatever. You'll need a more advanced method to do like a deep copy of an object, and I'll talk about that a little bit later in this lesson. So basically what it's doing is it's taking two optional parameters. So if we don't supply any sort of parameters at all, then it's just going to, let's see what it says. So if we don't put any parameters at all, it's just going to create a copy of the entire thing. Otherwise, it will create a copy of a specific part of an array. So let's see how this works. We have an array already right here, but let's say that we wanted to take out 2, 3, and 4 or something like that. So we've already got an array on the screen, and let's say that we wanted to make a copy of the entire thing. So we can say copy of the array is going to be array.slice. We don't need to pass in any parameters because we just want the entire thing. And now the copy of the array is going to be a perfect copy. Now, if you were to compare these, so copy of the array versus the array, they're not going to be equal. So I say that loosely, but that is a concept that we talked about when we looked at the JavaScript operators in a previous lesson. All right, so if we wanted to grab like a specific part of this array, so another copy, and we want to grab everything starting at 3 till the end of the array, you might say slice, and then you want to give it an index of not 0, not 1, not 2, but you want to start at 3, so you want to give it an index of 3. And now another copy is going to be equal to 3, 4, 5, 6. So that's just a quick overview of the slice method. The next method that we're dealing with is called splice, and it is not to be confused with slice. So if we go to the documentation, click on splice, it will say that this method changes the contents of an array by removing or replacing existing elements and or adding new elements in place. So in other words, this is useful if unshift and push, those two methods we learned about, are not sufficient. You want to actually replace something in the middle of the array rather than just the beginning or the end. Now I want to look at the function signature on this one because it's kind of interesting. So there's a lot going on, but the only required parameter is the start, which is the index at which you want to start changing the array. Then the comma here, it says we're going to a new parameter. We want the delete count. So it's basically saying we want to start at a specific index, and now we need to specify how many items of that array are we going to delete starting at that index. Now, if we don't provide this because it is entirely optional, it says if this is omitted or if its value is equal to or larger than the array.length minus the start, we don't need to get into that, then all the elements from start to the end of the array will be deleted. So let's say that we specified the start as index of 1, then it's going to basically delete everything except for that first element. So the next part that we have are these interesting brackets where we just have item 1, item 2, and then the ... This is basically saying that you can have an infinite number of parameters that you can replace, and it looks like if we come down here to item 1, 2, ... it says the elements to add to the array beginning from start. If you do not specify any elements, splice will only remove elements from the array. So this kind of changes the behavior of the entire method. We go from removing elements to adding elements to the array. So you can see how reading the documentation can be very helpful. In our case, we're just going to go through a basic example. So we'll say that our array is going to be equal to 1, 2, 3, and then we'll put in some string that doesn't belong there, 4, 5, 6. All right, so what if we wanted to, well, hold on. I cleared the screen but did not refresh, and I tried to redeclare that array variable. So let's try again. So 1, 2, 3, 4, 5, 6. And what if we wanted to remove that string from there? So all we'd have to do is array.splice, and then we want to specify that we want to start at the index of 3. So this is 0, 1, 2, and then 3. So we want to start at the index of 3. We want to remove a single element, so we just want to put in a 1 right there. And then at the end, we can put in, let's say, what we want to replace it with. So in this case, we want to remove this string and replace it with something. So maybe something in between. We'll put 3.5 or something. All right, so it returns the item that was removed, and now our new array has the replacement value in there. So at this point, I think it's a good time to just briefly mention the fact that we are mutating this array right here. Now, when we looked at string methods, none of those methods actually modified the existing string. And that is because an array is not a primitive value. Now, a string is a primitive value, and for that reason, it is immutable and you cannot change it. Now, an array is mutable, so that means that these methods that we're using are actually editing the array itself, and you don't have to basically create copies. You could if you use the slice method, though. All right, so the next one that we're dealing with is going to be the find index and index of method. So here's the find index. It returns the index of the first element, so only one, that satisfies the provided testing function. All right, so this is where we start getting into the callback functions that I talked about. So if you don't understand callback functions, be sure to go to that prior part of the lesson here and really wrap your head around those, because from here moving forward, we're going to be dealing with them in pretty much every array method. Anyways, it says if there's no match, so if your testing function does not match an element, you're going to get a value of -1. So we know that if this method returns us -1, then what we're trying to match does not exist in the array. Otherwise, we get the index to grab it from. Now, this is kind of similar, so the find index is kind of similar to the index of method. So if we come down here and grab the index of method, it's just going to return the first index where the given element is found. There's no such thing as this, callback function that matches or anything. We're just searching for a specific string. And again, this will return -1 if that is not present. Now, this is a little bit less powerful, and like I said, callback functions enable reusability. In this case, we just search for a raw string. With the find index, we can specify an entire testing function. So in this case, if you can grasp your head around these callback functions, the find index is going to be a little bit more powerful for you. So let's see if we can come up with a good example for this. We'll use what we got for the index of method. So again, array is equal to this right here. And we could just say array index of, and maybe we want to look for that value of 3.5. And it's going to give us an index of 3. So what we could do here is we could basically say, okay, I want to get that value here, so we can say array, then we can use the bracket notation. We obviously have to pass in an index, and then we can find this index. It's kind of circular here, but I'm just trying to show you how this might be used. And then we pass in there, and now we can actually get the value. So previously we just looked at for the index right here, but now we're actually getting the value returned because we used that index and grabbed it from the array. All right, so that's how you use index of. Now let's talk about how you might use the find index method for a little bit more powerful search. Now, what if you had a more complex array like this? This has obviously got a lot more to it. It's got objects that have two properties, first name and last name. Now, if you tried to use the index of method, so more complex array, and then you used index of, and then you started putting an object in here and typing out first name equals Bob, so on and so forth, you're not going to get a match. It will never match because you can't do that kind of equality comparison. So all we have to do is use the find index. So this is going to return us the index of the first match that we have identified within this array. So let's say that we want to identify we want to identify the first item in this array where the last name does not equal Smith. So that's obviously the last value, and that would be the 0, 1, 2, third index. So we expect an index of 3 to be returned. And what this expects as an argument, if we go to the find index again, you'll see that we need to return a callback, and that callback is going to have a couple of arguments that we can use here. So let's look at this real quick. The callback has an element, so that's the current element being processed in the array. That's not new to us. We have the index of the array. We probably don't need that. And then we have the original array that we're looking at, and we probably don't need that as well. And then finally, we have another argument after the callback, and it says optional object to use as this when executing the callback. We haven't talked about the this keyword yet, so we're not going to worry about that. All right, so we need to pass in a callback. Let's go ahead and populate that with the array item, and that's all we're going to use here. We could have passed in the index in the original array, but we don't need to. And then in this case, since we're searching for anything that does not equal Smith, we can just say where array item dot last name does not equal Smith. All right, so what this is going to do is return us a value of 3, which is the index of the first element that is not Smith, which happens to be this last object down here, John Doe. So you can see how powerful this is as compared to the index of method. There's a lot more things you can do with it, but as I said, this is just an overview of each method. The next method we're looking at is the map method. Now we've already looked at this in the documentation a little bit earlier in this lesson. Let's look at it once more. This was the method we kind of used to prove out the reusability thing. But basically, if we look at the parameters that we can put in here, it says that we have a callback function, and then similar to the previous method we just looked at, we have the this arg, which we haven't covered anything about that, so we're not going to get into it. So basically, if you remember, this is just a transformation function, and it's going to loop through an array and perform a transformation according to your callback function on each element in the array. So let's consider this array right here where we have blog posts from a database, and in this case, all of them are uncategorized. So what if we wanted to return a new array, but in the new array, the category is going to be set to something like web development? Well, all we would have to do is use the map method. Now, of course, you could, type it out and say blog post from database, and then go at 0, and then type in the category and set it equal to something, but that's going to get really clunky and slow. So what we need to do is say blog post from database dot map. Now this is where we pass in our map function, so we're going to pass in the array item. So as we go through each item, the first thing that we need to do is we need to modify that actual property, and then we need to return the item in full. So we'll say array item dot category equals web development. All right, so there we have modified this individual array item's category property, and now we're going to return the array item which has been modified. All right, so we'll press enter, and now you can see this map function returns the following array, and in this case we now have the category updated for all of these properties. So this would be a really useful function to do in the real world, and I've actually used something very similar to this example in some of my apps. So it's super realistic and super helpful. It will save you a lot of time. Next up in our lineup is the for each method, and until this point we've been looking at arrays and looping through arrays in one specific way. So this is how we've been doing it. If we have an array that has a couple values in it, now we write our for loop. So we initialize I to 0. We go until I is less than the array.length. And then we increment I. Then we drop down into the for loop and we're going to do something here. So maybe we're just going to print the element of the array that we're at. So there you go, prints it, and we can do all sorts of stuff within that code block. Now there's another way to write a for loop that we haven't talked about yet, and that is the for each method on an array. So here's how we would do that. We would say array.forEach, and now what's going to happen is we have a callback function that gives us the array item, and then we drop down into the function and we can once again console.log the array item. All right, so that's just a simple way to replicate that array up there. You can also get the index. So if we looked at the documentation of the for each method, it's going to say, here's our callback that we're looking at, and it's going to pass us the current value, and it's going to pass us the index in the original array. So again, this signature right here, the function signature is going to be very similar, if not the same, for pretty much all of these more advanced array methods. So in this case, if we wanted to take this for loop, so let's clear the screen once more. Here's our array that we're looking at. And if we wanted to do the for loop, we use for each. We want the array item, and then we can grab the index. So in this case, we have two things to work with, and we'll console.log, say the array item, and then we will enter down and console.log the index. And you can see that we are printing the value of 1, which has a 0 index, the value of 2, which has a 1 index, and the value of 3, which has number 2 index. So this is really useful, a little bit quicker than our other for loop. Now there are a couple differences, but nothing that we need to talk about right now. You'll find those out as you start programming, and I'll try to point them out within this series if we stumble upon them. The next method that we're talking about is the includes method. So this is going to help you find a single element and determine whether it exists within an array. So there are multiple ways to do this, and I'll show you a couple different ways and kind of prove out why the includes method might be the best in a lot of cases. So let's say that you have the following array. You have my colors. You want to figure out whether the color orange exists within this array using some code. Now there are a couple ways that you can do this, but one way that we can use is what we're basically accustomed to seeing. And we're going to initialize this variable right here. We'll say that it's false. And then if, when we're looping through this array, if any of the colors equals orange, then we set that variable to true. And now we can figure out if orange exists, which should be true. So that's one way to do it. But there is a simpler way to do it with the for each method. So we could say something like this. So we've already got the orange exist variable, and all we'd have to do is loop through it that way, set it to true, and we can say orange exist, and that is going to be equal to true. Now there is a even simpler way, and it's using the includes method. So all we would have to say is my colors dot includes, and then type orange, and it's going to tell us true. That does exist in the array. So as you can see, it's a lot easier to use a method like this than go through all of those for loops and, store the value in a variable and stuff like that. Now, just to connect the dots here and show you that there's a variety of ways to solve problems within coding, you could have also used the index of method. So if we would have said my colors, and then you say index of, and then you type orange, and you return that, it's going to give you an index of 3. So basically, all you would have to say is that statement right there, and you say if that does not equal -1, then our item exists in the array. because if it returns -1, then it didn't find it and we know that it doesn't exist. So that's just another way to solve it, and hopefully you've seen that there are, in this case, there are 4 different ways that I went through, something like that, of checking whether something exists in an array. The next method that we're going to use is filter, and this is probably the most frequented method for me. This is the one that I use the most, probably. I don't know for sure, but this one and map are probably the 2 that I would use the most within my code. Now, the filter method does exactly what you think it would do. It filters out different results. So let's say that you go on Amazon and you go to your orders page. It might look something like this. You know, this is fictitious. It's not actually what their data model is going to look like. But you can see that maybe we have some different properties on our orders array, and this is going to represent all of the orders. But you know, when you go on Amazon, you can click on buttons and filter those orders by date, by whether they're open, whether they're canceled, or whether they're digital. And we can do this with the filter method, which is basically going to return us an array that has been filtered based on a callback function that we provide to it. So with this array, you can see that we have this isDigital property, so we could find all of the digital products. We could save that to an array by saying digital orders, and then we'll set that equal to all orders dot filter. And now this is where we pass in our callback function, which again receives the array item, and then we will pass that in to our function and return anything that is digital. So we'll say array item dot is digital, which is a Boolean. So if it's true, then we're going to return a true value, and it's going to be included in our resultant array. So now our digital orders, if we print that out, you'll see that we have 2 of them, and it says is digital true, so we know that we matched those correctly. Now there's a couple other filters that we could do. We could paste in this and say, okay, we want all of the digital and canceled orders. So we're returning a condition where it says we want to check if it is digital and it is canceled. So in this case, we can print this array digital canceled orders, and we only have 1 of those where you can see is digital is true and is canceled is also true. So this is a super useful method, and it's often used on the front end where you're, like I said, on your orders page on Amazon, and you click the button and it might execute this filter method and just show the user whatever is filtered. So this is really useful. I use it all the time on the front end, and you can even use it on the back end a little bit as well. Now, I saved the hardest for last, of course, because I didn't anticipate the fact that I'd be talking for such a long period of time, but we're going to go ahead and try this anyways. This is the reduce method. So if we look at the reduce method within the documentation, it's going to give us a very interesting callback function. So instead of the array item and then the index and then the original array that we get passed into our callback, it's going to give us some interesting parameters. So it gives us the accumulator, it gives us the current value, and then it gives us some optional parameters here, index and then the original array. And then finally, we pass in addition to the callback, an initial value that we want to initialize this accumulator to. So I'm not going to go through all of these. I'm going to put this into terms that I think we can all kind of recognize. So let's go ahead and paste this in, and this is the code that you're probably used to seeing. So if we wanted to find the sum of this array, so we wanted to add all of these numbers together, this is how we would do it, and this is how we did it in the 25 coding challenges that we practiced for the previous lesson. So in this case, we initialize a sum variable to equal 0. So we start the count at 0, then we loop through our array, and for each element in the array, we add it to the sum using the plus equals operator. And then at the end, we console log the sum, which is going to equal 99, because that's the sum of all of these values in the array. Now, what I want to point out is the fact that this sum variable is essentially accumulating values. So it's basically called our accumulator. So if we go back to the documentation, it shows that the first argument of this callback is the accumulator. So you can think of this as our sum variable that we just wrote right here. So what I'm going to do is right below here, I'm going to rewrite all of this code, but using the reduce method. So the first thing I'll do is write our reducer callback function. And what this callback function is going to do is it's going to accumulate the value. So if you look at the documentation, it's going to first take this accumulator parameter, which is basically going to act as this sum variable right here. So up top, we defined it like outside of the for loop, but here we can just pass it in as a parameter to the callback. And then we have an array item, so that's going to be another parameter. And we have others, but we don't need them. So let's go ahead and just use this. And now what we're going to do is we're going to return a value. So we always return a value from the callback for each array item. And in this case, this sum variable is going to be accumulated over the course of looping over this array. So the reduce method automatically takes care of that and makes sure that that accumulates a value. So all we have to do is say sum plus or equal array item. And what this is going to do is exactly the same thing that we're doing up here, but we're adding the array item and we're doing it all within a callback function. So let's define that. And now we can say that we want our result to be equal to array.reduce. So we're using the reduce method, and we need to pass in our reducer callback, and then we need to pass in one more thing. So if you go over to the syntax, you'll see that we have the callback, which is encompassed in the highlight right here. But then you'll see after that highlight, we have a comma and then another parameter called initial value. And if you come down and read about the initial value, it's basically saying that this will represent the starting value of this sum variable that gets passed in for every iteration. So we want to start that at 0, just like we started the sum up here at 0. And when we press enter and print the result, we're going to get 99, which has done the same thing as our code above. So while it looks very confusing, it is very confusing, you can kind of anchor yourself to this more simplistic code that we've already written and already understand. So that is the reduce method, and the last thing I want to show you about it is how you can use this to basically get the average of numbers in an array. So we went through some practice problems in the 25 practice problem video previous to this lesson, and we had to calculate an average of an array, I believe. And of course there is no average method on the array object. I'm not sure why. It doesn't make a whole lot of sense to me. But you can use this reduce method to actually calculate your own average of the array in just a single line. Here's how you're going to do that. All right, so we're going to say array.reduce, and then we're going to, of course, pass in the sum and then the array item. So we're writing the same thing that we have written already. We're just going to do this in one line. So we're going to take the sum plus or equal the array item. All right, so what this should give us right here is going to be equal to, of course, after we pass in our initial value, that's going to give us the sum of the array. And then all you have to do is divide that total by the array.thelength, and now you have retrieved the average of this array. So that's just a way that this can be really useful, and you might take a second to look at this code and see what it's doing, because it's a little bit confusing as a one-liner like this. But anyways, that's just a really practical example. It's something that I've used before in writing actual code. All right, so that is the end of the most common built-in array methods. Now you might be wondering, well, what happens if I find an operation that doesn't have a method already built for it? And the answer to that is you probably will be using some sort of external library to do that. And the most common one for us JavaScript developers is going to be the Lodash library. So if you type in Lodash and you click here, this is a modern JavaScript utility library delivering modularity, performance, and extras. And if you go to the documentation, you'll see on the left that at the top we have our array data type, and you'll see that we have a bunch of different methods that we can do all sorts of really interesting things with. So we have a limited set of built-in JavaScript objects, but the developers of Lodash have taken it a step further and basically created some additional methods. So if you remember, something that was tough for us is comparing the equality of two objects. So if we go in here and create two objects, so we'll say object 1, and we'll set that equal to prop1 and some value. All right, and then we have object 2, and then we want to just set that perfectly equal to this. All right, so we put that in there, and now if we try to compare them, it's going to say false, and that's going to stay false even if we use double equals. And that's because we can't compare the equality of two objects. And if you wanted to write a function that actually compares the equality of two objects, it's going to take you hundreds of lines of code. But if you use the Lodash library, you can actually look at something. Let's go down here a little bit. And we have this method called isEqual. And this isEqual can actually take two objects, as you see here. So these are basically the example we just came up with. And it checks if they're equal, and it returns true. And behind the scenes, this library is running hundreds of lines of code to make this comparison. And you can see how we can extend our functionality by using external libraries. So let's go ahead and look. If we go to the documentation on MDN, go to JavaScript, go to built-in objects, and go down to the math object, you're going to see that there's a lot of built-in math functions. And as a developer, you might be saying, well, hey, I'm not writing a bunch of finance applications. I probably don't need this. Well, I'll show you in just a few seconds why it might be useful for you. All right, so if we go down here, this is a little bit different than we're used to seeing. So if we come into the console and talk about like dates or something, we know that we can make a date by saying new date. All right, so that's the syntax that we're used to. It's called the constructor syntax because we are constructing a, copy of this date template or the object. I mean, these are all terms that I'm kind of using in quotations because they're not perfectly true, but you kind of get the point. All right, so this is the way of constructing an object. Now with the math library, you'll see that all of the methods, we're just taking the actual object, so we're saying math, and then we're just executing the method against it. So instead of saying, let's say my date equals new date, and then we say my date dot get date or something like that, we are first constructing the object and then using a method on it. And this is how we've done it with all of these. So you might say, well, why don't we say math equals new math, and you press enter and it's going to say math is not a constructor. Well, this gets us into the concept of object-oriented programming. The math library actually has, rather than instance methods, so with the previous ones, with the date object and the string and the array, we have to first construct the actual object, and then we call methods on top of that object, which are called instance, because we have an instance of that object and we call methods on top of it. Now with the math library, we're just using static methods. So we just call it directly from the object, and it's pretty simple. So let's just go through a couple of quick ones that you might find useful. So let's see what my list shows right here. So let's clear the screen. And here are some of the common ones. So we have math.py. That's going to give you the value of pi. We have math.e. So this is, I think, Euler's constant or something like that. That might be something that you use. And then we start getting into the methods. So we have the absolute method. And we can actually pass in a negative number and get a positive or absolute value of that. We also have the math.ceiling method, which is going to round up to the nearest integer. So let's say that we pass in math.py. We're going to round 3.14 up to the nearest integer of 4. Likewise, we have the floor method. So we take math.py again, and it rounds it down to 3. And then finally, we have the math.round method. And again, if we put in math.pi, it's going to round it to 3 because 3.14 is closer to 3 than it is to 4. All right, so those are some quick methods that you can use. You can also use the min and the max method. So if we had min, you can pass in a couple numbers, and this is going to give you the smallest number. And then, of course, max will do the opposite. So same numbers, but we get the highest number. All right, and then the final one is math.random. So this is going to give you a random number, or random decimal, between 0 and 1. Now, this has implications that you probably don't understand, but we've actually used this to get a random index of an array for previous videos. And I'll show you exactly how we can do that. All right, so let's decompose this into steps. So first, let's get a random number and set that equal to math.random. All right, so this is going to equal something between 0 and 1. Let's just see what it equals right now. All right, so it equals 0.97. All right, so we know that if we multiply something between 0 and 1 by another number, it's going to give us a whole number between 0 and whatever number we're multiplying it by. So if we multiply random number times 5, we're going to get a number between 0 and 5. So we can use that to say that we want a larger number, we'll just call it that, and we'll say that will be equal to random number times we'll say 100. So now we get 0 to 100, and then finally, this is going to be a decimal when we look at it, but if we wanted to bring this down to a whole number, we just say math.floor, and then pass in the larger number, and now we have 97. All right, so we can combine this with our knowledge of the length of an array to get a range of random numbers that are within the bounds of an array. So let's just define an array real quick, and we'll just say some values, blah, blah. All right, so we got 4 values in there. The length of this array is 4. So here's how we get a random index of our array. We'll say random index, and we'll be setting that equal to. All right, so we will say math.floor because we know we need a whole number. Now we want to pass in math.random, so a number between 0 and 1, and then we want to multiply that by the array.length so that we can get from 0 to the length of the array, which is always going to give us a valid index. All right, so we will set that equal, press enter, and now we can just take our array and pass in our random index, and it's going to give us a random value of that array. Next up, we have to talk about array types within JavaScript, and we're going to combine that with some of the data types that we haven't quite talked about up to this point. All right, so array handling in JavaScript is something that a beginner is not going to find the value in, most likely. I know I didn't when I first started out. I could not understand why we need to handle errors within our code. But there are some really important implications to this. So if you have an external library that you're calling, or maybe you're fetching data from an external database or something like that, you don't know what the behavior of that external code is going to be. So it could give you an error. Or for that matter, let's say that you're building an app that's similar to, say, Instagram, and your user, who maybe is got some spotty internet at the time, is about to press post on their Instagram photo, and as they're pressing post, their internet goes out. All right, so clearly the code that's going to be run is going to fail, and what we want to do is handle that correctly. So when you try to post and you got no internet, you're probably going to see a message on the screen that says something like, "No internet, please try again when you're connected." Now that is proper error handling because we have detected that something went wrong and given the user a meaningful message for that. Now if we didn't handle errors and we just ran our code and just threw caution to the wind and said hope it works, well in that case when that user posts the photo and the internet goes out, the whole Instagram app is going to crash. So we obviously don't want that to happen. That's a terrible user experience, and that is the value of error handling. Now in JavaScript, there are 3 main types of errors. There are actually more. So if we go to the documentation, JavaScript, built-in objects, and then we go to error. Now this is going to be what we call the base class. This is the parent error type, and within this error type there are several subtypes of errors that we might see. Now there are 3 of them that I consider the most common and you'll probably see the most often, and those are the ones that we're going to talk about here in this video. So the 3 we're going to talk about are going to be the reference error, the syntax error, and the type error. And I'm just going to walk you through a couple situations where you might encounter these and just explain what they are, and then finally we're going to talk about how to actually handle an error in JavaScript. So the first one is going to be a reference error. So let's click on that. And this reference error, it says, is going to represent an error where there is a non-existent variable that is trying to be referenced, basically. All right, so a good example of that is if we don't have a variable defined, but we try to maybe print it to the screen or use it. So let's just define some variable. We'll set it equal to 20. And when we try to reference that by just typing it into the REPL or the console, it's going to give us a value. But if we were to type in another variable and press enter, we're going to say it's an uncaught reference error because another variable is not defined. So when we think of referencing, we're basically trying to find a reference in the computer's memory of that variable. And if we haven't declared it yet, then it obviously doesn't exist and we have a reference or a lookup error. So that's the basics of a reference error. Now a syntax error is the next one. So let's look at that. We'll go back to the main error page, go to syntax error. This is where you're writing invalid JavaScript. So this one's not very hard to replicate. All you have to do is write invalid JavaScript. So let's say that we write an object and we set it equal to this right here. So we'll say prop1 some value and put a semicolon at the end, enter down, and another value and put another semicolon at the end. And it's going to give us a syntax error because these semicolons right here don't need to be there. Those should be commas, not semicolons. So we wrote invalid JavaScript and we got a syntax error because of it. So this one's pretty easy. Now the last one, the type error, this one is a little bit more confusing. So let's look at it real quick. Go back to the main documentation, go to type error. Now it's going to say a type error represents an error when the operation could not be performed because you're doing it on a variable or a data type that doesn't have that operation. So something that you might think is going to throw this kind of error is, I don't know, adding 2 objects together. So let's say that we have object 1 and we're going to set that equal to, I don't know, say 20 here. And then we'll come down and do another object. And this is just totally arbitrary. I'm just making some examples. Now, what if we said object 1 plus object 2? You would think that instead of returning this string with meaningless object notation, we would actually get a type error because we're trying to do something that can't be done. We can't add 2 objects together like this. They're not integers or numbers. When you're going to get a type error is when you're trying to pretty much call a method on the wrong data type. So let's say that you have a number. All right, so we'll set that equal to 20. And on that number, you're going to say 2 uppercase. Now we know from earlier in this video that 2 uppercase is a method attached to the string object, not the number object. So in this case we get a type error because it's not a function. Now this might also happen, we have these objects up here and our property on the object is not a function, but if we tried to call it like we call a function, it's going to give us a type error because prop1 is not a function. So that's what a type error is all about. Now, the last thing that we have to talk about is actual error handling. And as we talked about, it's important because you want to give a user the correct message when they, run into an error, and you also don't want your application to completely crash every time an error happens, because it happens all the time with code. So to do this, we use something called a try-catch block. So the first part, we put the word try, and then we put these two brackets. So we enter down, and whatever code goes in these brackets is going to be checked for errors. And if there's an error, then it's going to throw that error and send it to the catch block. So let's write some code that actually throws an error. So let's say that same example of we have a number, and then we try to make that number uppercase, which is obviously invalid. So we know that's going to throw an error, but because it's within this try block, we're going to pass that error. It's going to be thrown, and then this error is going to be populated with that new error object. So this could be anything. We could make it E, we could make it error or ERR, or we could make it error. It doesn't matter, it's just a parameter like we've seen before. So let's enter down into the catch block, and now we can actually check to see what this error is. Now, I'm not going to just console log it, because then you might get confused, like, okay, what happened? So let's go ahead and actually, first, let's just cheat real quick. I'm going to put a var here so that we can use this code block again. So let's press enter, and you'll see that no errors were thrown here. And the reason is we had some invalid code, but it got caught here, and then we didn't run any code in the catch block. So if we try this again, no pun intended here, we can actually print some details about this error. So let's console.log something where we say error is an instance of, we'll say type error. And in this case, it is a type error because we're trying to call a method that doesn't exist on this data type. And this instance of operator is basically going to look at whatever is to the left of it, which is that newly populated error object, and it's going to say, is this an instance of, or kind of like a copy of the template that we call type error. Now, that's going to hopefully return true if it does what we expected. And then an error actually has a name attached to it, or a message. So we can say error.message and print out whatever that error message is. So you can see that if you looked at the instance properties, we have .message, so that's how I knew how to access that. All right, so we press enter, and now we get the value of true because this evaluates to true, and then this sentence right here is going to be the error message. So you can see that we have handled an error, what we call gracefully. We have not crashed our application, and this is going to come in handy when we're using external libraries that we don't know how they're going to behave. And finally, kind of going along with these error objects, we didn't talk about those much, we also have 3 more data types that we have not touched on. So let's clear the screen and look at what we're talking about. The first one is going to be NaN for not a number. So that's actually a data type. Then we have undefined, or actually let's go with null. We'll talk about null first. And then we have undefined. And you can see if we go to the documentation, we go to the main JavaScript documentation with the built-in objects, you will see that we have not a number right here. So you can see a little bit about that. You can also see if we look at the built-in objects that we have undefined somewhere. So here's undefined, and then finally we have null value right here. All right, so these are all, built-in objects, and like when we're looking at this, the null and undefined, I believe, are primitives. So let me just check that, make sure I'm talking about that correctly. So yes, the undefined and null are going to be primitives, as we talked about a little bit earlier. So let's start with the least common one, which is going to be not a number. So this is kind of something that it's not really used all that often. You probably won't even see it all that often. It's just nice to know about because you may get this response at some point. So basically, not a number is meaning exactly what you would think it would mean. It's saying that something is not a number. So if we had a string and we set that equal to some string, and then we tried to coerce, we've done this before, if you surround a number or like a string value, so let's say that we had this number constructor or whatever, and then we pass in a string, but that string is equal to a number value, this is going to work fine. But if we tried to pass in my string, you're going to get not a number because you can't possibly convert a string like that into a number. So that's where you might get not a number. You also might get it if you're trying to, add that string with a number. That doesn't work either. And then you also will get it if you say my string multiplied by 2, divided by 2, or minus 2. You're going to get not a number in all of those cases. Again, you're not going to see this very often, so I'm just going to move on from here. The next one is going to be null. So unlike not a number, you're going to encounter null values pretty much all the time. And what this represents, how I think of it, is going to be the intentional absence of a value or a placeholder that you put in to a variable. So if you were to define a variable, so we'll say let not placeholder, we'll just say let my number, and then we'll set it equal to null. It says we're redeclaring it because we've already defined my number, so we'll just say num equals null. And we've redeclared this, so I've been typing into this console too much and using the same variables, so let's go ahead and refresh the whole page. All right, so this should work better. We'll say num does not equal 20, it'll equal null. So this is a placeholder value, and this evaluates to a falsy value. So if we say num triple equals false, then it's going to say false because it's not perfectly equal to a Boolean. But we say if num, and then we get into a conditional block. We'll console.log this will not be reached because this will evaluate to false. So this block will be reached. And when we press enter, you'll see this will be reached because we said if num, and num equals null, so it's a falsy value, so this does not get reached. So that's just something nice to know as you're using conditionals. And then finally, we're talking about undefined, which is very similar to null, but instead of being an intentional assignment of value, so kind of a placeholder, this is when you just declare a variable. So let's say we declare a variable called myvar, and we don't assign it to a value. Now, you've probably been seeing this undefined happen within the console, but that's not actually representative of what we're talking about here. So if you were to type console.log myvar, you're going to get undefined, and you're going to get it twice because it always prints undefined within the browser console. But this actually does equal undefined, and if you were to pull up this conditional statement again and you put in myvar, it's still going to print this else statement because you didn't reach this because this evaluates to a falsy value. All right, so that's it for this lesson number 6. It was a very long one, obviously split up into multiple videos. But if you made it here, congrats, and I look forward to talking about some more complex subjects. We're going to try to get a little bit away from JavaScript. But in the meantime, I do have some practice problems for you, and you can continue on to practice some of the things that we have learned within this lesson. We've done practice problems in previous lessons. We did 25 of them. It took over 2 hours to do, and you can check out this video to go to those. Those will be a little bit easier for you. But now in the previous lesson, or lesson 6, I guess it's this lesson, we went through a lot of the built-in objects and then the associated functions for those objects within JavaScript. So we have a much broader understanding of what's available to us, and therefore we'll be a lot better at solving these challenges. So I'm going to walk through each of them. I recommend that you try them out first on your own, and then you can go through my solution. We'll kind of look at some community members' solutions as well. Now, in the previous code challenge video where I did 25 of them, I didn't zoom in, so I made sure to have a nice big screen that you can see. That was a little bit annoying to actually edit that video, so hopefully this will work out better. But anyways, go to the link in the description to get to the collection we're going to be working on. So this is my profile on Code Wars, and if you go to my profile, or no, this isn't my profile. If you go to my profile here, you can come down and you can see the collections. And you can see that for lesson 5, we did 25 problems, and then for lesson 6, we have some challenges. And once you get here, you can click on the Train Now button, which is going to take you into all of these problems that I've laid out for you here on the right, and there's 10 of them. So we'll go ahead and click Train Now, which is going to basically put us in this list and keep us there when we press next kata or whatever that's called. I think it's something that has to do with jujitsu. I didn't know in the previous video, but I think I learned since then. Again, leave it in the comments if you know totally what it means. Anyways, let's get started with our first code challenge, which is going to be list filtering. Now, if you remember from the previous couple of videos, we went through the built-in methods, and one of those was the filter method on an array. So in this case, I would guess that we're probably going to be using that to solve this problem. Now, I haven't seen any of these, or I've seen them, I picked them, but I haven't tried to solve any of these, so we're going to be going in real time. But I think the filter method's probably going to be what we want here. So it says, in this kata, you will create a function that takes a list of non-negative integers and strings and returns a new list with the strings filtered out. So this is a perfect use of our filter method. We'll go here, and as we always do, let's change our parameter name so it's more descriptive. So we'll call this num list, or even better, num array. And what we have to do is basically return num array, and then we want to add the filter method on the end of that. And the filter method, as you might remember, is going to basically take a callback function, and whatever that callback function returns, if it returns true on the individual element that we're looping through, then it's going to keep that in the array. If it returns false, then it's going to throw it out and not include it in the resultant array. So just for the sake of clarity, I'm going to actually break this out into a separate function, and then we'll refactor it so that it's a little bit more concise. So we'll say our callback function is going to take an array item. So that's how all of these methods on the arrays work. They pass in the array item to the callback, and then we're going to return a condition. So in this case, we want to look and see if we have a non-negative integer. So any negative number or string is something that we need to filter out. So we'll say, first off, if the type of array item, which is going to return us with the type of the variable, if that is not equal to a number, which we actually have to put in quotes. So let's go to our little playground here, and if we have a number, something like this, and we say type of 20, it's going to give us number in quotes. And then if we put in some sort of string, it's going to give us string. So we're using that knowledge, and we're saying if the array item does not equal number, then we want to filter it out. And then we also want to add a condition. We can say if it's not a number, or with these two pipes, or if the array item is negative. So how do we figure out if a number is negative? Well, we could just multiply it by -1, and if that turns out to be positive, that's the case, but we could also do something else. So in our callback function, we need to return either true or false, which will determine whether this individual array item that we're looping over will be returned in that final array. So in this case, we have two conditions. So we'll put this in a comment. We'll say our first condition is that it is a number. Our second condition is it is positive. So all we have to say is if the array item is greater or equal to 0, and the type of the array item is equal to number, then we want to return true. Otherwise, we return false here and exclude it. So this little type of operator, we've looked at it before a couple of times. Just to show you what I'm talking about, I have up here, if we say type of string, or put a string in there, it's going to return the value of string, but if we put in, say, a number, it's going to give us number. So that's what I'm doing here. I'm saying if the type of the item is equal to number, then we want to keep it. All right, so there's our callback function. This should work, and all we would have to do is say return numarray dot filter, and then we pass in our callback function, and let's see if that works when we test it. So it does work, but there's a couple ways we can refactor this. The first way is that we don't need this conditional. All we have to do, really, is return this expression right here, which if this expression evaluates to true, we want to keep it, and if it evaluates to false, we want to throw it away. So if we just return the expression, it should work just the same. Now, another way we can refactor this is by taking this entire callback function and simplifying it. So instead of passing it in as a declaration or whatever, we can just define it right here. So we can say array item and then use an arrow function to actually return this. So let's break down onto the new line, and we will return this expression right here. And then we can get rid of this second function, test it again, and we should pass it. Now the last thing that we can do, we don't even need these little brackets here. We can get rid of those and get rid of the return statement, because if we put it all on one line, it should work just fine. So let's go ahead and test that. Looks like we got some sort of syntax error. Yeah, we have this little semicolon at the end, which is not valid. So let's go ahead and test it now, and we're passing it. So that's how you might take this and refactor it to work correctly. Let's attempt the solution, and we pass them all. So we solved this one just okay. So we'll submit it and see what other people have used to solve this solution. All right, let's go down here and let's see. This one did something very similar to us. Looks like they're saying if this is equal to number. So I don't know if they accounted for negative numbers, but maybe there's something about this that does. Down here, let's see. Well, maybe I misread this actually. So I wonder what the instructions were. Maybe go back and see. I guess maybe we didn't need to look for non-negative numbers. I don't know. All right, let's move on. It's not super important. You can go back and kind of look at that on your own. All right, our next challenge is array.diff. So probably getting the difference of an array of some sort. So let's go into the instructions. It says your goal in this kata is to implement a difference function which subtracts one list from another and returns the result. It should remove all values from list A which are present in list B. Okay, so looking at this, we see that 1 is in both of these arrays. So it's going to remove that and leave us with an array of 2. In this one, we have 2 present in both arrays, so we're going to remove that 2 and we're left with 1 and 3, which gives us our result. So that's basically how this is working, and hopefully we can use one of our built-in methods to solve this. So just a fun fact, if you go to the Lodash library, this is something I talked about in a prior lesson, or not a prior lesson, in this lesson in a prior video. You can go to the documentation and there's actually a method here. So we can go to the intersection. The intersection method is going to find what is alike within the arrays, but we're trying to find the difference. So we can go to the difference method right here. So ultimately our challenge is to implement this method, which we can use in Lodash. It's very just kind of an interesting thing to know, and if you start using the Lodash library like we might do kind of later in this series, it will come in handy for this reason. So what we're trying to do is find the difference, and I think the way that we can do this is by using the array.includes method. Let me pull up the MDN documentation. So we'll go to the web docs, go to JavaScript, go to built-in objects, click array, and now we can go down to the includes method, which we talked about in a prior video in this lesson. So this is basically going to figure out if something is included in another array, or if a value is included in another array. So if we were to loop through one of these arrays and then ask, is each value included in the other, and if so, just remove it, then that might help us solve this problem. The first thing I want to do is check for the edge cases. So if you see in the test down here, there's a couple times where the first array might be nothing, or the second array is nothing. And in those cases, we just have to return whatever is in the other array. So let's say that if a.length is equal to 0, then we want to return b. So we want to return the other array. And then we'll say if b.length is 0, then we want to return a. And let's go ahead and test that to see if we got a couple of them right. And you see that we passed one of the tests because it passed in as an argument an empty array. So now we have to actually solve the question of how do we get that intersection and figure out what is actually different between the two arrays. So I'm just going to open this up here to full screen, and then maybe we can put in an example just so that we're anchored to something. So let's put in something like 3, 5, 6, 6, 5, and 2. And then the second array will be something like 3 and 6. So we know that we want to have in the final array, we want 5, 5, and 2. So let's see how we can actually solve that. So what I think we should do is loop through this, one of the arrays. So we'll say a.forEach, and then we have to pass in our callback function, which will do something on each iteration. So we'll say array item, and then we also probably want to grab the array index, and I'll show you why in just a second. So let's drop down into our function here, and this needs to be stored in a result. We could also just return it, but we'll store that in a result, and then we'll return the result at the end of the function. So every time we iterate through this, we're going to actually use each item, check if it exists in the other array, and if it does exist, we're going to remove that item from both of the arrays in each iteration of the loop. In order to do that, we need something that removes an item at a specific index of an array. So let's go on to the documentation and just refresh ourselves on this method called splice. Now this is something we talked about in a prior video of this lesson, but this is going to change the contents of an array by removing or replacing existing elements. So we can remove an element at a start index, and then we can, that's kind of how we're going to solve this. So we'll say that if the array item, or actually let's say we're iterating through array called A, so if B, so the other array, includes the array item, if that includes the array item, then we want to remove it. So I'm going to put some comments here. We have found this element in both arrays. So we know that we need to remove that. So how do we do that? Well, we have to probably get a new array for each of these, and then now we're going to be working with that as that most recent array. So let's make a variable up here for, we'll say current array A, and we'll just set that equal to, I don't know, we'll put a placeholder in there called null. And then we'll say let current array B equal null. So that will be the placeholder that we're going to assign these if we have mutated the array. So now what we want to do is create two separate arrays. So we'll say new A, and then we'll come down here. I'm not done with this yet, but we'll say new B. So we're going to grab two arrays that have these values removed from them. And the way that we do that is basically by saying a.filter. So we're going to use the filter method. And then I'm just going to pass in the name of the item as item, because we don't want to conflict with this right here that we've used in kind of the parent callback that we're using. And then let's go ahead and return this so long as this item that we're looping through does not equal the array item that we want to remove. So as long as item does not equal array item, we want to put that into the new array, and we can actually use this same syntax down here. We just need to replace A with B. So this will be the new array for each of them, and all we have to do here is replace this with our placeholder. So current array A, and I'm actually going to just call this new A just for simplicity, and then new B, and we'll change that here, so new A and new B. And so now each time basically what we're doing so far here is we're looping through every element within the A array, and then we're going to basically create a new array for both of them with only the elements that have not been matched across both of them. So let's see what this is returning. I'll exit out of here. Let's just test it. Looks like we've got something going on here. So let's go ahead and print what the result is before we actually return it. So let's print the result and see what we're getting. So a big mistake that I made that I just realized is that I'm actually modifying the original arrays, and we don't want to do that because that's basically saying, okay, we're looping through through this array, but within the loop we're actually modifying it at the same time, and we definitely do not want to do that. So let's open up the code block once more, and now what we need to do is we need to get a copy of each of them. So we'll say a copy is going to be equal to a.slice, which is just going to create a copy of that array, and then b copy is b.slice. So that's just going to give us two copies of the array. And now what we're going to say is instead of a.filter and b.filter, we're going to do the a copy and the b copy. And that's how we're going to sort through these. Let's go ahead and test that and see if it gets us an answer here. So looks like we're getting undefined for our result, and I wonder why that's happening. So let's see. Oh, that's because, okay, I'm just not thinking here. So we're not going to assign the for loop to a value because it doesn't return an array. It just loops through it, doesn't really return anything. So returning the result is going to not work. So what we need to do is just return either one of these, I believe. So let's see what happens if we console log new A and then maybe return it. Okay, so we're passing more of them now. Let's see. It looks like this sample test, it says if A is an empty array, then we want to return an empty array. So I think I messed that up here. Okay, so here we have the first one empty, so we want the result to be empty. So if a.length equals 0, then we just want to return an empty array rather than the B array. So let's test that. Looks like we passed all of them. Let's go ahead and attempt it. I'm not sure if this is going to pass. It looks like we got some problems if we have negative numbers maybe. Let's see what we're dealing with here. Okay, I think something that I'm doing wrong here is I'm taking a copy of the original array each time, but we probably want to take a copy of the new array that we've created. So each time it loops through, it's going to remove, one of the elements. But if we keep making a copy of the original array, we're going to keep adding back those ones that we removed already. So let's go ahead and instead of making a copy here, I'll expand this out. We'll make a copy of new A and new B. So this should represent the updated array. So how this is working, I just want to take a second to explain this. Let's say that we have the following example. So we have 1, 2, 2, and 3, and then maybe we have 2 and 3 or something like that. So what's going to happen is we start with array A, and we're going to loop through it with this for each loop. So we're saying, okay, we're going down into our code. New A is going to be equal to null to start, and we're going to be taking a copy of that, which is going to give us null. And then we're going to say if B includes the array item, so in this case the array item is going to be 1. So we're saying if this array, B, includes the value of 1, then we're going to drop into this code right here. And if that's the case, then we're going to take new A and we're going to filter it and set it equal to, or we're going to filter the copy and set it equal to new A. So we probably need to initialize this to be equal to the original array. So we'll say, we'll start it with A, and then we'll start it with B there. So now we're starting with the original array, and each time we get down into the loop, we're going to take a copy of whatever has been updated. And each time in the loop, we're going to check, okay, is 1 included in this second array? Yes, it is. So now let's set new A, which was the original array at the beginning, but now we're going to filter out this item that we found in both of them. So now as we go through the second time, it's going to be removing elements. So in the first iteration of this loop, 1 is not found here, so we don't do anything. The second time that we come around, we look at 2, and we see that 2 is included in both of these arrays. So we are going to drop down into this if statement, and we're going to reassign these placeholder arrays with our filtered array that does not include the 2 anymore. So it's going to just have 1 and 3 and then 2 and 3. And then finally we get to the last one. After a couple iterations, we see it's in both, we remove that, and then we assign it to new A and new B. So let's see if this works a little bit better. Looks like we passed the easy ones, and then we passed all of them. So this was a tough question. Like if you look at the difficulty of it, it's 6 KYU, and I once again have not gone through this beforehand. Like I didn't know how to solve this problem before I looked at it. So hopefully that gives you a good idea of how thinking through this works. Like it takes a lot of iterations. It's not something where I'm just like, all right, we're going in and solving it. I know exactly how to do it. You have to try some things. You have to test it. You know, you realize, oh, I didn't account for this, didn't account for that. And eventually you will get to the answer. So this was a really tough one. I would definitely not call this a beginner JavaScript problem, but hopefully you can see in our big solution here how we have used a bunch of different methods. So we used slice, we used filter, we used includes, and we used for each. We used all of these in the same problem, and that's how these built-in methods of JavaScript can really come in handy. And it looks like after solving that, since it was a tougher problem, looks like I have leveled up here. I started this Code Wars thing to make these videos, so that's why I'm not a little bit higher up. All right, enough notifications here. Let's go to the next problem. Looks like we have another tough one, 6 KYU. So let's see if we can solve this a little bit quicker than the first one that we did here. Okay, so let's look at some of the potential inputs. And at the bottom it says, note, all the hashes are pre-validated and will only contain uppercase and lowercase letters, a little dash, and it looks like a period. So that's all that we would expect to see. And then looking at the examples, you see we have a list of objects where each object has a property called name. And as we scroll over, okay, that's all that we're working with there. So in this case, Bart, Lisa, and Maggie. So it looks like we have to put a comma after the first one, probably a comma after the second one if there's more than 3. But in this case, there's 3, so you put the and instead of the comma. Okay. And then in this case where there is nothing in the array, so it's empty, we just return an empty string. So that's a really easy one to start with. I'm going to actually zoom out. This is a little bit zoomed in. I wanted people to be able to see everything, but in this case we're running out of space. So let's go if the names.length equals 0, then we want to return an empty string. And if we test this, we should pass at least one of them for that empty array. So we did that, we got that test case covered. Now we have to actually go through each of these. So let's see how we can do that. We'll probably be iterating through the array with a for each loop, but let's see. Okay, let's try that. So we'll say names.forEach, and then we can say name will be the argument that we're dealing with. Let's put some parentheses in here because we're actually going to need the array index, which is the second argument of the for each callback. And again, if you wanted to see that, if you wanted to actually figure this out on your own, if you go to the for each method, so I go to Technologies, JavaScript, Built-in Objects, Array, and then I go to the for each method, and then you can read all the syntax, and it says the callback is going to have these parameters right here. So it first passes in the current value, then the index of the array that we're looping through, and then the original array. So that's how I knew to add in the name and then the array index. And you could have just called this the array item to be a little bit more clear. So let's break this down onto a new line. All right, so we're looping through, and that's not going to return anything. So we'll probably need to store this in our final string, which will be equal to nothing to start. All right, so we'll loop through. And actually, if this array has a length of 0, then this for each loop is not going to do anything. So we probably could just return the final string, and instead of having this if statement up there, we'll just have this. So let's test that and make sure it works with that empty array, which it does. All right, so back to here, we're basically going to be grabbing the name property. So we'll say name is going to be equal to the array item.name, because we know that the array item is going to be an object, like right here, and it has a property called name. All right, so we have our name, and we just want to add that to the final string. So let's see. We need to first check if the array index does not equal the total names array dot length. So basically what we're saying is that if we're not on the last index of the array, then we want to do something. So if we're not on the last index of the array, we want to take our final string and we want to add the current array item name, which is stored in the name variable that we put right here. So that's going to just add the names, and then of course we need the comma. So we want to add the name. So let's just remove this equal sign, and then we'll say final string equals final string plus name, and then plus a comma and then a space. All right, so that's going to basically reassign that final string and add the names with the commas. So let's console.log the final string as we have it. It's definitely not going to be right, but we'll see what we're getting. Okay, so we have Bart, comma, Lisa, comma, Maggie, comma, Homer, comma, and Marge, comma. All right, so that's kind of what we're expecting here, but now we have to add in the and symbol. And you can see in the last one right here, we've put in a comma. So let's see what this one actually was passing in as a test. Okay, so one mistake that I made, if the array index is not equal to the names.length, remember the length of the array is going to be literally how many elements are in the array, but the array is 0 indexed. So we'll actually never reach the index that is equal to the length of the array, so we have to say the names.length minus 1. And if we test this, we should not see this output here. We should basically skip that one. So you see that we skipped marge this time, so that is actually correct. Now, we'll put an else condition in here, so otherwise, if it is kind of the last element of the array, so in here we'll put the final string will be equal to final string plus the and symbol, and then plus the name itself. All right, so I don't think this is going to work perfectly, but let's test it. Yep, so we're seeing and marge without a space here. So all we need to do is add a space in there and test it. All right, so this looks a lot closer to what we're expecting. So what we're missing here, why it's failing, is because we still have this comma here, and when we have the and symbol, we don't want the comma at the end. So basically, this condition is not going to be correct. So we want to actually identify two different situations. We want to identify when we are on the second to last, and then when we're on the last one. So instead of saying not equal to, let's say equal to. So if the index that we're working with, let's go ahead and expand this a little bit. So if the index that we're working with is equal to the last one, that's when we're actually going to paste in this right here. So we want to put and name, okay? Otherwise, so else if the array index equals names.length minus 2, so the, I guess, third to last, we want to say the final string will be equal to final string plus the name, but we don't want any of the commas going on here. And then otherwise, we just want to return the final string will be equal to final string plus the name plus a comma and a space. So let's try this out and see what we're getting as output. You can see that we're getting a lot closer, so we have everything correct except we need a space right before the and symbol. So let's just add that real quick. Here's where we're doing and. Let's just put a space there and test it again. And now you can see that we're passing most of the test cases. Now we have one down here. It says wrong output for a single name. So if we have a single name, we probably need to just return the name itself. Okay, so we can just cover that in a separate test case. So we can say if the names.length is equal to 1, we're going to just return the names 0.name. So that should cover when we have a single name. So we passed all of them. Let's attempt it. And we passed all of them. So this was another really tough one. Probably not a beginner problem necessarily, but hopefully, again, you see how we're iterating through this and trying out different things until we get to the final solution. All right, so let's submit this one and go to the next. As you can see, someone solved it with the reduce method, which we learned about in the prior video of this lesson, but I didn't think of that, so that's a useful one. And basically, anytime that we're using like an accumulator, so in this case we had the variable called final string, so go back in the video to see that. If you have a accumulator variable followed by a for loop that modifies that, that's always a good use case for the reduce method. I didn't think about it in this particular scenario, but that's always a good use case. This one's very interesting. I'm not going to go through all of these, but be sure to look at them because people come up with some very clever solutions. All right, so let's look at this one. This, again, is a pretty tough one. So I guess we're getting all of the tough ones in a row, and then it's going to get a little bit easier here. So in this problem, it's basically, the name is take a 10-minute walk, and it's saying you live in this city, blah, 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 where the roads are laid out in a perfect grid, and you arrive 10 minutes early to an appointment, you want to go take a walk. You've got an app that generates a little route, and you can go either north, south, east, or west, and each unit is going to be a single block. All right, so we need to figure out if a given array of directions is going to put us back at our original destination and it's going to take exactly 10 minutes, and it says that each block is going to take you 1 minute. So it takes you 1 minute to traverse one city block. So we're basically returning true if it does, false otherwise. And then it says, note, you'll always receive a valid array containing a random assortment of directional letters, and you're not going to receive anything other than north, south, east, or west. So in this case, I think I have an idea of how we might solve this just initially. So let's open this up and say the first condition. We know that if there's not exactly 10 elements in the array, it's going to take us more or less than 10 minutes. So we'll say if walk.length does not equal 10, we're going to return false. All right, so if it doesn't equal 10, we're returning false and not going to the rest of the code. If it does equal 10, then we'll go into the rest of the code and see if it gets us back in 10 minutes to our original destination. Now, in this case, I think what we're going to do is initialize 4 different variables. So we'll say north offset equals 0, west offset equals 0, and we're going to do this for all of the directions. So east offset and south offset. All right, so now we're going to loop through the array. So we're going to use the for each method, and we're going to pass in, instead of array item, let's start learning how to actually name our parameters to be a little bit more descriptive. So we'll say direction, which will represent the direction that we're going to receive. And then we'll go down into the for loop. And for each direction, we're going to set our variables offsets. So we'll use a switch case statement. So we're going to put in the direction in the switch statement, and then we're going to say case, if it equals n, then it's going to be north. All right, so we're going to put a break statement in there. If it is west, all right, and then we'll just put the cases for all of the other ones. We don't need that last break statement because it'll get there no matter what. Okay, so we're going through all of the different cases, and in each one we're going to change the offset. So if it is north, we're going to say the north offset is going to be plus or equal 10. All right, so that's just going to say, or not 10, we'll just say 1. So we've gone north 1 block if the case is north. And we're going to do that for all of these different cases. So we'll say west offset will be plus or equal 1. And then, let's see, east offset plus or equal 1. And then in the last case, we will say south offset plus or equal 1. So if we reach our destination, like if we get put back to our destination, then I think the sum of all of the offsets should net to 0. Or not the sum, you have to subtract them. So the north offset will offset the south one, and then west, and then east. So basically, if north minus south equals 0 and west minus east equals 0, then we know that we have returned to the original destination. So if we go down to the for loop here, we'll say if north offset minus south offset equals 0 and west offset minus east offset equals 0, then we will return true. Otherwise, we return false. Now, in all of these cases, you're going to start catching on that when we just return true in a conditional, oftentimes we can just return the expression itself. So let's copy that, and instead of this complicated block, let's just return the expression itself. All right, so let's break out of here and test it and see what happens. And we passed all of them, so my assumption was correct. You just calculate the offsets. They should net to 0 if you subtract them. And if the left and right offset is 0 and the top and bottom offset is 0, then you've returned to your office or your appointment. So let's attempt it, see if we covered all the cases, and we did. So awesome, let's submit it. Now this one I think was a little easier than the last two that we did, but still required a little bit of thinking, and I'm sure someone solved it in a much more efficient way, so when it loads we'll see. Alright, so the first solution here, pretty much the same thing that we did. So we did pretty good on this one. Alright, once again we have a 6 KYU, so might be a little bit tough, but let's jump in and see. It says write a function called persistence, right here, that takes in a positive parameter, num, and returns its multiplicative persistence, which is the number of times you must multiply the digits in num until you reach a single digit. So I don't understand this fully at first, but let's look at the examples. Alright, so if we pass in 39, it says we do 3 times 9, which is going to be 27, right here. And then you do 2 times 7 will equal 14, and then 1 times 4 will equal 4, which is a single digit. Okay. Now, does it always do positive numbers? Okay, it says positive parameter. Okay, so we know it's going to be a positive number. So we know how to identify whether the solution is a single digit. We basically say, you know, if it is less than 10, it's a single digit. Okay, so we're probably going to go in some sort of loop here to iterate over each new solution. And we might actually use something called recursion. I'm not sure about that yet, but we'll see. So let's see if this works. So we'll say, how do we get the individual pieces of this number though? So let's go, I can't actually remember if you can do this, but let's take a number like 299 and see if we can access individual pieces of it. Looks like you cannot. So we have to figure out how to get the first digit of each of the numbers. So in this case, I probably should know this, but I don't. And in the real world, this is what I would do. I would just open up a new tab and say find, or maybe not find, we'll say get first digit of a number in JavaScript. So this will work, get the second digit of a number. Okay, so looks like we're turning it into a string, grabbing the first digit and then converting it to a number. Okay, so let's put a num equal to 299 and then say num to string. Okay, it gives us 299, and then we can grab the first piece of that and then we will convert that to a number. Now there's a quick way to do this. You could just wrap it around with this number object and it'll turn it back to a number. Or what you can do, this is a shortcut, you can just put a plus sign at the beginning and it automatically coerces it into a number. So this is the pattern that we're going to use. We're going to grab each of the digits of that number and then we can see, multiply them together basically. So the thing I'm curious about is whether we have, okay, so if we have 3 digits here, we have to multiply all 3 of them. Okay, so that's good to know. So it could be up to maybe, 4 or 5 or 6 digits, so we have to do, this times that times that times that. So that's something we have to take into account here. Now, if it's already a 1-digit number, it says to return 0. So let's just say that first. We'll say if num is less than 10, which means it's a 1-digit number, we're going to return 0. And if we test that, we should get at least one of these correct. So if it passes in a 1-digit number, we got that correct. Okay, so the next part, let's see. So what I think we should do here is we should convert the number to a string and then maybe instead of doing what I was showing you over here, converting it back to a number, maybe what we can do is take the string and put it into an array. So let's go ahead and do that. String version is going to be num.toString, and then from the string, what we know we can do is actually convert that to an array. So we'll say array version is going to be equal to the string version, And then let's see, I actually can't remember exactly what we used there. So let's go to the documentation and go to the string methods is what we're looking for. The reason we're looking for a string method is because we're trying to convert this string here into an array. So let's go to built-in objects, string down here, and then let's look through the methods. I know that there's a way that you can turn this into an array. Okay, so it should be the split method. Yep, that's what we need. I don't know why I couldn't think of that, but if we take a string, so let me just use an example. So you remember, we can actually write a string literal. So some string example, and then we can take that literal string and chain a method on top of it because it wraps it in the actual string object that has methods automatically. So what we can do is say split, and then if we just pass in a empty string, it's going to split it by each of the values here, and that's exactly what we want to do. So let's go ahead and see how that would work. So if we say num.toString, so we first convert it to a string, and then we say .split, and we pass in an empty string, it's going to give us each of those numbers in string form. All right, and then from here, we can basically convert those to numbers and multiply them together. A good way that we can do that is by using the reduce method. So if we chain on one more thing here, we can say reduce, and then we can say the accumulator, which is going to be accumulating that multiplication operation, but we have to pass in a callback function. So we'll put the accumulator and then the actual array item or the number. So maybe we'll just pass in num for number. And then now what we want to do is accumulate, so multiply equal. So it's going to take like whatever that's equal to now, and then it'll multiply that by the new number and store that in the same variable called ACC for accumulator. So we'll just do that multiplied by a number, and we get the answer of 162. All right, so that's our solution here. So if we do 2 times 9 times 9, we get 162, which is our answer here. So this is basically what we're going to do, and we can do it in one step like we've done here, but we can also see it a little bit more clearly if I break it out into steps. So let's go ahead and do that. We've already converted it to a string. Now we want it to be in an array. So we'll say split by an empty string. And then finally we want to get the multiplication value is going to be equal to array version.reduce. And then we of course have our accumulator and our number. And then what we want to return from that callback function is the accumulator multiplied, not added, sorry, multiplied by that number. Okay, so that's our callback function. Multiplication value should get the multiplication of all of them. And then we'll say if multiplication value is less than 10, then we want to return true. So you can already see where this one's going. We can just return multiplication value is less than 10. So if it is less, then we return true. Otherwise, we return false. Now, the problem with this is we have to figure out how many times we have to iterate through this before we get something that is less than 10. So we're not quite done with this solution yet. So this, I believe, is where the recursion comes in, and recursion in coding languages is probably the hardest concept that you could learn. So this one, don't beat yourself up if you don't understand what this is doing fully. This is something that took me a long couple hours early on in my journey to fully understand like how it worked. So don't beat yourself up, but I'm going to show you how I'm going to do this, and hopefully it will actually work so I'm not talking a bunch of nonsense here. All right, so for this solution, I had to turn off the camera. I didn't realize that we'd be dealing with recursion here until I looked at this problem. But a trick that you can use for recursion, and just to kind of explain this code just at a high level, and again, you don't need to understand exactly how it's working because recursion is a very tough subject. But basically what we're doing is we, go through this code, which I explained a little bit earlier, and this is going to give us our multiplication value. And then for recursion, where we're, calling the function multiple times on itself, you need a stop condition. Okay, so the stop condition is when multiplication value is not greater or equal to 10. So basically in this else return. And what we're doing here when we say return 1 plus the persistence, what it's doing is this is just a trick of recursion. And if you read up on how recursive functions work in JavaScript, you'll see this notation right here. But basically what we're doing is we know that if the stop condition is met, then we return the value of 1. Otherwise, we're going to keep calling the persistence function until we reach that. So if we add 1 to the return value of each iteration or recursion, then we're going to accumulate a total value of how many times we went through this. So again, this is a little bit confusing. It was really confusing to me. I had to brush up on recursion a little bit to solve this problem. But basically, this is, I think, the best solution that you're going to find for this problem. So let's go ahead and attempt it. We passed all of them, so let's see how other people solved it. Maybe there's a way to do this without recursion, but nevertheless, this is probably the most efficient solution. Okay, so actually the first solution might be more simple than what we used here. So this doesn't use any sort of recursion at all. This is simply using the reduce method kind of as we had used. So we did this exact thing. But it's looping through while the num counter is greater than 1. So, and then it uses this times variable to kind of collect the number of times that we've gone through this. This one right here, this is as concise of a solution as you could possibly get. This is basically what we did. It's a little bit syntactically compressed, so you have a lot of little JavaScript tricks going in here, but you can see where we do 1 plus the persistence function, so we're recursing over it. So that would be the most clever solution, as you can see here. But once again, recursion is a very tough subject. I wouldn't expect any beginner that's watching this to really understand how to do that. But of course, you could have solved it this way, which didn't require recursion like I used. Okay, so we're on a 7 KYU problem, which should be a little bit easier. So let's see if that's the case. It says ATM machines allow 4 or 6-digit PIN codes, and PIN codes cannot contain anything but exactly 4 digits or exactly 6 digits. If the function is passed a valid PIN string, return true, else return false. So this one looks pretty easy. We're going to be using regular expressions here. So this is exactly 4 digits. This is 4 digits, but it's alphanumeric, so there's a letter in here, so it's not valid. So this one should be pretty easy. We can go over here to actually look at these regular expressions a little bit. So let's say that we have a string, and the string is 4 digits here, and then we want to match that against a regular expression of some sort. So if we want to do that, we're looking for numbers between 0 or 9, and we want either 4 or 6. So the way we can do that is we can basically, I think we can just wrap this in a parenthesis and then repeat it with an or. And then instead of 4, we pass in 6 here. So let's see if that works. If we add in one more, it should not match it, but if we add in 2 more, it should. No, so that's not working. We could just separate this into multiple regular expressions because I can't remember exactly how to do this for both of them. So in this case, we're looking for any number, so this will exclude letters automatically, in a quantity of exactly 4. And we could be even more specific by saying the start of the line and end of the line with the $sign. And basically, if we're matching this, then we're good. So if we come up with anything here, now if we put in 5 of them, we're going to get an answer of null. So we know that if we get an answer of null, then it's not correct. So let's go ahead and just write 2 regular expressions. So we'll say 4 digits regular expression is going to be equal to what we just wrote here. So let's just paste that in. And then we can come down here and say 6 digits regular expression and just change this right here to a 6. So we're either matching all numbers in a quantity of 4 or all numbers in a quantity of 6. So we can basically return, if both of these are null, that means that we didn't match either of them, so the answer is false. But if either of them are true, so they have they're not null, then we can return true. So let's say we want to return 4 digits regex, and we actually have to match this up against the pin code, so let's do that real quick. So we'll say result 1 equals, and then if you remember, you can take the string pin number. I'm not sure if it is a string. Okay, so it's passed a string value, so we're good. So we'll say pin.match, and then we'll pass in the 4 digits regular expression. And then we might want to look for result number 2 and pass in the 6 digits regular expression. So here's what we can say. We can say return result1.length is greater than 0. Or no, because if it's null, then we don't have an array that we can check that on. So basically we can say if result1 equals null and result2 equals null, then we want to return false. Otherwise, we want to return true because we matched one of them. So null values default to falsy values. So we can actually remove this and say if not result and not result 2. And you can see that it passed. Now we can simplify this even further. So if we say, let's see, if we just return this expression, can't spell. So if we're saying if both of these are equal to null, then we return false. So let's see if that works. It may actually be the opposite. Yeah, so it's going to be the opposite. Let's see. So all we have to do is reverse this by wrapping it in parentheses, kind of reversing the result. And this time it should pass. So this is a decent solution, but I guarantee you there's going to be solutions that are a little simpler than this, where we don't have 2 different regular expressions. There's definitely going to be a solution where we have a single regular expression that checks for both of them, and I'll point that out when we get there. Okay, so this one would be the best one. The \d represents the digits, so that's the same thing as our brackets and then 0 to 9. And you can see that it's doing the same thing that I was kind of trying to do. I must have just messed up part of the syntax there. But it's just testing against this regular expression. So that's basically the best solution, and this is the one I'd recommend using if you had the time to actually figure out how to write the regular expression that covers both cases. Now this is another regular expression. This one should be even easier because it's 8 KYU. So it says your task is simply to count the total number of lowercase letters in a string. Okay, so let's take one of these complicated ones here and just take it into our little sandbox that we've been using. So I'll paste that into the string and we'll start over with our regular expression. So in this case, we're counting the number of results that we have. So we probably want to pass in the global flag to our regular expression. So put that at the end. And then we want to look for A through Z lowercase letters. And that's basically going to give us our answer, I believe. So if we just pass in A through Z and then we pass in this global, so if we take this off, it's just going to match the first lowercase letter, but if we put it back on, it will give us all of them. So that's pretty much all we're having to do here, and then we just need to count the length of the array. So let's do that. We will just say return string.match, and then we'll pass in lowercase a to lowercase z. We'll pass in the global option, and then we'll return the length of that array. Looks like we failed one of them. So cannot read property length of null. So in this case, there's probably no array that we're getting. Right, so if there's nothing, if there's no lowercase letters, we're not going to get a valid array. And you can see that here. If we were to take out all of these lowercase letters, you're going to get a value of null. So we need to handle that. Instead of just tacking on the length, we have to first check whether it is a truthy value. So let's see how we could do this kind of simply. So we can use a ternary operator to do this. So if we basically say if this is a valid expression, so as long as this does not equal null, then we're going to get put into this part of the ternary operator. So let's go ahead and save the result. So the result is going to be equal to our regular expression evaluation. And then we're going to say if the result is a truthy value, then we're going to return result.length. And otherwise, we're going to return false or something like that. Let's see what it says in the instructions. Okay, so if there's nothing, we want to return 0. So sorry about that. It shouldn't be false. It should be 0. All right, so we passed it this time. Let's just clean that up and attempt it. Cool. So this one was rather simple, a little bit easier than our previous regular expression. And again, as I said in the lesson, you don't need to necessarily know like all of the details about writing regular expressions. It's just good to be able to read them, and that's why I wanted to go through this as an example. So the next one we're doing is going to look at some basic dates. And this one is asking, is the date equal to today? So it says write a simple function that takes a parameter as a date object, or takes as a parameter a date object and returns a Boolean value representing whether the date is today or not. Okay, so this last part is basically just telling us like, hey, there is going to be, the 10th of January and the 10th of February, so you can't just look at the day of the month, which we will look at, but not exclusively. So let's just make a bunch of variables here. So our check day, so this will be the date that we're passed. We can just use the getDate method. That's going to give us the day of the month. All right, so check month is going to be date.getMonth, I believe. We can go to the date methods. So if we go to the MDN documentation, go to built-in objects, and go to date, you'll see that we have the getMonth method, the getFullYear method, and the getDate method. Now you might say getDay, but this is the day of the week, not the day of the month. So we need getDate instead. So this will be day, or this will be month of year, and then this is 0 indexed, so that's important to remember. So January is going to be 0. And then the check year is going to be the date.getFullYear. All right, and then our date today is going to be very similar. So let's just copy all of this code down here. And we'll say today instead of check. And then we'll replace all of this with the actual current date. So today is going to be equal to a new date. That's how we initialize it. And then we can pass this in here in place of the date. So then we just return check day equals today day, and all of the other ones match. So let's just write that out. All right, so it's a little bit of a long expression, but it should work. All right, so we passed it. Now the quickest way to do this, it looks like, is this solution. So what are they doing here? So they're creating a new date, converting it to a date string, and checking if that is equal to the date that was supplied to date string. I actually didn't know that you could do that because this will give you different times, but I guess it matches if you have different times of the day. So let's just try that real quick in our console just to see if it's true. So we'll set A to a date, and then we'll set B to a date, and then see if B equals A, which is false. So if you go, obviously those are not going to be equal because the value of the date is milliseconds since whatever, January 1st, 1970 at midnight. But if we convert it to string, so toString, and then try it with b.toString, that's going to give you a false value too. So I'm not sure what's going on here. Oh, to a date string. Okay, that's where we went wrong. We're using toDateString, so that should work now. Okay, so that equals true. So let's take a look at that method on our documentation. So it says toDateString, which is not one of them that we covered in our lessons, which is why we didn't use it here. But it says this returns the date portion of the date object. So that's basically going to strip off the time and check if it's the same day. So that's a good solution. Didn't think of that, but that's a lot more concise than what we did. This is what we did. We just checked it up against all of the different methods that we had covered in our lessons. All right, so let's go to the next challenge. And this is alternate capitalization. Given a string, capitalize the letters that occupy even indexes and odd indexes separately and return as shown below. Index 0 will be considered even. Okay, so we're going to return basically two strings for each argument here. The input's always going to be lowercase with no spaces. Okay, to solve this, we first need to get this into an array. So we need string to be into an array, and then we'll capitalize them separately, and then we'll combine them back into a string and assign them to different array values. So how that's going to look, let's see. We will say array is equal to string.split, and we're going to split it by an empty string, which will just separate all of the characters by a comma. All right, so if we just did that and console.logged it, here's what we're going to get. Here's our string right here. So we've got all of each letter broken out, and we know that we have to take this array and we need to capitalize it in two different ways. So we'll just say array1 is going to be string.split, and then we will also have array2. And then we're going to loop through these arrays. So array1 dot for each, and we'll say for each item. Then we also probably want the index because we got to figure out if it's even or odd. And then we'll say array2, but let's not do that quite yet. We'll just figure this one out first. So for array1, we want to check if the index is, we'll say, even. So this will be even capitalization, can't spell here. All right, so if it's even, that would include zeros. So how do we find out if a number is even? Well, we could use the modulus 2 operator. So if we came to our little playground here in the console, and we said, okay, 0 modulus 2 is going to be 0. 1 modulus 2 is going to be 1. 2 modulus 2 will be 0, and 3 modulus 2 will be 1. So basically, anything modulus 2 that returns us with 0 is going to be even. Everything else is going to be odd. So that's all we have to do here. We'll say if the index modulus 2 equals 0, then it's even. And for that case, we'll say array 1 at the index that we're looking at. And then we want to set that to uppercase. Okay, so we've got array 1 completed. And let's go ahead and console.log that and see if we did it correctly. And we didn't do this correctly. I don't know what I was actually thinking here. We already have the array item. So we just need to take the item and make it uppercase, I think. Okay, so we have a problem here. We're trying to modify the actual item, which is not going to modify the original array. I just realized that. So if you go to the array methods and go to JavaScript, built-in objects, and go to array, you're going to see, if we look at the for each method, which is right here, the callback function takes the current value, the index, and the array. So we want to actually grab this third parameter and modify it within our problem here. So we'll pass in the item, index, and then the original array. And in this case, we'll take the original array, we'll pass in the index of that, and then we'll set that equal to the item.toUpperCase. So I believe this one should work now. We'll see. And you'll see that we did capitalize the first, so that's even, lowercase on the second, uppercase on the third. So that should be working, and I believe we did that right, but let's check one time. So capitalize the letters that occupy even indexes. Index 0 will be considered even. Okay, so we did that correctly. So array 1 is done. And then we can basically just do this again for odd capitalization. Change this to array 2. And then instead of saying when it's equal to 0, we'll say when it's not equal to 0. And then we just need to return a final array, and we pass in array 1 and array 2, and I think that should get us to an answer. Maybe we did this in the wrong order. Let's see. Oh, I'm sorry, I'm not doing this correctly. So our arrays are split out into individual letters, so we have to convert those back to strings. So let me do that real quick. Array 1 string is going to be array 1 and then join by an empty string, which will, or actually, yeah, I believe by an empty string, which will join them all together. And then we can do the same thing for array 2 string, pass in array 2, and then we will return those like this and see what we get. All right, so we passed them this time. Let's just open this up and review what we did. So as you see, we're going to first take these strings and turn them into an array. So if we go back here, if we have some sort of string and then we say split and we use an empty character, it's going to put it all into an array. Then we go and we loop through that existing array with the for each method, and we know that the callback function that we're using is going to pass the item that we're looking at, the index of that item, and then the original array that we can actually modify within that loop. And we knew this because we looked at the documentation here. Otherwise, you probably would have to do just a regular for loop, which acts a little bit different than a for each. So anyways, we're going through and we're asking if the index is modulus 2 equals 0, which indicates it's an even number. And when it equals an even number, we take our original array, we pass in the index into the brackets to grab the item, and we set that equal to the item itself in uppercase form. And then for the odd capitalization, we just basically do the opposite. If modulus 2 does not equal 0, then we want to make it uppercase. Then finally, we join those back together. So if we go to this array here, so we split them into an array, and then if we add join with an empty character, it just joins them back together to the original string, but we've obviously capitalized a few of them in the middle. So we join them back together and then we just place them in a new array and return that array, and that should give us the answer. Okay, I think this is getting to the end, one of our last ones here, if not the last one. It says, given a number, return the maximum number that could be formed from the digits of the number given. Only natural numbers pass to the function. Numbers contain digits 0 through 9 inclusive. Digit duplications could occur, so also consider it when forming the largest. Okay, so that's a good hint for us to remember. Here's an example. So 3 goes first, 2 goes second, and 1 goes third. That makes sense. That's the maximum number that we could form. Okay. So basically we have to take our number and we have to order it from greatest to least. So I think a good way to do that is we might have to convert it into an array, possibly. So basically what this is asking us to do, if we think about it, all of these numbers are going to be in the descending order, so you have the largest one first. And so basically what this is asking us to do is sort an array, because we know that we can take this number, convert it to a string, and then separate that out into an array. And if we can just sort that array, then we got the answer. But the sort method does not do it correctly when we have numbers here. So let's just type it in to Google. This is just an algorithm, so sort array numerically in JavaScript, and we'll see what the answers are. So it says how to sort an array of integers correctly. And let's see. Okay, so we can just use the sort function. We actually can use it. We have to pass in a callback that will compare the two numbers. So let's see. The sort method takes a compare function. Okay, so I was just reading this incorrectly. So we can take a callback and look at the compare function and return the greatest number. So let's go ahead and do that. Just practice real quick. So let's say that we have an array of numbers, so 2, 6, 3, 1, and we want to sort that. So we will pass in our single num, and then we want to say, let's see, what does it pass into this callback? So let's look. The first element and the second element is what it's going to pass in there. So if we go to our little playground here, it's not just one number, but we'll have the first and second element. And so if the second element is greater than the first, then we'll return true, I believe. So let's see how it did it in this Stack Overflow answer. It says return A minus B, so actually it's the other way around. So if A is greater than B, we return that as true, and then that's going to actually sort our array for us. So let's test that out real quick. We just want to return first minus second, and now we have it sorted in ascending order. I wonder if we take it second minus first. Okay, so that's going to do it in descending order. So we want to do second minus first for our problem here. All right, so the first thing we need to do is get this into a string. So we're just going to try to do this all in one line because it'll help us kind of visualize chaining the methods together. So we're going to return n toString. Okay, so that converts it to a string. And then we want to split it into an array. Now we've got it into an array of numbers here. And then we want to sort it and pass in the first number and second number, and then we want to return second minus first. Okay, and then that's going to give us a sorted array of numbers. So maybe we won't do this. Let's just store this in a result for now, and then console.log that result and see what we have so far. So we'll test that, and you'll see that it prints to the console a descending order of that array. Now we know that we can take an array of numbers and we can actually just combine those together with join. So maybe that's all we need to do. We just, at the end here, so hold on one second. Let's return this again. Or no, let's not do that. Let's keep it in the result, and then at the end here, I'm going to break out for a second, and we can actually put these down onto separate lines. So we'll say dot split, dot sort, and then the last thing that we want to do is we've got it in the descending array, so then we can join it back together as a string, and that's going to give us one big number, and then we need to just convert that to a number, and all we have to do is add a plus sign at the beginning to do that. So now let's see what our result equals. Looks like we're getting the correct number here. So all we have to do is return this result now. So we don't even need to store it in a variable. We can just return it, and let's see how it works. Looks like we passed everything, and again, this is just some indentation. It doesn't really matter how you do this. We're just chaining all of these methods together, and you could certainly have broken that out into separate steps. So let's attempt it. Looks like we passed everything, and see what others use to solve this problem. Okay, so this person did not pass in a sort callback. They just passed in no function whatsoever, and that's going to default to ascending order, as you saw up here. So it says the default sort order is ascending. So here they're going to split it into an array, then they're going to sort it to ascending, then they're going to use the reverse array method to make it descending, and then they're going to join it together and then wrap it in a number, which we did by adding the plus at the beginning of the entire expression. So you can see, I believe, yeah, this one right here is the exact solution that we used. So pretty good. I'm pretty happy with that one. And with that, I think we are done with these problems. Hopefully you learned a little bit. I know some of these were more complicated and challenging than you would expect for a beginner, and certainly when we talked about recursion there for a little bit, that's getting a little bit over the pay grade of someone just starting out. But it is an important topic to explore and kind of understand. It definitely will come up in some sort of coding interview if you're doing those. But yeah, hopefully you enjoyed this. If you care to drop a like on this video, I'd really appreciate it. Subscribe to the channel for future lessons. And hit me up on Twitter. I'm at ZG_dev. Tell me what you thought of this video and how the challenges went for you. All right, so I will see you in the next lesson. I believe that is lesson 7. Congratulations on making it to the end of this course. I know it was long, I know it was challenging, but hopefully you learned something. And if you did, be sure to give this channel a subscribe and like the video. It really helps me out. If you want some next steps, as you probably will, this is only the beginning. I've left some resources in the video description, so be sure to check those out.